Hi, my name is Tia Williams and I'm Director of Content Production here at A Cloud Guru. As you may have heard by now, A Cloud Guru acquired Linux Academy in December of 2019. This has allowed us to combine the best of two first-class learning platforms and expand the catalog of courses and features available to you. This course was originally published on Linux Academy. As we integrated features across our platforms, we tried to be as uniform as possible so you can find the tools and features you expect easily. You'll find that although the look of the site is different, Cloud Playground, Cloud Sandboxes, hands-on labs, and more are where you expect them to be and largely look and feel the same. As we continue on this journey together, we'll continue to publish all new courses and labs on both platforms to be sure all of our students get the best of both worlds. Eventually, everyone will use a single site as we continue our integration. Keep an ear out for updates via our announcements, social media, and email over the coming months. We want to welcome everyone to a brand new world where a combination of our platforms gives you access to the most effective, hands-on, and comprehensive cloud learning catalog around. Thanks for watching, and we wish you the best in your learning journey.
Hi everybody, it's really great to have you with me for this course where we're going to focus on how to implement management and security solutions within Azure. And this is actually one of the courses within the AZ-303 learning path as well, which I'll talk a little bit more about shortly as well. So throughout this course, we're going to focus on a few different topics. Firstly, we're going to cover off governance. So if you're working with multiple subscriptions, or maybe you're just working with one subscription, how do you set that up in a way that is organized with structure and boundaries so that you can maintain your security, so that you can maintain costs, and so you have clear ownership and organization as well. This is where we're going to focus on services like Azure Policy and role-based access control. Once we have our environment up and running and configured with governance the way we require, we can then take a look at network security. So how we're going to use things like load balancers to securely distribute information across resources within our solution, or how we're going to secure the network edge with things like Azure Firewall. So within this topic, we'll focus on services like Application Gateway, the Load Balancer, Azure Firewall, Traffic Manager, and many more. Next, what I want to talk to you about is application security. You can see that what we're doing throughout this course is we're building the different layers of security within our solution so that we can have defense in depth. So to learn more about application security, we're going to focus on services like managed identities or even Azure Key Vault to securely store application secrets and information. And finally, to wrap things up, what I want to talk to you about is workload management. This is where we learn more about how we can perform migrations to Azure, whether that's servers, databases, or so on, how we can implement disaster recovery for our solutions, and how we can even manage those solutions once they're in Azure. So if those are the topics that we're going to cover, well, what can you really expect in terms of lessons and content? Well, just bear in mind that this course is focused on implementing Azure solutions. Okay, so it's going to be a very hands-on experience. However, with that being said, this is a solution architect-oriented course as well. So it's not just about hands-on, it's about what purpose do these different services actually serve? When would we use one service over another? What are the key limitations, constraints, and features of the different services that we'll cover? But yes, it will be very hands-on, so you can expect to use things like Azure PowerShell, Azure CLI, and the portal, and so on. And to get the most from this course, I really will expect that you have experience working with a range of Azure services as well. So this shouldn't really be your first Azure course. At a very bare minimum, you should have either completed the AZ-900 Azure Fundamentals course or have that experience already. And we are going to work with things like Azure Identity and a range of different networking services, so I do expect that you have that knowledge as well. If you haven't completed the first course within the AZ-303 learning path, then I would encourage you to either check that out or make sure that you are familiar with the basics like implementing virtual networks, virtual machines, storage accounts, and so on, the core infrastructure fundamentals. To help ensure that you can get all of the knowledge and skill that you require from an architectural, design, and implementation standpoint, we have a range of content here that is going to be available to you. First and foremost, of course, there will be video lessons where I'm going to walk through the services. We'll use Azure CLI, PowerShell, the portal, and so on, and we'll perform hands-on tasks to actually get familiar with a range of different services. And I also will include a range of different hands-on labs. And if you'd like to quiz your knowledge at the end, I have included some flashcards for this course as well. Now, I've mentioned a couple of times about the AZ-303 learning path. So what is it? Well, just understand I've got another lesson coming up shortly where I'm going to talk more about the learning path itself. But this course is actually the second course within a series of courses that focus on the AZ-303 exam. So within this course, we're focusing on implementing management and security solutions. But I do actually expect that you have that knowledge from implementing and monitoring core infrastructure as well. And if you're going on to take the AZ-303 exam, I will have the other courses to cover the core syllabus items from the AZ-303 exam. Now, you don't have to be taking the AZ-303 exam if you'd like to just learn more about management and security solutions within Azure, then by all means, feel free to take this course by itself. If you are interested in taking the AZ-303 exam, then understand that doing so actually earns you the first part of a two-part component in achieving your Azure Solution Architect Expert exam. So if you take this course as part of AZ-303, you can go off and take the AZ-304 exam as well, and that will entitle you to become a certified Azure Solution Architect Expert. So folks, whether you're taking this course by itself or as part of the AZ-303 exam, I am really happy to have you here with me. Please do feel free to reach out with any questions, comments, or concerns. I'm happy to be here to help you on your learning journey. I hope you enjoy this course, folks. Thanks for being with me. I'll see you again soon. Hi everybody, in this lesson I wanted to quickly have a chat to you about course support and feedback. Now, when each of us go on our learning journey, sometimes it can be easy and sometimes it can be hard. So I did just want to let you know that there is a range of support tools available to you to help ensure that your learning journey can be as smooth and successful as possible. We are all here to help you achieve your learning goals and dreams. So let's have a chat about some of the different tools available for you to support you on your learning journey. Now, for each of these different tools, I'm going to include some additional information, some links for where you can actually access community, support teams, and even contact us directly if you need to. First things first, with the community, if you'd like to just reach out to your fellow students or even to the training architects, then you can jump into the community forums and you can ask questions, you can share your tips for success, you might even want to celebrate an exam that you've recently passed. The community is made up of students, training architects, and even members of the support team to help ensure that you can get access to everything that you need to be successful. Now, if you have a question that is about something that is going wrong, okay, maybe you have a lab that isn't working, or maybe a lesson that isn't displaying properly, then this is where you can reach out to our support team. We have a team of dedicated technical professionals that are available to help you promptly resolve any of the issues that you might face. So if something is broken, then you'll find that you can access that support far more readily through the support team than perhaps if you reached out via the community. Lastly, maybe you just actually want to reach out to me directly about a specific question, or you'd like to have a chat about advice in your career or in your learning journey, then do understand that I am absolutely here for you. I'll include my contacts below, and if you'd like to reach out to me directly, please definitely feel free to do so. The last thing I did want to quickly mention is that of feedback. I definitely appreciate your feedback, whether it is positive or whether it is negative. I find all of that feedback really important and it is very much welcome. So feel free to reach out to me and provide me with any feedback that you would like. Okay, everybody, so that's all there is to it for course support and feedback. Now just remember, a really key takeaway from this lesson is that we are here to support you on your learning journey. Whatever we can do to help, please feel free to reach out and we will do our best to help you. So thanks very much, everybody. I look forward to working with you throughout this course and beyond. Hi all, my name is James Lee and I'm a Microsoft Azure Training Architect with Linux Academy. Over the last decade, I've worked my way up the ladder in IT, starting on the help desk and ultimately becoming a solution architect and IT consultant. Now, I've helped a range of organizations, including startups, large enterprise, and government. And I've been really passionate about helping these companies truly harness and get real value from Microsoft Azure, Office 365, and modern workplace. And as an IT consultant, I've worked with several technologies and earned certifications across Microsoft, AWS, Citrix, and VMware. And I'm really looking forward to help you do the same. When I'm not working on training material, I love spending time with my wife and 2 kids, or reading sci-fi and fantasy. and playing games on the computer when I get a chance. So hey, reach out to me on social media or in the Linux Academy community. Let me know what your favourite book is or what Microsoft technology you're most excited to learn about. So thanks everybody for your time, and I look forward to working with you all. Hey everybody, welcome to this lesson on organizational structure and management. Within this lesson, we're really going to focus on two main things. What is the resource hierarchy within Azure, and why does it matter? And how can we use something called resource tagging to capture additional important information for our own benefit? So let's jump in. First things first, what we're really talking about here is taking control of our environments. We know that when we work with cloud, whether it's Azure, AWS, or Google, it's really easy to go in and create virtual machines, web services, machine learning, database services, a range of different technologies, and you can build them very easily anywhere in the world with a few clicks of the mouse. Now that's great, that's really powerful and it helps us to have agility within our business. But the flip side to that is it's really easy for things to get, quite frankly, messy and out of control. So within this lesson and within the other lessons within this section of the course, we're going to be focusing on services and structures and techniques that we can use to help us get better control over the organization of our resources so that we know that we have security implemented, clear accountability and ownership, and at the end of the day, appropriate billing and cost management as well. So why does this stuff really matter? I know it can sound like a little bit of a boring topic to discuss. Let me tell you about a quick scenario. In my time consulting as an Azure solution architect, I've worked with a number of organizations who have migrated their internal infrastructure across to Azure. And a really common story was that the first operation they wanted to do with the cloud, the business wanted that to be small. They didn't want to migrate everything off to start with. They wanted to start with a small operation. Maybe it was an aged piece of infrastructure that they needed to migrate to Azure, or maybe it was a really urgent new solution that they needed to build quickly. So what really commonly happened was that organization would jump into Azure, for this example. They would build up that solution. Maybe they've got a third-party team, or maybe it was the internal IT team that did so, and very quickly they're up and running. However, if you fast forward 6 months from that point, and that's often when we were called along to help out, things had actually changed quite a lot. No one was clear who owned the solution that was built in Azure. Billing was not really clearly being taken care of. Definitely monitoring was not being taken care of. You have maybe an IT help desk team subscription. Maybe you have virtual machines running there that you didn't know about. Someone from the development team in your office has gone to test a new solution. You've got web apps that are running. No one knows who owns all of the different resources. No one knows who should be paying for it, and no one knows if they can be deleted. So why does all this matter? Well, what you really should do is for your first step when you're working toward an Azure solution, you want to take a look at all of these different requirements so that you can go about setting up all of these boundaries and these policies so that when you jump into Azure, you know you're going to do so in a controlled and secured way. So within this section of the course, we're going to focus on all the different tools and tricks that we can use like Azure policy, role-based access control, and so on. But first things first, let's have a chat about how we should structure our environments in terms of the Azure resource hierarchy. So we know that when we first move to Azure, we're going to have an Azure Active Directory tenant, and this is where we're going to store all of our identity, users, security groups, registered applications, and so on. After that, we associate our Azure Active Directory tenant with one or more subscriptions. And it's really popular for organizations to have multiple subscriptions, and it does serve some important benefits. So for example, you may have a subscription that's dedicated to a specific geography, maybe a specific business unit, or even different departments or different environments like production, development, and so on. Because remember, we have these different requirements for our organizations, these different policies and standards that we want to enforce. And so it's important that we actually design our subscriptions according to different policies that might be required. Within our Azure subscriptions, we of course then have the resource groups and the underlying resources. Why this all matters is because, as we're going to see through upcoming lessons in this section of the course, we can assign different policies and different security controls at each of these different layers. So for example, we can impose security restrictions at the subscription level, and that's going to filter down to the resource groups and the resources as well. We might also just use our subscription as a billing container, because we know that if we have a single subscription dedicated to a given purpose, that all of the costs associated with the resources in that subscription can be associated to a different department, business unit, environment, or so on. Similarly, when we work with resource groups, these are a great way to apply security and billing controls as well. It's really going to be up to you how you design this. Again, I've worked with companies that have had this based on geography. Business units is a really popular one. For resource groups, that's largely going to be based on the life cycle of the solution that you're building or the actual purpose of the solution. So for example, you might have a resource group that's dedicated to a finance web application. But you might also actually mix and match. So for example, you could have a resource group that's dedicated to all of the core networking for your given subscription as well. Just like with subscriptions, we can apply security at this level, and security can filter down from the resource group to the resources involved. And we're going to see that in an upcoming lesson on role-based access control. So let's actually just really quickly jump across to the Azure portal and see how this might actually look. Okay, so you'll see I'm logged into the Azure portal, and I've already got a couple of subscriptions for this fictitious company called JazzLab. I have a production subscription and I have a development subscription. And again, within each of these subscriptions, I can apply important things like access control, and I have nice access to billing controls and billing analytics and reports as well. What we're also going to see in an upcoming lesson is it's at this level that we can apply things like Azure policies, which are going to go about enforcing business conventions and standards as well. So that's the first layer. Next, if we browse into the resource groups, we know that this is another way that we can actually contain our solutions, and we can control security, and we can monitor billing as well. So you might have resource groups dedicated to networking, maybe dedicated to projects. It's really up to you how you choose to do that. If we browse into the development subscription, you might have different naming conventions and different resources that are dedicated to the development environments as well. So if we've got these subscriptions, resource groups, and resources, and we can name them and structure them in a way that suits our organization based on security, billing, and things like policies and so on, then what if there's other information that we want to capture as well? What if this naming convention that we use and the structure that we use doesn't actually capture all of the information that we want? Well, this is where we can use something referred to as resource tagging. So let's have a chat about that now. For resource tagging, what we're talking about is capturing custom information in a name value text pair. And we're going to see what this looks like shortly. So if we want to capture additional information for our resources, we need to understand where we apply these tags. We can apply these tags to resources. So we might capture information like the environment, the owner, or so on. We can actually also apply tags to resource groups. Maybe we want to capture additional information about what project this relates to. And at the highest level, we can apply tags to a subscription as well. Now, when we're applying these tags to different resources, it is important to know that not all resources currently actually support tagging. But for those that do, we can use them in a variety of different ways. As you've seen here, it might be to capture information about the environment, projects, business regions, owners, and so on. It's really up to you how you want to use this. But it doesn't have to just be for capturing information. It can also be for cool things like monitoring, automation, cost management as well. So for example, we might require that all of the resources within our subscriptions are tagged with the owner. And then what we can do is we can go into Azure Cost Management and we can break down the different resource costs based on that tag. So you can see already how that can be helpful. But let's also think about maybe virtual machines within our development subscription. What if we didn't want those virtual machines to be running at nighttime? Well, you might actually go and create a tag that is going to have a tag name of shutdown, and it's going to have a tag value of something like 7 p.m., 9 p.m., or whenever you want that virtual machine to shut down. So let's jump into the Azure portal and see how tagging works. So for example, you'll see here within my development subscription, I have a resource group called Finance Web. I'm going to navigate into this resource group, and you'll see that here we have a virtual machine within our Finance Web application. Now let's say that for this virtual machine, we did in fact want it to stop and start at a specific time. This is where we could use something like tags, and then we could have an Azure Automation Runbook that's going to search our entire subscription for those tags, and it's going to stop that virtual machine at a given time. So let's browse into the virtual machine. And what we're going to do next is browse into tags. And then you'll see we can go ahead and get started creating our tags. Now we might just type something like automation _ shutdown, and then at the other point we might put the time. So let's say 1900 in our example. Okay, but really whatever you want to put in here, it's up to you. It's really versatile. How you're going to use it, what information you capture, that's all up to you. So again, we could have something like environment, for example, and that is obviously in this situation going to be development. Once you've created your tags, you can go ahead and click on save, and that's it. Nice and easy. Now our virtual machine, our resource within a resource group, has 2 tags associated with it. You'll see what we're talking about here is that key value pair, a name for our tag and a value for our tag. And we can use that however we want. Okay, folks, so that's a wrap for this first lesson on organizational structure and management. Now, again, I do appreciate that this can be a little bit of a boring topic to start with, but just understand when you are architecting solutions within Azure, when you are going to manage solutions in Azure, these building blocks that we're talking about can be really, really important because you don't want your solutions to have unmanaged cost, to have bad security, and to get that resource sprawl where no one knows what's happening within Azure, and then the finance teams start to get really mad with different people. Or maybe even your security teams are getting mad because there's been a security breach, and no one knows who owns what and what purpose it actually serves. So throughout the upcoming lessons within this section of the course, we're going to build upon these concepts. We're going to take a look at those different Azure services like role-based access control, Azure policy, and more. And we're going to use these and we're going to apply these at different levels of the resource hierarchy that we've just discussed. So thanks for your time, folks. I'll catch you in the next lesson. Hello again, folks. Thanks for joining me for this lesson. Within this lesson, we're going to chat about Azure Management Groups, which is an extension of the previous lesson where we're going to take a look at how we can further organize and structure our resources within our Azure environment. Specifically with Azure Management Groups, we're talking about structuring multiple subscriptions. Okay, so really this is about how we can efficiently manage subscriptions when we know that quite commonly we're going to use multiple subscriptions depending on our own needs. That might be region-based, it might be department-based, or it might be environment-based like we spoke about before. With management groups, we're looking at how we can actually structure that and group them so that we can actually better leverage them when we use things like security with Azure Role-Based Access Control or organizational standards when we use things like Azure Policy. So what we're going to be able to do is build the hierarchy that works for us, again, whether that's geographically based, whether that's environment based, department, business unit, and so on. But we know that we want to actually be able to enforce policies and standards and security as well. When we use management groups, it provides us a more easy way to actually apply these policies, apply these role-based access controls for security, and have them filter down to subscriptions that logically matter to us. So when you think about traditionally what we would have done, we would create subscriptions that match our need. And if we wanted to apply policies or security controls, we would have to go to each of those subscriptions and we would have to apply each of those different configuration items on a per subscription basis. Well, with management groups, this allows us to do it more centrally. And we're going to build upon this as we move throughout the lessons on policies and role-based access control as well. So first things first, how do we actually configure these management groups so that we can benefit from the efficiencies that they provide? Well, the first thing we need to create is referred to as a root management group. And actually, when you start using management groups, this group is created for you. It's at the very top of the hierarchy, and it is established for you by default. What we want to do after that is we then want to create the resource hierarchy that is appropriate for us. Currently, when we're using management groups, we can actually go to 6 levels, but we have some different restrictions. So for example, let's say that we've started to use management groups within our environment. That's going to establish a root management group. And then what we want to do is we want to create some management groups based on the global region, Asia Pacific, Europe, maybe Americas, or so on, that matches our actual organization. Okay, this is more of a logical representation of what our organization is going to look like. Because maybe then we have different subscriptions. For example, in Europe, we might just have something simple like production and development. Maybe we've actually also got a subscription that is corporate, that is used across the globe. You'll see that we can have these different subscriptions, and we know that that helps us with billing and security isolation, but we do still want to be able to apply policies that reflect what we actually work with in the real world. This is what Azure management groups allow us to do. So just understand that when we create this hierarchy, and we're likely going to do so based on our own organization, that we have some restrictions. One management group is actually allowed to have multiple children, as we refer to them. So as we see here for Europe, we could have multiple subscriptions, and we might even actually have another management group there as well. However, for each of our subscriptions or our management groups, you can only have one parent. So how you're going to use this really does depend on your organization. I think personally it would be great if we could have nested management groups, but that's not how these are to be used. The management groups are really to mirror your own organization so that you can apply policies and security matching your organization. Now, as we'll see when we move throughout the lessons, what we're really talking about here is Azure policy for organizational standards and conventions and role-based access control. Within this lesson, what we want to focus on though is how we create these management groups and what they look like within the portal. So let's jump across to the Azure portal now and take a look. Okay, you'll see that I'm within the Azure portal and I've navigated into the management group section. Now to do so, you can actually easily browse up to the search bar at the top and type in management groups, or you can browse through the all services section if you prefer. You're not going to start by clicking on the create a resource option, which I know might seem the normal way to do so. You're going to navigate into the service, and then you're going to click on the start using management groups option right here. Now just understand that when you do so, you actually need to have global admin privileges for your Azure Active Directory domain. Remember, this is something that's going across multiple subscriptions. So to have the privileges to configure management groups, we're talking about Azure AD permissions, not Azure subscription permissions. So let's go ahead in this example. And what I'm going to do is I'm going to create a new management group, and I'm just going to call this Asia Pacific. Now, the first management group ID that we have is something that can't actually be changed after you've created it. So you have another element here referred to as the management group display name. So for this one, I can actually put something in more meaningful, or at least a little bit more pretty if you like, and we'll have Asia Pacific there. Okay, what I'm going to do is I'm going to go ahead and click on save. And then since this is the first management group that I'm creating, it can actually take some time to create. If you do get an error about permissions, just remember that you are going to need to have Azure AD Global Administrative Access, so make sure that you have that within your Azure Active Directory tenant. In my circumstance, that's jazzlab1.onmicrosoft.com, and I already am a global administrator. Okay, perfect. So that has actually created. That was pretty quick. And what you'll see is that what actually happens to start with is we actually get the view of the tenant root group. And everything that you create from now on, everything that you associate with these management groups, you're always going to see for the tenant root, because the tenant root is at the very top. It's kind of known as the parent, if you like. And any permissions that we apply to the tenant root level are going to filter down to all of our management groups and all of our subscriptions. Remember, this is like a resource hierarchy, just like a tree, just like in the icon you see here for this service. So I have my 2 subscriptions and I have my newly created management group. What I might want to do in this example is actually add the production subscription to the Asia Pacific management group. So let's go ahead, click on that management group. And then what I'm going to do is actually click on the details option here. Now, personally, I find this interface a little bit unintuitive, but once you get the hang of it, it's actually pretty straightforward. So I'm in the Asia Pacific management group. I can click on details, and then we get more information about this management group itself. So if we want to add this subscription to this management group, we're going to go ahead and click on the add subscription option. So let's try this out. I'll click on add subscription. I want to go ahead and choose my production subscription, and I'll choose save to get started. Okay, so there you have it. The subscription has been added to the management group. Now, just understand that if you are following along at home in your own environment and you're watching this lesson and you're completing these steps yourself, if you've only just created the management group, adding a subscription to that management group might actually fail. If that does actually fail and give you an error message, then just wait 5 minutes or so and try again. So what you'll see here is that we now have this management group, and within that we have a subscription. We could, if we so desired, actually choose to create another management group and have that belong to the Asia Pacific Management Group itself. So it's really up to you in terms of what type of hierarchy you want to have. But understand that it's at this level that we can then actually go and apply Azure role-based access control, security, or we can also apply policies using Azure Policy. And you'll see there's actually a little bit of cost analysis we can get breaking down the different resources within the subscriptions associated with this management group. So this is really the key goal of management groups, to be able to create a hierarchy that matters to you, that represents your actual real life organization. And we use that with role-based access control and Azure Policy. Okay, folks, so that's a wrap for this lesson on management groups. Just a quick introduction to how we create them and why we would use them. And as we're going to see throughout the upcoming lessons, this is where we can actually apply different controls as well. So thanks for your time on this one, folks. I'll catch you in the next lesson. Thanks for joining me for this lesson on role-based access control, or RBAC for short. Within this lesson, we're going to focus on how we can use Azure RBAC to secure access to our Azure resources. To understand this better, we'll jump into the Azure portal and we're going to take a look at both built-in Azure RBAC roles as well as custom roles and how we can create those. So let's get started. First things first, what are we trying to do with RBAC? Well, we need to secure access to Azure resources. This might sound a little bit obvious, but what's really important to take away from this point here is that we're talking about Azure resources. Okay, we are not talking about access to Azure Active Directory tenants. Just understand that these are two separate things. When we want to secure access to our Azure resources, we can use identities and security groups and security principals from Azure Active Directory, and we can grant those with access to our Azure resources. But what we are not talking about is the security of the Azure Active Directory tenant itself. We're talking about things like who can restart virtual machines, who can create a resource group. We're not talking about who can reset user identity passwords, who can create identities, and so on. Okay, so when we're focusing on securing access to Azure resources, what we want to understand is that we're really trying to provide the least privilege possible to users that need to access resources within Azure. So we don't just want to say a user can have access to Azure and they can have access to everything. We don't want to give a help desk administrator full administrative privileges to the Azure subscription, for example. Or maybe you do. Or maybe you want to provide access to the finance billing section, in which case the finance team probably shouldn't have access to administer your environment. So this is what we're talking about with role-based access control. It's about thinking about the different roles that we have within our organization, whether that's help desk, finance, solutions engineers, developers, and so on, and making sure that when we provide them with access to Azure resources, we only give them the permissions that they really need. This is referred to as the principle of least privilege. So when we use Azure role-based access control, we can focus on the permissions that a role should have, as well as the permissions that a role should not have. So what does this really look like? Well, let's have a chat about the key components of role-based access control. The first thing to understand is that we have the security principle. This is the thing that's actually going to get access to our Azure resources. It could be a user, a security group, an application that we're registered within Azure AD, and so on. Okay, so this is the thing that is going to get some sort of access. The next part we have is referred to as the role definition. This is where we say, what is that access? And we use the keyword here, role, because we're kind of thinking about only giving access that is appropriate for that given role. So for a given role, do you need to be managing virtual machines? Are you creating and configuring and monitoring backups, for example? These are the different types of roles that we might be talking about. And when we use Azure RBAC, we actually have two different types of roles. We can have built-in roles that Microsoft's already created for us, and we can have custom roles that we configure ourselves. It's the role definition itself that is actually going to say what types of actions can this security principle actually perform. Now, what you're going to see when we jump in the Azure portal and take a look is that there are three main different types, if you like, of roles that we are commonly going to use. These are referred to as owner, contributor, and reader. Now, if we use the roles called owner, contributor, and reader, then these are going to have different types of permissions. Owner will have full access. Contributor will have access to perform a range of different tasks similar to the owner, but it won't have access to change permissions, whereas reader will only have access to view and not change or modify any of the different things within our subscription. Now, you can actually see different roles that have a little bit more information than this, and I've listed one here, for example. There's a built-in role referred to as the virtual machine contributor. When we talk about the VM contributor, we're saying they've got all virtual machine related permissions, but no ability to change permissions themselves. Now, that's just a little bit of a key takeaway to remember, and you're going to see this as you work more and more with Azure Role-Based Access Control. It's somewhat of a convention that Microsoft have been using for all of the built-in roles that they've configured themselves. So if we've got the security principle, we've got the role definition, what do we have next? And that's something referred to as a scope. This is where we say who has what type of access and what to. Remember, we've talked about in the previous lessons, we have management groups, subscriptions, resource groups, and the actual resources themselves. When we are defining these permissions, we can choose that scope. So you might say that someone has virtual machine contributor access, but only to all virtual machines within a specific resource group, for example. Or you might need to actually provide full access to all virtual machines within an entire subscription. In this scenario, we could assign a given security principal the virtual machine contributor role to an entire subscription. So you'll see how we've got this kind of modular breakdown of the different parts of Azure Role-Based Access Control. And it's really helpful because we can reuse different roles across different scopes for different users and so on. The final thing to understand is that we have what is referred to as an assignment. Now, the assignment is just when we take all of this and we put it together. So let's say, for example, we had a user, Morty Smith, with a user ID of msmith, and we did want to provide him with VM contributor permissions, but only to the resources within a specific resource group called Phoenix Project RG. Why don't we jump into the Azure portal and take a look at how this would actually work? So you'll see I'm logged in here to the Azure portal, and what I want to do next is take a look at providing permissions to this user to a specific resource group. So what we need to do is we actually need to browse into that resource group. So you'll see I'm looking at a range of resource groups here, but I haven't actually included all. So let's just click that option now. And then I'm going to navigate into this resource group I've created called Prod Phoenix RG. And let's say that for this, I have a range of different virtual machines within this resource group. Let's just pretend here because obviously I don't right now. What we would want to do is we would want to navigate into the access control section for this resource group. And what we want to do next is actually create a role assignment. This is where we go and say who should have what role to this resource group. So let's click on add, then click on add role assignment. What we want to do next is choose the appropriate role for this situation. So in our example, that's going to be virtual machine contributor. And you'll see there's a range of different options here as we discussed earlier. So virtual machine contributor is one of these built-in roles that Microsoft have already defined for us. So we'll choose that role, and then we're going to go ahead and choose a user. Now in my example, I don't have a Morty Smith, so let's choose Apollo Adama, for example. We're going to go ahead and click on save. And what we're doing is we are saying that this security principal will be assigned this role to the scope of this resource group. So let's go ahead and click on save. Now the important thing to understand about role-based access control is we have something referred to as inheritance. So all of the permissions that I've just assigned to this resource group will apply to any resources that are created within this resource group. So Apollo Adama will now have virtual machine contributor access to all of the resources created in this resource group. Well, what would happen if A, we weren't happy with those permissions? We wanted something a little bit different. And B, we actually wanted to apply it to all of the resources within maybe our subscription or maybe our management group. This is where we can use something referred to as custom roles. A custom role allows us to create a specific set of permissions that we want to choose, that we want to decide upon. Whether you're using custom roles or whether you're using built-in roles, we can apply these at the resource group level, resource level, subscription level, or management group level. So let's actually take a look at how we would do this with a custom role, for example, and let's first have a chat about what that custom role is going to look like. When we're talking about custom RBAC roles, what we need to know is that we use a JavaScript object notation definition of a custom role that meets our own custom needs. And it looks pretty much like what you're going to see here. So if we want to create a custom role, what does it look like? This is what you see on the left-hand side here. Let's say, for example, we wanted to create a custom role that meets the need of our help desk administrators. And we're going to apply this to all of the subscriptions across our entire environment. Maybe they need to have access to be able to view everything in all of the subscriptions. Maybe they also need to be able to start virtual machines, and perhaps they need to be able to log tickets with Microsoft. What does this look like? Well, we've got a few different things that we need to know about the custom role. On the left-hand side, we have JavaScript object notation, or JSON, which, working with Azure, you're probably going to be pretty familiar with right now. The custom role takes the format that we see here. We have some metadata, things like name, ID, description, and so on. And then we have the really important characteristics of actions and data actions. And understand that this custom role that we're looking at now is actually exactly what all roles, even the built-in roles, will look like. They have all of these different characteristics. The actions are where we go and say, what different operations can this person who is assigned this role perform? We have another cool thing here called data actions. When we're working with access control within Azure, we really have two main layers that we're focusing on: actions and data actions. Actions are the management operations, things like starting a virtual machine, creating a resource group, and so on. Data actions are things like actually performing operations within a storage account, for example, creating data, reading data, maybe within an Azure file share. Okay, actions are management operations. Data actions are operations within an actual data specific service itself. Now, for both actions and data actions, we actually have something referred to as not actions and not data actions. And as the name suggests, this is actually where we go and define different operations that a specific role cannot perform. By default, you're not going to have access unless it is granted in the access component of your role definition. So you don't actually need to go and explicitly define a not action for all of the management and data operations themselves. If someone doesn't explicitly have an action listed within actions or data actions, they will not get that access. But Microsoft still has provided you the ability to blacklist different tasks if perhaps you want to assign a role that's going to apply to different users that have different role assignments as well. Personally, I'd say that's when things get really quite messy. So in a lot of situations, we want to avoid not data actions and not actions, but you do have that there as an option you can choose. The last thing that matters for our custom RBAC roles is something referred to as assignable scopes. This is where we say, where can this custom role actually be assigned to? Can it be used across all our subscriptions? Can it be used across management groups and resource groups? So let's actually jump into the Azure portal. And what we're going to do is we're going to take a look at this role, how we create it, and how we assign it. Now, fortunately, Microsoft have actually provided a nice graphical user interface for this, but that wasn't always the case. Whether I navigate into the resource group or a subscription or the management group, I can then go into IAM for access control, and you'll see I have this new ability to click Add and then add custom role. Now we're going to do it a bit of the old-fashioned way because as a solution architect and someone working with Azure, it's always important that we understand things like PowerShell and Azure CLI as well. So I'm going to open up the Cloud Shell and we're going to use PowerShell to create a custom role. So let's actually maximize this right now, and I'll increase the font size just a little bit for better visibility. Now what I want to take a look at first is the fact that I already have a custom role here ready to go. So let's use Visual Studio Code within the Cloud Shell. I think this is a really awesome feature. And we're going to use the custom role that I've created, helpdeskrole.json. Now when we take a look at that, you can see pretty much just what we saw on the previous slide. We've got this custom role that we're creating. We want to provide our help desk administrators with full read access and the ability to start virtual machines and the ability to actually lodge support tickets. Now you might be wondering, well, where do we get these actions from? How do I actually do this? Now I'd say that this is actually something that comes with experience, but what I will do is include a link to a really important Microsoft article that's going to list all of the different resource providers and then all of the different tasks that can be performed. What we're saying here is in this first line that for all resource providers, that's what the asterisk wildcard is going to mean, that this role will have read permissions. You'll see we're being more specific in the next action where we're saying for Microsoft.compute, which is the resource provider for virtual machines, then I want to provide this role with the ability to start virtual machines. And you can see there that, of course, when we're talking about Microsoft.support, we're really talking about lodging support tickets. So within the description for the video down below, I'll include a link to this article right here, where we talk about all the different resource provider operations. So let's browse back to the Azure portal. And what we're going to do is we're going to create a role using this custom definition that we have here. Now to do this, we want to use the command new-az role definition, and then we're going to have the input file, and that's going to be our help desk file that you see above. So what I'm going to do is I'm going to go ahead and press enter, and that's going to create this custom role for us so that we can use it within the Azure portal. Okay, so we've created that role successfully. And in our scenario, let's say we were going to assign this role to a management group. You'll see here that within the assignable scope section, I've included the management group that we created earlier. So let's minimize the Cloud Shell. I'm going to browse back to home, and then I'm going to navigate into the management group section. What I'm going to do is I'm going to choose my Asia Pacific management group, and then I'm going to click on details, and then we can navigate once again into this familiar IAM section. So I've navigated into IAM. I want to go ahead and click on add and add a role assignment. Let's say, for example, that Apollo Adama was one of our help desk administrators. Now, best practice would be that we actually have a security group here and that we apply the security group permissions for that role instead. And then Apollo could be a member of that security group. But you can, of course, just assign it directly to an identity if you choose. So I'm choosing Apollo Adama as my security principal. And for the role, I'm going to search for help desk. And you'll see we've got that new help desk role that we just created. Then I can go ahead and click on save. And what's going to happen now is we've assigned this role for that user to the management group. And remember from our management group lesson, these permissions are going to flow through all of the subscriptions that are a child of this management group. Okay, folks, so there you have it. That's a wrap for this lesson on role-based access control. The key takeaways are really that what we're trying to do is secure access to our Azure resources. And we do so by having a role. Whether that role is custom or built-in, it then needs to be assigned to a security principal for a specific scope. That scope can be management groups, subscriptions, resource groups, or resources directly. When you're working with the security of Azure, this is really going to be one of the foremost services or configuration areas that you're going to be working in. So definitely I'd encourage you to jump in, have a play, check it out, and understand how this works, because it really is quite important. Okay, folks, thanks again for your time. I look forward to seeing you once again in the next lesson. Hi there, and welcome to this lesson on Azure Policy. Well, we're going to have a chat about how we can use Azure Policy to enforce business rules, business conventions, and policies across our organization that we need to have reflected within Azure. We're going to have a chat about the key purpose of Azure Policy, as well as jumping into the portal and taking a look at the key components and how we can configure it. So let's get started. Firstly, with Azure Policy, what we're talking about is the ability to enforce business rules and conventions, or maybe just report and monitor compliance with those. You're going to hear the word compliance a lot when we talk about Azure Policy. So what do I really mean when I say business conventions or organizational rules? Well, let's say, for example, that you're working with a government organization. Now, I've worked with a number of these in the past, and I can tell you that a lot of the times there is a lot of caution around where the data is going to be stored. Is it going to be stored within your resident country? So for my example, that's Australia. Does it need to be within a specific Azure region? So again, for my example, in Australia, that might be Australia Central, where Microsoft actually provide data centers that comply with a range of different government requirements. Or maybe we're not talking about something like restricted locations. Maybe instead of that, we're talking about restricted virtual machine sizes. Or maybe you need to enforce tagging. Well, with Azure Policy, we can define these different types of rules and we can assign it to different parts of our environment, whether that's subscription, resource group, and so on. And that can help us to actually enforce these rules and monitor compliance with them as well. So if that's what Azure Policy is, well, how does it actually work? To understand this, what we first need to know is that what we are doing is we are looking for specific conditions, and then we're going to say whether or not those conditions are allowed, or do we need to take some action like monitoring for that condition. So for example, when we spoke about locations and wanting to restrict which locations are allowed for your resources to be deployed to, within our policy definition, we can actually have something like, is the location equal to US West, for example, or Australia East, or Australia Southeast? So what we are really doing is we are monitoring certain fields for our resources, and we're going to check for a specific condition. Now, with these policy definitions, when we are monitoring for a specific condition, just like with Azure RBAC, we actually have both built-in and custom roles. So for example, Microsoft have some built-in roles for things like requiring a tag and a value, or allowed locations for resource groups. But we can actually get a lot more advanced than that and have things like requiring that disk encryption is enabled for our virtual machines. So really, you've got a lot of power in terms of what you can do. And with Azure Policy, after you've monitored for a specific condition, we have the ability then to trigger an effect. This is where we're going to say, what are we going to do if this condition is found? So this is actually quite powerful. It can be a little bit more than just, do we block the creation of a resource that doesn't meet our requirements? It can be, do we just audit it? So we allow that to happen, but we take note of it and we provide reporting capabilities. We can go and do things like appending or modifying. So that gives us a lot of flexibility in terms of saying we have these conditions that we require in our environment. Are we going to allow it or are we going to enforce it? So with these additional types of effects, we can actually change the resource itself so that it goes and meets our conditions instead. So for example, with require a tag and value, you can just say, I'm not going to block someone from creating a resource if it doesn't have a resource tag. What you can do instead is say, I'm going to go across my entire environment, I'm going to check all of my resources, and if they don't have a tag, then I'm going to add that tag myself. This is how powerful and how flexible Azure Policy actually is. Now, the great thing with Azure Policy is that just like Azure RBAC, we do get to define our scope. So we can actually assign these policy definitions, including the effect, to a variety of different scopes. You can have it for the management group, and we know that's going to flow down through subscriptions and resource groups and resources, all the way down through to a very granular scope of the individual resource. So that's what Azure Policy is. Well, as always, I think it's really great to get some hands-on. So let's jump into the Azure portal and check this out in action. Okay, here I am logged into one of my Azure subscriptions, and what I'm going to do now is navigate into the policy section. You can, of course, browse through the navigation pane on the left-hand side, but I've already been using policy, so we'll just click on this link right here. Now, what you're going to see straight away is that we're getting a range of different information about what resources have what policies applied and what status are they currently. A really key word we're going to see here is compliance, because remember what we are talking about is defining these rules that we have for our organization, and we want to check if our resources comply with those rules. Now, if you've already played with Azure Security Center, you might see this option here already enabled, Azure Security Center default policy. And what I'm going to do so we can get a bit better visibility is actually expand the scope here. I'm currently only looking at my production subscription, so let's just actually browse to the other subscriptions and we'll select all so we can see what we have. Now, you'll see that I've actually already created another policy and I've assigned that here. That's the allowed locations. And what we're seeing is that this is currently compliant. Okay, so 5 out of 5 resources, 100% compliance. So at a really high level, this is what we're talking about. We have policies, we enforce them, and we check for compliance. To better understand this, what I want to take a look at is the actual Azure policies themselves. We can take a look at the definitions, and we can take a look at something referred to as initiatives as well. So let's browse into the definitions section on the left-hand side. And what I'm actually going to do is choose the definition type here, just select policy for the moment, and we'll talk about this more a little bit shortly. And then what I'm going to type in here is location. Now what you're seeing is we have a number of different policies that are built in. Microsoft have already built these. And I think a really great example of Azure policies, a easy one to get started with, is allowed locations. So let's click on allowed locations. And then what we're going to do is actually take a look at this policy definition itself. Now you'll see the very familiar JavaScript object notation, JSON, for the definition of our policy. And if we take a look at this, you can see there's really a few main key components. We have, of course, all the different types of metadata, like what's the display name, what's the description, and so on. But really, the key and most core part of all of this definition is the policy rules and the parameters. Firstly, let's take a look at the policy rule. What we're talking about with this policy is whether specific locations are going to be allowed for the resources that we deploy. So you can see when we look at the policy rule, what we're doing is we're saying for the field that's called location, and we know all of our resources have a location property, it's going to check, is that field within the allowed list of locations? Now we've got a couple of extra things here, and this is just to say that we're not going to check locations when we're talking about resources that are considered global, or when we're talking about a really specific type of Azure Active Directory resource, because we don't want this to apply. So you can see already that with the policy definition, we can easily define what we are going to look for, the location, whether or not it's in our list of allowed locations. But we also get that powerful flexibility to have things like exclusions for our policy as well. And what's important about this policy rule is what are we going to do, okay? And you'll see here with the effect, we're talking about deny. When we go to create our resource, if it does not exist within the list of allowed locations, then we will deny it. So how would we actually use this? What we want to do next is click on the assign option. Now for the assign option, we do get the scope as I mentioned. So let's click on the few dots here and we're going to take a look at what we can choose. You'll see that we can choose management groups, we can choose subscriptions, and then we can choose resource groups as well. So if I choose the development subscription, for example, maybe I want to say that for my finance web resource group, I only want to allow my resources to be within a specific location. So I'll go ahead, choose select. Then I need to choose the parameters. What locations am I going to allow? Maybe I'm going to say that I'm only allowing resource to be created within Australia Central. So I can select that option. I can click on review and create and go ahead and click on create. Now I've already been through these steps because Azure policy can actually take 30 minutes or so to apply. So I've completed this already. So let's jump back into the policy definition. I'll just discard these changes and we can take a look at what this is going to do. If I navigate into the overview section, you'll see that I already have this policy. It's already defined. So let's actually just quickly browse into home, and I'm going to go ahead and really quickly just try and create a virtual machine that does not exist within the appropriate location. So for my subscription, I will choose the development subscription. For the resource group, I'm going to choose that finance web resource group. And I'm just going to fill in some details here. And I'll pop back once we're ready to go to create this, with the key bit of information being I'm going to actually create this in UK West. So I'll pop back shortly once this is ready to go and we're ready to create that resource and we can see what will happen. Okay, and here we are straight away at the review and creation screen, and we have a validation failed error. Now, first things first, you may have noticed that I wasn't really paying attention to the screen earlier on because I couldn't choose the UK region for my subscription. However, I've chosen West Central US, which does not comply with the Azure policy. And when we take a look at the validation failed error message, you'll see that resource VM1443, which is a resource associated with this virtual machine that I'm going to create, is disallowed by policy. And specifically, it's disallowed by the allowed locations policy that we associated to the scope of this resource group. So there you have it, folks. As you'll see in this scenario, we've completely blocked the creation of a resource using a simple Azure policy. Before we wrap things up, I just want to quickly show you one more thing. I'm going to browse back into the Azure policy section. And what I want to do next is browse back into the definitions section and take a look at something else we saw here. Let's take a look at initiatives now. What is an initiative and why do we have something different? We've got a policy and we've got an initiative. Well, an initiative is really just the ability to take multiple policies and make a simplified assignment. So let's say, for example, we wanted to provide a range of exclusions across our environment related to location. Well, we saw that we had a policy definition that talked about resources and the allowed locations, but it did not focus on resource groups. Let's say that we wanted to have a single policy definition and we wanted to apply that restriction of allowed locations for both resources and resource groups. What we could do in this example is we could choose the definition location, maybe we go back to the development subscription, okay, and then what we're going to do is pick a name. So let's say, for example, allowed locations. Now you'll see on the left here that I can actually choose now multiple different policy definitions. So if I filter by location, I can then choose allowed locations and I can choose allowed locations for resource groups. And I can set the allowed values here in this screen. So an initiative is just the ability to assign multiple policies within a single assignment. Okay, folks, so that's a wrap for this lesson on Azure Policy. As you'll see, what we're talking about here is kind of a continuation of all these different tools and tricks and techniques to enforce structure, control, and organization of our environments. You can see that we're continuing to use scopes like management groups, subscriptions, and resource groups. But with Azure Policy, instead of focusing on the allowed operations, which is role-based access control, we're really focusing on the allowed characteristics of resources within Azure. Okay, folks, so I hope you've enjoyed this lesson. Thanks as always for your time, and I'll catch you in the next one. G'day again, everybody. It's good to have you with me for this lesson on Azure Blueprints, where we're continuing a chat about how we can control and standardize the resources that we create within Azure. Within this lesson, we'll focus on what purpose Azure Blueprints serve, and we'll jump into the Azure portal and we'll actually see this in action because Azure Blueprints are really powerful. It really helps to standardize and simplify the deployment of resources within your environment. But it's not necessarily so obvious what purpose they serve until you see it in action. So let's jump in and check it out. First things first, let's have a chat about why we use Azure Blueprints. With Blueprints, we're focused on centralized management of the deployment of solutions that should look the same each and every time. We want to have controlled deployments of our solutions. Okay, with Azure Blueprint, what we're really focusing on is this ability to take a range of different key artifacts and bring them all together. So far we've spoken about Azure Policy and how we can enforce organizational standards. We've also had a chat about role-based access control and how we can use that to configure and control secure access to our environment following the principle of least privilege. However, we also know that when we configure our environment, it's not just about the standards and the security, it's also about the resources that we want to deploy. And you should know, either from my previous course or because you've already had experience with it, that we can use Azure Resource Manager templates, or ARM templates for short, to use JavaScript object notation to define what resources we want to deploy and what they look like. Well, with Azure Blueprints, we bring all of this together to say, what should our solution look like? With ARM templates, what are we deploying? With RBAC policies, what security will there be? And with Azure Policy, what types of conventions are we going to enforce? So with an Azure Blueprint, we can connect all of this together along with resource groups to say what our solution should look like. So how does this actually work? Well, we've got a few different key elements with Azure Blueprints, and surprise, surprise, it actually looks quite familiar to policy definitions and role-based access control. We firstly start off with our definition. With Blueprints, our definition is talking about all of these different artifacts that we are going to use. What role-based access control will there be? How many resource groups do we want to create? Will we use Azure Policy? And what type of resources are we going to deploy with an ARM template? One of the other cool things about Azure Blueprints is that it actually provides publishing and version control. So when we create this definition, we can do so as a draft. We can make whatever changes we need, and then we can publish that as a version 1, 2, 3, whatever it might be. You might then go on to make additional changes and actually have additional versions of your blueprint, so that at any given time, you can have a versioned definition of your solution, and you can easily use that to go and deploy a solution exactly how you want it to be. So this is the next part of a Azure Blueprint. It's the actual deployment, and we refer to this as an assignment. An assignment is where we say we want to take a version of our definition and we want to use that to actually deploy a solution. The cool thing again about Azure Blueprints is this type of modular approach to our solutions with a definition, an assignment, and the actual deployment allows us to have a good audit control of what was done and what definition is used to deploy our solutions. So as always, to understand this a bit better, let's jump into the Azure portal and we'll check it out in more action. Here I am once again in the familiar Azure portal, and what I'm going to do is navigate into the Blueprint section. Now let's say, for example, we've spoken about this development finance web application a number of different times, and maybe you're working in an organization where you are testing a range of different things and you need to deploy this test web application again and again. Maybe you're making some changes and you want to test it with different data, and then you want to delete it, recreate it, delete it, recreate it, and so on. And maybe you want to change how that solution looks each and every time. This is an example of where we might use blueprints. We might use blueprints to easily deploy this development finance web application exactly the way we want, because we know that when we're deploying things for test, it can be really easy to forget about things like security. With an Azure Blueprint, if we have this really clear definition of what our solution looks like, we can be sure that even though it's for development and testing, it's going to be secure with the RBAC policies, and it's going to look like what we want it to look like with Azure policies and with the ARM templates. So let's go ahead and create a blueprint and see what this looks like. I'm going to get started by using a blank blueprint definition, but you will see that Microsoft provide actually a range of samples that you can build from yourself. So let's use a blank blueprint. We're going to give this a name of Dev Finance Web, and we'll leave the description as blank for now. And let's choose our definition location, and we're going to select the development subscription. Okay, next what we want to focus on are the artifacts. Now this is the really key component of our blueprint definition. It's what actually says what our solution should look like. So we can, for example, say, I want to have a resource group for my solution. When I deploy this, I want to create a new resource group. You might even create multiple resource groups. Maybe one resource group for the web resources and another resource group for the virtual network. It's going to depend on your environment and how you want to deploy that. In this situation, we have a virtual network, so let's just leave this as is and we'll pick one resource group. We're just going to call the artifact display name resource group, but you might have something more verbose like web or VNet or core or something like that. Okay, now you'll see that for the definition, we can actually go and specify the values that we require, the location, the resource group name, tags, and so on. Or you could say that I'm not going to do that until the time that I deploy the solution. And that's the option we're going to choose. So I'll click on Add, and we now have a resource group for our blueprint. Within this resource group, I might say that I want to deploy different resources. And to do that, I might actually use a Azure Resource Manager template that I have available. So I'm going to choose this option, and you'll see what I need to do is I need to specify all of the text for my ARM template here. What I'm going to do is I'm just going to copy in a Resource Manager template that I have created earlier, but if you would like to know more, be sure to check out the previous lessons in the AZ-303 Course 1, where we take a look at ARM templates in more detail. Okay, so I'm going to paste my template in. Now, for my example, this is going to create a virtual machine with a public IP, a virtual network, and a range of other resources. The key takeaway here is that we are using this ARM template to define the resources that we want to deploy. And we could just use an ARM template if that's all we wanted to do. But we know that with blueprints, we get more control over things like security, policies, and we get that added benefit of version control as well. So let's just call this ARM template, and we'll leave the rest as is and go ahead and click on Add. Now what we can do next is we can actually go on and say what types of permissions should there be allowed to this solution once it's deployed. And we do that with a role assignment. A role assignment is really when we're saying we're going to use Azure Role-Based Access Control to configure permissions for the solution. So I might say, once again, I want a role and I want to define what that's going to be when the actual blueprint is deployed. So I'm saying that for this solution, I want to define an owner who is going to have complete control, complete access to the solution. So I'll go ahead and click on Add, and you'll see the other artifact that we can add was the Azure Policy Assignment. Now, for example, once again, I might choose to go ahead and restrict the location. So I could go and choose allowed locations and click on add. And maybe for this example, what I actually want to do is I want to dictate this location before the deployment. So I might say that for the solution, I actually want to have Australia East, and let's actually choose some other Australian options as well, maybe Australia Southeast as well. So just understand that for these parameters that you specify, you can either do so at the creation time, so they're hard-coded and cannot be changed, or at the deployment time, so they can be chosen when the solution is deployed. So I'm going to go ahead and choose Save as Draft, and this is the option that we get to choose for our blueprint, because what we're going to see next is when we save our blueprint definition, it enters a state of draft, and we then need to go about actually publishing that blueprint when we're ready to do so. Just understand, if you are following along at home, it can take some time for that button to take effect, so don't worry about clicking it again and again and again. Just click it the once like I did and wait a few seconds and it should be ready to go. So we can see up here that the saving of our blueprint definition was successful. And if we now navigate into the blueprint definitions and then click on Scope, and what I want to do is choose the subscription that I specified for this blueprint earlier. So I've saved this blueprint definition to the development subscription. So let's select that, and we can see we've got our definition right here in the draft status. So I've navigated into that, and what I want to choose next is the Publish Blueprint option. But remember, we have version control, so we might edit it, we might change it, and so on. I'm going to go ahead and click on Publish, and I'm going to say that this is version 1.0. And you see you can actually enter and change notes, so you get that audit trail of what you've been doing with the definition of your solution. So it's a lot more than just a basic ARM template. We get to bring all of these different things together in the type of way that we would really want to define an actual solution that we deploy to Azure. Now that that blueprint has been published, let's go back to blueprints, and I can actually now go ahead and get started assigning this blueprint. So I've actually got this blueprint here. It's published, it's version 1. I'm going to go ahead, click on the drop-down options over here and choose Assign Blueprint. You'll see now what we're doing is we're actually creating the deployment of this solution using the definition. I won't choose the location of West US 2 because that's going to fail based on our policy definition. So let's actually type in Australia, and I'll choose Australia Southeast. We're going to use the version 1 definition of our blueprint, but you'll see that if we had multiple versions, we could actually choose different versions there as well. Now, one thing you're going to see here is something referred to as lock assignment. If you're not familiar with resource locks, what we are talking about here is something that's not specific to Azure Blueprints. It's the ability for us to say we want to apply a resource lock that is only going to allow read-only access to our resources, irrespective of whatever Azure role you have access to this solution with. Or you might say do not delete access, which means that the solution can be modified, but it cannot be deleted. Now, resource locks are really popular when you're working with things like virtual networks, maybe an express route gateway or so on. But really, because an Azure Blueprint is going to be defined based on a blueprint definition, Microsoft want to include the resource lock in case you want those changes to be locked here so that you only purposely manage your solution through Azure Blueprints. I'm going to leave that lock as don't locked, and you'll see we also get a managed identity that's going to be created for the creation of our resources. We're just going to leave that one as is using the system assigned managed identity. Now, because this is the time we are deploying our blueprint, we get to specify a range of different options. So for example, I might say dev finance web 1 -RG for my resource group name. I might choose Australia Southeast again for my resource group location. And then you'll see we also get to choose the owner, which we specified we needed to define for the owner of our solution. So I might go ahead and type adm.jlee. And then we'll go ahead and choose my admin account right there. Okay, so that's all we need. We have specified these additional features and we're going to use that ARM template to deploy the solution. I can go ahead and click on Assign, and that's going to deploy our solution using that configuration. Okay, folks, so I'm not going to bore you with having a look at that solution once it's deployed. What you can see there is everything we need to see for Azure Blueprints. Really what we're doing with Azure Blueprints is bringing together these different types of controls and deployment techniques that we've got all together so that we can appropriately deploy a solution nice and easily using all the different characteristics we would normally want to. As opposed to an ARM template, which is just going to deploy resources, we use blueprints when we want to define all the extra things like security, like policies, and so on. And once again, don't forget, we get the added benefit of version control, and we can easily take a look at the solutions now that have been deployed. We can even browse into the assigned blueprints. And if we take a look at the development subscription, what we can do is we can then actually see all the different solutions, the provisioning state, when they were deployed, and so on. So it's a little bit more than just simple solution deployment. It's much more control over security, deployments, versioning, and so on. Folks, I hope you've enjoyed this lesson. I hope you've seen that Blueprints is really quite powerful, definitely something you should know as a solution architect. Hope you've enjoyed this lesson, and I'll catch you in the next one. Hello once again, everybody, and welcome to this lesson on Azure Active Directory Access Reviews. Now, Azure AD Access Reviews are a really cool feature, and I know I probably say that about most Azure services, but this is really something that you should know about if you're interested in securing identities. And you should be interested in securing identities because we know that's at the center of nearly everything we do when working with modern cloud applications. So within this lesson, we're going to chat about what Azure AD Access Reviews are, and we'll create an access review and take a look at it from both the administrative and what you might refer to as the end user experience as well. First things first, what are they? Really, Azure AD Access Reviews is this simplified, streamlined approach to being able to take a look at all the identities used in your organization and make sure that they only have access that they should have access to. Okay, so have a think about maybe help desk administrators, for example. You might have a security group that has help desk administrators within it. And we know that from previous lessons, such as Azure Role-Based Access Control, we might actually apply permissions to that security group that grant powerful access to manage Azure resources. So it's really important that we actually manage these security groups and these administrative access accounts so that they're only being used by people who should have access. It's really common, for example, to set up security groups when you first start creating a solution. And maybe when that solution is first created, some people need access, but then after that solution has been deployed and handed over to other teams, the initial team no longer requires that access. When we use things like Azure AD Access Reviews, we get the ability to schedule reviews of these security groups and even reviews of permissions within Azure Active Directory and confirm that that access is still in fact required. That might sound a little bit vague, so just bear with me because as we walk through the demonstration, you'll see what I mean in more detail. So how do we actually perform this? Well, if we want to implement Azure AD Access Reviews, the first thing we need to do is onboard your Azure Active Directory tenant. This is a simple process of just clicking an onboarding button and saying, yes, you do want to approve Azure AD Access Reviews. Also understand that you're not going to be able to create the reviews if you don't have the appropriate licensing. So we'll take a look at this in the portal as well, but just understand at a bare minimum, you will require Azure AD P2 licensing. And this is going to be required by any user that is going to take part in the Azure AD Access Review itself. Again, this can seem a little bit vague, but we'll see more when we actually perform the review. So you've onboarded your Azure AD tenant, you've got appropriate licensing. What you want to do next is create the actual access review. The cool thing about access reviews is we get support for quite a few different types of scenarios. We essentially are able to check 3 different things. The first 2 are really focused on Azure Active Directory security groups or Azure Active Directory applications. So applications at the time of this lesson being recorded is actually in preview. But what we're talking about these 2 things is saying, do we still require certain members to be members of specific security groups? Or do we still require specific users to have access to specific applications? However we configure these reviews, what we're really focusing on is checking the membership of different access, whether that's a security group or an application. And what you can do when we create these reviews is you can give the ability for users themselves, so the actual members of these groups or members of these applications, to actually confirm whether they do still require that access. Now, if you don't want to give the ability to your end users to say yes or no, they require access, then what you can also do is create an access review that is going to be performed by the owner of that application or that security group itself. So you can see how this is powerful in terms of helping alleviate the administrative burden. You can hand over the administration of these access reviews to either owners of groups or the actual members of the apps and groups themselves. Now, when we create these access reviews, the way in which they are going to be performed is through something referred to as the access pane. And this is where self-reviewers or owners are going to be able to go in and say, do I still have access, or should these people still have access? What I also want to mention to you is there's actually an additional type of review you can perform. And this is referred to as an Azure Active Directory privileged role review. With Azure Active Directory, we have privileged roles for people to be able to manage Active Directory itself. And so, of course, this is also something that we want to perform checks on to see if people still should have that access. Just understand that this is slightly out of sync with the new access pane and the new Azure AD Access Review approach, and I'll show you this within the portal. So let's jump in and get started in the Azure portal and actually take a look at this in more action. Okay, here I am within the Azure portal, and of course, since we're talking about Azure Active Directory, security groups, privileged roles, or applications, we want to take a look at Azure Active Directory itself. So if I browse into my tenant, what I then want to do is navigate down to the Identity Governance section. And this is where we go about creating and managing access reviews. So I'm going to click on the Create an Access Review option right here, and then we can chat about some of these different options. So for the review name, let's just call this Help Desk Admin Review. Let's say in our example that what we want to do is we want to take a look at a security group called Help Desk Admins. This security group within Azure Active Directory has a range of different users that belong to the help desk. And maybe we've got Azure role-based access control so that this security group has the ability to manage different resources across Azure. Since this is an important security group with important secure access to Azure, we want to review who still requires membership to this group. So we create our review and we can say when we want to go about actually performing this. We might say that this is a once-off access review, or you might like to actually add this as a weekly, monthly, quarterly, or so on. And you can do this because really these access reviews should be performed on a regular basis. In our example, we'll choose one time, but just bear in mind that you can choose these different frequencies if you so desire. Now, what we have to choose next is the end date. This might not be obvious why we do so at the start. Really, when we create this access review, we're saying we want to perform a review of the membership and we want to allow some time for people to respond. That might be the members themselves, or it might be the owner of the security group in question. So we need to allow some time for this review to be performed. And this end date is important because once the review is complete, we might actually automate certain things to happen. And I'll show you that shortly. So let's say we've got this help desk admin review. What we want to do is we're going to say that we want to review this security group. But again, you can choose an application if you desire. So what we want to do is we want to check everyone within this security group and we want to see if that access is still required. So for our security group, we're going to go ahead and select one of our Azure AD security groups to perform this review. In our example, we're going to choose help desk admins. So let's select that now. And then what we want to do is choose who is going to perform this actual review. So let's just scroll down. And you can ignore this option here because yes, I have already created this review. When we choose the reviewers, what we are saying is who is actually going to go and say who still needs access. We can say it's the group owner, and this is a good way of handing over control for security groups so that it can be managed and alleviate that burden on administrators. But you might actually say, I want a selected user to perform this review, and you might select an admin or maybe a dedicated resource that you have to do so. Or what we can actually choose to do, as I mentioned, is the self option. This is where we say that people who belong to the security group will have to respond and say whether they do still require this access. Now, once this review is complete, you'll see we get some additional options. We can auto apply results to the given security group in question. This might be that what we're saying is if people don't respond, we want to remove access. And at the end of this review, when the end date is reached, depending on who has responded and who has not, we might enforce automatically to revoke people's access. This is really good, for example, if you have people who move on from your organization and you want to remove that account as a measure of good, clean security practice. However, in our example, let's just choose disabled And this would mean that the access review will create some results that we can go and action ourselves. So I've actually gone ahead and already created this access review. So if we navigate back into identity governance, I can discard these changes. I can navigate into the access review section, and you'll see that I have this help desk review already created for the help desk admin's security group. So if that's the creation of our access review, what does it actually look like? Okay, I've created this access review for the membership type of review, which means I need people to respond to say if they do still need access. Now, in our example, within the help desk admins, I have a member called Egwene. So let's browse across now to the access panel and take a look at how this access is performed. Okay, what I'm going to do is I'm actually going to browse to the old address. This has been recently changed, but we can navigate through to the new address using the myapps.microsoft.com address. Then what I'm going to do is I'm going to log in as Egwene at jazzlab1.com. Now I'll enter in my credentials and complete the authentication. And then what we're going to do is we're going to check out this review. So you'll see here I'm logged in as one of the end users, the member of the security group help desk admins. And given the access review is underway, I have this option here that I can choose. And it's going to take me to a new experience. I'm actually going to click on the try it and use the new experience, but both of them are more or less pretty much the same. So you can see that we're logged in as Egwene. If I check up the top right here, everything is as we expect. And we have the ability now to perform this help desk review. So this is a help desk review that's being performed by a member of the security group. And you'll see what I'm being asked is, do I still need access to this group? So I'm going to go ahead and choose yes and say, I am still a help desk administrator. And what you can see here is we get this added benefit of a bit of an audit trail, which is obviously something that's very important when we're working with security. So as an end user of the security group, I've stated that I do still require access, and I've stated why I require that access. Now, if I browse back to the Azure portal as our administrator, you can see that if we take a look at this help desk review, it's currently active. We can get more information about what the status of the review is, who has responded, and then once this is complete, we can actually go ahead and take some action. So what I'm going to do right now is I'm just going to click on stop. I'm going to say that I want to stop this review. There was actually one other member that needed to reply, but let's say that we had to cut this review short. And then you can take a look at the results and actually see what has happened. So you'll see we had one user, Apollo Adama, who did not reply to the review. And the recommended action is going to be that his access, therefore, is going to be denied. And we have Egwene, who did respond and has logged in once within the last 30 days. So we get some smarts here about what's going to actually happen. And you'll see the benefit of this as well is that we have this audit trail of what has happened for this access review. If I browse back to the overview for this, what I can then actually do is go ahead and click on the apply option. And depending on how I have configured this review, that may or may not actually therefore go and remove access to security groups. So as you can see, that's a really powerful tool, folks, something that you can schedule on a regular and recurring basis to ensure that only those who need access do still have access. Two other really quick things I wanted to demonstrate for you. If we take a look at the Azure Active Directory tenant, understand that within your licenses section, you will need to have the appropriate licenses. And what you will need to do is actually assign that to at least your administrator to get started, but it should be assigned to any and all who participate within your Azure AD access reviews. The last thing to understand is that if we want to perform these access reviews for Azure AD privileged roles, that the experience is a little bit different. What we can actually do is we can navigate into Azure AD Privileged Identity Management. We can then select the Azure AD roles, and we can navigate into Access Reviews, and we can click New and create an access review. You'll see it's much the same experience, but what we're talking about here are Azure AD roles themselves. Things like Global Administrator, User Management, and so on. Well, everybody, that's a wrap for this lesson. I hope you've enjoyed it. I hope you've seen how powerful this tool is. As I've mentioned, it's one of my favorites. It's something I think you should be familiar with, but just bear in mind that it does require that Azure AD P2 licensing. Thanks for your time, folks. I'll catch you in the next lesson. Hi, everybody. Welcome to this lesson on network security groups. Today, we're going to have a chat about how we can use network security groups to secure resources within virtual networks. We'll start by having a chat about how we create and configure them, and then we'll jump into the Azure portal and check it out. With network security groups, what we are really trying to do is control the flow of data, of information, of network traffic across our virtual network and outside of our virtual network as well. So what we're really focused on doing is controlling the flow of information. I really want to focus on here how this is slightly different from routing. With routing, what we are actually doing is talking about the different pathways that we have. So think about roads between houses. Now, with network security groups, what we're talking about is the ability to filter traffic. So think of this as something like a front door on your actual house. It's where you could say, okay, anyone can come to my house. There's a driveway there, there's a footpath, anyone can get access. That's routing. Network security groups is when we say at the front door, who am I going to let in? Who am I going to let out? So it's the same sort of thing, but what we're talking about is resources within a virtual network. So we're defining what can come in and what can go out. And the thing to understand about network security groups is that we can actually provide this type of control, this filtering, at either the subnet layer or the network interface layer itself. The other cool thing about network security groups is that you can actually configure a range of different complex scenarios because we have the ability to define priorities for the rules within our network security group. So to help understand this a little bit better, let's actually have a chat about how these network security group rules are configured. And this is where we talk about something referred to as rules. This is really the core of what we do within network security groups. You'll see here I've just got a basic screenshot of a network security group from Azure. And what we're talking about here is this ability to define what types of traffic do we want to allow in and out. And what's really important is that definition of the traffic itself. This is where we say, what port are we talking about? What protocol? Where is the data coming from and where is the data going? And there, are we going to allow it or are we going to deny it? So with a network security group rule, as we'll see within the portal shortly, we have the ability to create each of these individual rules. We can have a really simple network security group with only a few rules, or we could have a really complex one with a great number of rules. Now, what you're actually seeing here on this screenshot is something that includes a range of what's referred to as default rules. So what you see here for the allow VNet inbound, allow Azure Load Balancer, and this really important one, deny all inbound, these are called default rules. Now, we can't actually change these. So this is a brand new network security group that I've created, and these are the rules that exist by default. I can't delete them. But what I can do is I can actually override these rules. And to do so, this is where we leverage the thing referred to as priorities. So we can create our own rules. And let's say, for example, I have this rule here, deny all inbound. And I actually, which I shouldn't do, it's very bad practice, I actually wanted to allow all inbound. To do that, I could create a new network security group rule in this network security group in the inbound security rules, and I could give it a priority of, let's say, 100, and I could say all ports, all protocols, all source, any destination is allowed. That's going to override this default deny all inbound rule. Again, that's not something I should do. That's really bad practice. But what's important to understand here is that we have the ability to override these rules by having a rule with a priority that has a lower number. That might sound a little bit odd, but just remember, the lower the number, the higher the actual priority. Now, to understand this better, what we'll actually do shortly is jump into the Azure portal, create a network security group, and alter these rules, and we're going to allow some inbound access to a virtual machine that we have up and running. But before we do so, let's have a chat about how we actually use these network security groups. Firstly, we create them, we configure our rules, and next, we need to assign them. Now, when we're assigning our network security groups, we get two options. We can assign them at the network interface card layer, or we can actually assign them at the subnet level. Now, when we assign a network security group direct to a network interface card, it's only going to apply to that virtual machine. When we apply it to a subnet, it's going to apply to all traffic within that subnet. So you really have the opportunity to be as granular and as flexible with your security as you require. What do I mean by that? Well, when you have multiple NSGs assigned, so you have one NSG assigned to a subnet and you have one NSG assigned to a network interface card, then these two things actually do both take effect. So it is important that you understand how this works when you've got NSGs assigned to a subnet and a network interface card. I always like to provide the recommendation, follow the traffic. So let's say, for example, we had an NSG at the subnet layer and it was allowing RDP access. But we had an NSG assigned to a NIC for one of our virtual machines and it was blocking that inbound access. What's going to happen? Well, if we follow the flow of traffic, we're going to see that the traffic is allowed at the subnet layer. However, when that same traffic then reaches one of our virtual machines, it's going to be blocked by a network security group. The other virtual machine and any other virtual machine within this subnet will be allowed to have this traffic flow through. Similarly, for outbound access, if we had something blocked at the network interface layer, it's never even going to reach the subnet at all. So just remember, follow the flow of traffic and have a think about what that network security group is going to do at each step along the journey. Okay, so let's actually jump into the Azure portal and check this out. Okay, here I am logged into the Azure portal, and what I want to have a look at is a virtual network that I've already got configured. So let's type in VNet2 and we'll browse to this virtual network. Now for this virtual network, if I navigate into the subnet section, you'll see that I have a singular subnet, subnet 1, and I currently don't have any network security groups assigned to that. However, if I take a look at connected devices, we'll see that I do have a virtual machine attached to subnet 1 with an IP address of 10.2.1.4. So let's say that within this virtual network, we had an important virtual machine and we wanted to protect it. Okay, we didn't want to allow inbound access except for the things that we did specifically allow. What I want to do first is actually show a really important point about working with resources in a virtual network. I'm just going to navigate into this network interface card and you'll see we've got a public IP address assigned for this virtual machine. So I'm going to take a copy of this public IP address, and what I'm going to do is I'm going to browse across to a remote desktop client and I'm going to try and connect to this virtual machine via public IP. Now have a think about whether this will work. I'm going to go to my address bar at the top, type in rdp:// and I'll paste in the IP address there, ready to go. Now when I hit enter, it's already working, okay? It's prompting me for credentials. If I go ahead and enter my credentials, you'll see that the virtual machine is in fact loading. Why is that? Well, let's browse back to the portal and have a chat about why. For this virtual machine in our virtual network, there's two important things we need to know. One, we don't have a network security group assigned. And two, we have a public IP address assigned to this resource. So by default, we're going to be able to access anything on this virtual machine. If I had a web server running, inbound access would work on this public IP. If this was a Linux box with SSH, SSH inbound would work. Until I apply that network security group, this is going to work by default. All inbound access, all outbound access is already working. So do you want to use network security groups? Yes, you definitely do, because by default, access is allowed, and that's really not secure. Really quickly, something to understand is this public IP address is actually what's referred to as a basic public IP address. When we're working with any resource that has a basic public IP address, then that inbound access will be enabled. However, just understand if this virtual machine had a public IP address with a standard SKU public IP address, then actually, by default, that will have been blocked. So that's a really key takeaway when you're working with network security groups. Just understand that for resources that have a basic public IP address, all access is allowed. For public IP addresses that are the standard SKU, then you actually have to go in and allow through a network security group. So just something to be mindful of when you're working with Azure. Okay, so for our resource, we've got a basic SKU and we want to protect that. So what we want to do is we want to browse back to the home, click on create a resource, and we're going to get started creating a brand new network security group. So we'll type in network security group, and I'm going to pick this Microsoft option here and go ahead and click on create. Now let's just choose a resource group I already have, and we're going to choose VNet2 resource group. We'll just call this NSG1, and I'm going to place this in the location of Australia Southeast. So let's choose Australia Southeast. Then all we need to do is go ahead and click on review and create. Now that's really actually all there is to it to creating a network security group. Remember, what's really important about the network security groups are the security rules, the inbound and the outbound rules that we define what access is actually going to be allowed. So with that network security group created, let's go and check out those security rules. You'll see here we are in the network security group and we have the inbound and outbound default rules that already exist that we just spoke about. Now, by default, we have this really important rule, deny all inbound and deny all outbound. So if I wanted to just take this network security group and assign it to subnet 1, then I'm going to click on the subnet option here and I'm going to choose associate. When I do so, this network security group is going to now block all access to anything within that subnet. So let's choose VNet 2, and I'm going to choose subnet 1, and I'm going to go ahead and click on OK. Now what that's going to mean is my RDP access to that virtual machine is going to stop working. But maybe in this scenario, I actually did want to allow access. So to do so, I'm going to navigate into the inbound security rule section, and I'm going to want to create a rule that is going to override the default deny all inbound rule. So to do so, I can click on add, and you'll see this is where we specify all the information about what traffic we do want to allow. What I want to do is I want to be really specific about what type of traffic I will allow. So let's step through this option now. For the source, what I could actually choose to do is pick something referred to as IP address, and then I might actually include the public IP address of my home computer. This way, it's only going to allow me to connect via RDP to resources within that subnet. I'm just going to leave this as any for now, and what that's going to mean is that once we've created this rule, anybody who has the public IP address of my virtual machine will be able to try to RDP. Now the next option we have is the source port range. Just understand that if I was at home connecting to virtual machine 1 via RDP, what I'm going to do is I'm going to use the destination port of 3389. That's the RDP protocol. For SSH, we'd be talking about 22. If it was a web server, we might be talking about 80 or 443. Just understand that for this source port range, you're actually commonly going to use the asterisk option here, which means any source port range, because what we're really focused on is what port will we be allowing inbound access to for our given resources in the subnet. In this scenario, that's RDP, which is 3389, and my client computer can actually use a range of different ports to access this. Next, what we need to do is choose the protocol. Now with network security groups, you'll see we have the option of TCP, UDP, or ICMP. This is really going to depend on what application or what service you are allowing inbound access to. For me, I'm going to choose TCP as that's what RDP is going to work over. Then, really importantly, what do I want to do when traffic inbound matches this rule? I'm going to say I want to allow this traffic, and we're brought to one of the final most important parts, the priority. Remember, the lower the number, the higher the priority. So let's just say for this example, we're going to use a priority of 1000 because we know that's a lot lower than the default deny all on 65,500. We can enter a rule name. I'm going to say inbound _ IDP _ allow. Then I'm going to go ahead and click on add, and that's more or less actually all I need to do. You might be wondering, well, how is this RDP rule going to work? I'm allowing a computer to connect via RDP, but outbound access is blocked. This is the final thing we need to understand about working with network security groups. A network security group is what we refer to as stateful. What this means is that if you allow inbound traffic, then the corresponding outbound rule is going to be allowed automatically. What's happening is the traffic is going to hit the network security group inbound. It's going to match this rule on priority 1000. It's not going to process any more rules because once it reaches a match, it stops processing. And what it's going to do is it's going to allow that inbound traffic into, let's say, virtual machine 1 within subnet 1. When it does so, it's automatically going to allow the reply traffic back to the client who is connecting over RDP. So folks, that's actually all there is to it for network security groups. It's a really important, really powerful thing that we need to know about when we're working with resources that exist within a virtual network. The key takeaways here are we have network security groups. They can be assigned to a network interface card or a subnet. We can have multiple different rules, and these are all prioritized using the priority number. The lower the priority number, the higher the priority. The way this works is that when a rule is matched on a priority, no further processing takes place. And for network security groups, we have stateful rules, which means if you allow traffic in either the inbound or outbound direction, then the reply traffic is also going to be allowed. So folks, that's a wrap for this lesson. Thanks very much for your time, and I'll see you in the next one. Hi everybody, welcome to this lesson on augmented security rules, where we're going to have a chat about how we can simplify our job when we're working with security for virtual networked resources. We're going to focus on a couple of things within this lesson: service tags and application security groups. And it's really something that's easier to understand when we see it within an example. So we'll jump into the Azure portal and check it out. First things first, what we're focused on with augmented security rules are simplifying network security rules. As I mentioned, we're trying to make our jobs easier, and we do so by defining security rules that actually correspond to real-world services and solutions. So if you are building something that has web servers or database servers, how can we more easily and logically actually refer to these as web servers? Or if we're working with the Microsoft storage service, or maybe APIs or any other Microsoft managed service, how can we create network security group rules that actually point to the Microsoft storage service or other Microsoft service really easily? To do so, we use two things: service tags, which is how we talk to the Microsoft services, and application security groups, which is how we represent our own solutions that we build ourselves. So let's start by having a chat about service tags. Now, service tags are where we're referring to Microsoft services, and you'll see I've listed just a really quick snippet here of a Microsoft article that talks about a couple of Microsoft service tags. We have action groups or API management, and really what we are talking about here is if you want to create some sort of network security group rule that actually refers to a Microsoft service, it's going to be really hard for you to enter in details about the IP addressing. Think about Microsoft's global services that they manage, okay? It might be behind load balancers, content delivery networks, public IP addresses in one region, different public IP addresses in a different region. With service tags, Microsoft provides us this really easy ability to just point to a tag, and they will take care of all of the management of what IP addresses that actually is. Whether it changes, they'll update that regularly, and so on. So it's something that makes it really simple for us to configure network security groups, and actually, as we'll see shortly in another lesson, even Azure Firewall. The point is, if we're creating these security rules that are filtering traffic which communicates with Microsoft services, then we can just use these tags to really easily do so. So what I want to do is let's actually jump into the Azure portal right now before we have a chat about application security groups. And let's just have a chat about how this would work. Okay, so here I am in the Azure portal, and we're looking at Virtual Machine 2. Now, if we take a look at the networking section, you'll see that this is a virtual machine that's in a subnet that we were already configuring network security group rules for in the previous lesson. So we can see here we have NSG1, which is attached to subnet 1 within virtual network 2. And as we configured earlier, we have the inbound allow rule for RDP access. Well, we know also that for our network security group that we just created, we didn't configure any outbound rules, which means that the deny all outbound rule is going to apply. So whilst we can RDP to this virtual machine, it can't really do anything. Let's say that this virtual machine did actually need to do a couple of things. We needed it to be able to communicate with Microsoft storage, and we also needed it to be able to communicate with some web servers that we have running in this same virtual network. Well, service tags can help us out with the first bit, and application security groups can help us out with the second. So let's take a look at how that would work. What we're looking at here is the network security group that we configured earlier, and I'm pointing that out just so you know that this is a slightly different interface. We're looking at it through VMO2, but it's the same thing. So we can actually just either click on the Add Outbound Port Rule right here, or we could navigate into Network Security Groups, Network Security Group 1, click on Outbound Security Rules, and then add this security rule as well. So I'm just showing you a different view of the same thing that we already looked at. So for adding this outbound security group rule, we know we configure the source and the other details like port, protocol, destination, and so on. In our example, we're saying we want to allow this virtual machine, and maybe any virtual machine within this subnet, to have access to Microsoft storage. To do so, we can click on the destination option, and you'll see that we could click on IP addresses, and we could type those IP addresses in here. But again, since that's a Microsoft service, that's going to be really hard to do. So instead of that, we use the service tag option. And when we have the service tag, we have all these built-in different things that we can use, such as internet. If we wanted to allow access to the internet, maybe on port 80 and port 443, for example. Or maybe we wanted to allow some other connectivity to other Microsoft services, which you can see here. In our example, we're talking about storage. So if we search for storage, you'll see Microsoft have all these built-in service tags ready to go for us. Now, I'm in Australia Southeast, so maybe what I want to do is only allow connectivity to storage that is within the Australia Southeast region. This is the Microsoft storage service, so things like blobs, files, queues, and tables. And I might just allow that on port 80 and 443. Maybe it's a blob storage service, and we're accessing it via the REST API on 80 and 443. So you can see here that we've got the same familiar interface. We can add the priority. So let's create that priority as 1000, and we can configure a name as well. Let's just call this outbound storage allow. So that's it. We can go ahead and click on add, and now any virtual machine within subnet 1, which is where we assigned that network security group, is going to be able to access the Microsoft.storage service within Australia Southeast using port 80 and port 443 on any protocol. Now, we could have locked this down to VMO2 in a couple of ways. One, we could have just created a network security group with similar rules and assigned it to only this network interface card. Or we could go into the source component here, and we could actually say IP address for our source and type in the IP address of 10.2.1.4, which is the IP address of this virtual machine. It's really up to you what you want to do. In our scenario, we've added it for all resources within subnet 1 because that is where the network security group is associated. But the real key takeaway here is this service tag, and you'll see that we've got lots of different options we can choose from, and it really simplifies the ability to create rules that work with Microsoft services. But what about if we want to work with our own services? What about, for this example, Virtual Machine 02 should actually be able to access another virtual machine within this subnet, or maybe a group of virtual machines. Let's say we have some web servers in this subnet, and we want to be able to allow access to those web servers. Currently, we could create an outbound rule, and we could set the destination to IP addresses, and we could type in all of those different IP addresses of maybe 10.2.1.5 and maybe 10.2.1.6. But really, that's making it manual for us, and it's a lot more hard to maintain. So let's have a chat about application security groups, which is something we can use to really simplify this for our own services. Now, before we jump in and check out those application security groups in detail, why don't you go ahead, have a break, grab yourself a coffee or a snack, and we'll pop back shortly for part 2 and take a look at that in more detail. Welcome back to part 2 of Augmented Security Rules, where we're going to take a look at how we can create application security groups within Azure. For application security groups, we're talking about things that represent our own solution. Again, if we had multiple virtual machines, maybe for web servers, database servers, rather than going and configuring those network security groups manually, we can actually simplify this. And we simplify it by saying the network interface cards for these actual real-world virtual machines that represent a real-world solution belong to an application security group called web servers or DB servers. And then we can refer to that within our network security group rules really easily. So what we're doing is we're creating this tag, if you like. It's kind of like a service tag, but it's something we manage. And we assign that to virtual machines within different logical groups. So I really like to think of this as customer managed service tags, but these are referred to as application security groups. Just understand that when you're working with ASGs, there are some limitations with respect to your virtual network. So all of the network interface cards that you are going to assign to an application security group must reside within the same virtual network. So I couldn't create an ASG for my web servers and then have those VMs across different virtual networks. So once again, to understand this better, let's hop into the Azure portal and take a look at this in action. And to do so, what we have to do first is we actually have to assign our NICs to application security groups. So we're going to do so using the Cloud Shell within the portal, and specifically we're going to use the following types of commands. We're going to get details about the network interface for a virtual machine that we already have running. This is our pretend web virtual machine. Then what we want to do is we want to get some details about an application security group, and we have to actually go and assign our network interface card to that application security group itself. So let's hop on over to the Azure portal and check this out. Okay, now what I'm going to do is I'm just going to discard these changes from earlier. And then what we want to do is first things first, we want to create our application security group. So I'm going to click on the create a resource option up here. I'm going to type in application security group. We'll choose the first option here and click on create. Now to make things simple, I'm just going to create this application security group in the same resource group that my web virtual machine exists in. And we're going to go ahead and call this web VM-ASG. And let's just give that a region once again of Australia Southeast. We're going to go ahead, click on review and create, and then click on create. Now with that application security group created, if we actually click on the home and we browse into network security group 1 that we created earlier, you'll see that now if we hop into outbound security rules, we can go ahead and actually get started by using this application security group. So I've clicked on add to add a new rule. I'm going to say that the source is any, the ports are any for the source, and the destination is going to be my application security group. Now you'll see that I've got an option here. I can choose Web VM ASG, which we just created. Let's say in our example that what we were actually allowing was port 80, port 443, and maybe 3389. Now you normally wouldn't mix all of your different ports and protocols like this, but I did just want to demonstrate that you can actually enter in multiple ports within a single rule. So for our example, we're saying we want to allow this access. We're going to leave the priority as 1010, and we'll change the name to allow outbound web ASG. And then we can go ahead and click on add. Now what we've done there is we've created that outbound rule, and it's going to automatically include the IP addresses of any of the resources we have associated with that actual application security group. Now that's not really going to help us at this stage because nothing's associated with that. So let's open up Cloud Shell, and I'll show you the next important part, which is how we actually associate the network interface cards with an application security group. Now just to make things a little bit more clear, I'm going to click on the settings option here and we'll change the font size to large, and I'll expand up that window a bit more. Now what we want to do for this application security group is we want to add the network interface card for our web VM to that application security group. That's how these application security groups actually work. What we do is we have to have that membership. So you could have multiple different web virtual machines and you'd assign them all to be a member of that application security group so that you don't have to worry about managing changes to your security rules if you're going to change things like IP addresses and so on. So in our scenario, let's get started by creating a few variables. We're going to have resource group name, and that's going to be web1-rg, which is the resource group that has our web virtual machine. Then we're going to have the nickname, and let's actually browse into the Azure portal, and we're going to take a look at our web virtual machine, webvm1, and I'm just going to make sure I get the right information for the network interface card. So you'll see it's got a automatically generated name of webvm1723. So let's have that for our nickname, although it would help if I put the $$ at the start there. And let's go ahead and say equal webvm1723. And next what we want to do is we want to have a variable for the application security group. So let's go ASG name equal webvm-ASG. Okay, now what we want to do is we want to get some details about this network interface card because that's what we want to associate with the ASG. So let's go ahead and type nick, and we'll capture all of this information in a variable object. We're going to say equal get as network interface and name. We'll use the nickname, and we'll give it the resource group as well, which is RG name. So what we've done is we've just gathered all the information about that network interface card, we've captured it in a variable, and now we can really easily refer to that with the other commands as well. We want to do something similar for the application security group as well. So let's go ASG equal get hyphen as application security group, if it's going to autocomplete for me, application security group. And autocomplete doesn't seem to want to work for me, so let's just quit. Application security group. Okay, that's better. I'm not quite sure what I did with the top one, but I did something wrong, so let's try this again. Okay, ASG equal get as application security group. We want the name, which is in the variable we have captured earlier, and we also want the resource group, so RG name. Now, if I haven't made any more mistakes, that should go ahead and work. And let's just double check by outputting the data for this variable perfect that has captured our application security group. And that brings us to the final and most important part. Let's go ahead now and associate this NIC with that ASG. To do so, we're going to use the variable we captured earlier. We're going to type in the IP configurations. It's the first IP configuration that we want to change. And so we're going to change IP configurations 0.application security group. And we want that to be equal to the application security group we just captured. So what we are saying is for the network interface card for WebVM1, there's a specific property within the IP configurations, and that's referred to as application security groups, and we want it to be associated with the ASG that we just captured above. Now, we've only actually changed a variable right now. You'll see that we haven't actually changed anything to do with our virtual machine. So what we want to do is we want to go ahead and change our network interface card configuration, and we'll do so using the set-AZ network interface. I'm not doing too well on the keyboard today, am I? And we're going to put in the network interface card that we just captured. Okay, so NIC. Now what we're actually doing in this step is we're saying that we want to essentially enforce those changes that we just made. We want the changes that we just made to this variable to become real. So we're doing so by saying actually go about setting those changes. Okay, and if everything's gone through correctly, and I wouldn't be surprised if it hasn't with all the errors I've been making, then that should go ahead and complete. Awesome, there you have it. Now, I have shown you the long roundabout way because it is always important that you understand how to do these things with features like PowerShell and Azure CLI. Just understand that what we could have done is actually do this through the portal. So if I click on the Home option, I'm going to go ahead and minimize this right now. Then what we're going to do is browse into the virtual machine, so WebVM1. We're going to take a look at the networking section within the settings. And you'll see here we have this option, Application Security Groups. So currently we're a member of the WebVM ASG. You could just click on the option here, but I did just want to show you how to do that within PowerShell as well. Okay, folks, so that's a wrap for this two-part series on augmented security rules. As you'll see here, we've got two really awesome features, service tags and application security groups. And these really just help us to simplify network security group rule configuration by associating the rules with more real-world type services. Service tags for Microsoft managed solutions and application security groups for virtual machines that you manage yourself. As always, I hope you've enjoyed this lesson, everybody. Thanks again for your time, and I'll see you in the next one. Hi, everybody. Welcome back. It's good to have you with me for this lesson on Azure Firewall. Well, we're going to chat about what the service can actually do for us, why we would use it in place of network security groups, and how we can configure and implement it. So let's jump in. Firstly, when we're talking about Azure Firewall, this is different from network security groups. We're not just talking about basic inbound and outbound filtering. With Azure Firewall, we're really focusing on more traditional on-premises type firewall solutions, okay? But just understand, even though you could run some of the traditional firewall solutions within Azure as a network virtual appliance, this is a fully managed solution that's built by the Azure team for the Azure service. So you get full type of integrated support for things like high availability and scale. You can natively integrate with virtual networks, availability zones, and so on. But really, we're talking about capabilities beyond network security groups with features such as fully qualified domain name filtering support. So what are all of these great benefits that we can get by using Azure Firewall instead of network security groups? Well, let's have a look. With Azure Firewall, we actually get a range of different features, but first and foremost, it's important to understand that this is a as-a-service type of solution, and Microsoft used the terminology of unrestricted cloud scalability. So when you look at the traditional approach, you would have your own hardware appliance within your own on-premises environment, and certainly you might still do that in hybrid type topologies. When we're looking at firewalls within Azure, however, we would typically use something like a network security group, or if you weren't happy with the features provided there, then you would deploy a virtual machine that operates as a firewall, and we call this a network virtual appliance. Now, you'd have to go about managing the high availability, trying to deploy multiple virtual machines, synchronizing configuration, ensuring that the scale was right, managing the licensing. I can tell you from experience that really it was quite a pain. And there were some vendors that were quite good at supporting Azure, and they were really cloud first. They'd built new solutions, documented it. They had engineers who were really skilled working with it. Or you could have some other vendors who were just creating a firewall there because they kind of had to. Now, certainly when you're looking to deploy security for Azure, you might not just rely on the Azure firewall. You might have your own on-premises solution, or you might instead prefer to use the third-party solutions, because there are a lot of features with Azure Firewall, but there are still some traditional type firewall functionality that's missing. But in terms of what we do get, well, firstly, we get support for fully qualified domain names. This is a really big and important one when you're working with firewall type operations within Azure. You don't want to be having to remember IP addresses like we saw within the augmented security lesson. That's really difficult to do, and that's why we use things like service tags and application security groups. So the idea that we can actually, instead of using IP addresses, create rules that rely on fully qualified domain names actually simplifies the job of security operations a lot. With that being said, we do still get functionality that you would come to expect for typical firewalls or network security groups. So the standard type of source, protocol, destination type of rules that we've already seen. What we also get access to is something referred to as DNAT and SNAT. This is where we're just talking about inbound and outbound rules that specifically go about assigning public IP addresses to those operations. What do I mean? Let's say you had a virtual machine in your virtual network, it was a web server, and it needed to have public accessibility for your users. You would want to allow that type of access inbound from your users to that virtual machine. When you're using Azure Firewall, what you do is you assign a public IP address to your Azure Firewall, you provide that IP address to your end users, and then the inbound connection will hit your firewall and then be what we call NATed, if you like, network address translation, will take place and send that traffic off to your virtual machine. You can do the same sort of thing with outbound, where you say, I want my virtual machines to have the public IP address of the firewall, instead of having to assign public IP addresses to your virtual machine resources. Another cool feature we get access to is threat intelligence. So Microsoft will actually go about automatically using the Microsoft security team's knowledge of malicious and unsecure IP addresses, and it can help with flagging those as being risky. And finally, given this is an Azure service, we do get some integration with the Azure Monitor solution itself. So that's great. We've seen Azure Firewall. It's really a great step in the right direction toward having a fully managed firewall as a service. How do we use it? Well, first things first, we need to deploy our Azure Firewall service to a virtual network. Now, just understand that when you do so, you can deploy it to a virtual network that contains your existing resources. With that being said, a lot of times you're going to hear about the hub and spoke topology. This is where you have a centralized virtual network that has a range of central core services for your environment. That can be Azure Firewall, it can be other virtual machines, and so on. And you might have a range of other spoke virtual networks that connect to this central virtual network using things like peering. Now, the Azure Firewall service does support these types of advanced and complex deployment solutions. So if this is the type of virtual network topology that suits you, Azure Firewall can support you. However, what we're just going to look at is a basic deployment to a single virtual network. Now, whatever type of topology you have, you need to deploy your Azure Firewall to a Azure Firewall subnet. It actually has to be called Azure Firewall subnet. And if you don't have a subnet called that, you won't be able to create the service. Now, once you've actually got your Azure Firewall service up and running, how are you going to use it? Okay, let's have a think about what you have within your environment. You might have virtual machines within another subnet within your virtual network. Well, even if you've deployed that firewall service, nothing is going to change. Okay, you can already get that standard type of connectivity based on the default connectivity that exists within virtual networks. So a virtual machine and a subnet within the same virtual network could access the internet. So to change this, you need to configure routing. You need to configure custom rules that will force whatever traffic you desire to go via the firewall. Now that's up to you. You could have custom rules that say all traffic between subnets to the internet to other spoke virtual networks all have to go through the Azure firewall. Or you might just say only inbound and outbound when we're talking about the public internet. That's up to you. It's up to your requirements. I would say just be mindful of the amount of load you're going to put on your firewall if you do subnet to subnet filtering. You might have, for example, a database server in one subnet and maybe an application server in another subnet. Now, if that's a really chatty solution where the data is flowing back and forth all the time, then pushing it through the firewall might not be a great idea. It's going to depend on your own environment. But whatever case, if you want to leverage the firewall, you're going to need to configure those custom routes to push the traffic through. Well, we've now covered the theory for Azure Firewall, but before we jump into the portal and check things out, why don't you go ahead, grab yourself a break, a coffee, a drink, whatever suits your fancy, and we'll pop back for part 2, where we're going to take a look at actually performing the implementation, configuring the firewall, and testing it out with a virtual machine in a virtual network. So thanks for your time. I'll catch you in part 2. Hi folks, and welcome back to part 2 on the Azure Firewall lesson. Let's go ahead, jump into the Azure portal and get started with the configuration and testing of the Azure Firewall service. Okay, here you'll see I'm in the Azure portal, and what I'm going to do is I'm going to take a look at Virtual Network 2. Now the first thing we need to do if we wanted a firewall within the subnet is click on the subnets option and go ahead and create a new subnet and call that Azure Firewall Subnet. Now when you do so, just bear in mind that you don't need the subnet to take up a lot of space. So for example, we might create this with 10.2.250 and maybe we only need a /27, for example. You'll see here that's going to talk about how many actual IP addresses we're reserving for this subnet. Now, given the Azure Firewall actually scales itself, at a bare minimum, you do actually need to have a /26 subnet. It doesn't have to be bigger than that, so we don't need a /25 or a /24, but you do need it to be a /26. This is just so that there's enough space within this virtual network for Microsoft to manage the underlying infrastructure that facilitates the Azure Firewall service. The other thing to bear in mind about this subnet is that it cannot have network security groups associated with it. You must leave them not attached because this subnet is going to be dedicated to the Azure Firewall service. So we can go ahead and click on OK, and that would be our virtual network up and running, ready to go. Now what we want to do next is we want to click on Home, and we can actually browse to the All Services section or the Firewall section, or you might click on Create a Resource. If you go to Create a Resource, just type in Firewall, and you can click on the Firewall option, and then go ahead and click on Create. Now the other funny thing about deploying an Azure Firewall, and this probably will change in the future, is that the resource group this firewall is deployed to must match the resource group of your virtual network. So let's say I typed create a new resource group and I said firewall1-RG, click on OK. Now when I navigate down to the virtual network section, if I said create new, that's okay. But if I choose use existing, that's not going to work, okay, because these do in fact need to match. So what I'm going to do in this example is choose the resource group of my virtual network number 2, and then make sure I choose the correct region, so Australia Southeast. And then if I choose the virtual network option, you'll see I can pick the option here. Now if I choose VNet 1, that's not going to work because the resource group doesn't match. VNet 2, I'm good to go. Now of course the Azure Firewall, being a service that allows inbound and outbound connectivity, is going to need a public IP address. So you can just go ahead and click on Add New, and you'll see that what it is doing is it is creating a public IP address with the standard SKU and a static assignment. So I'm just going to say for this example, firewall02 PIP, and then we're going to go ahead and click on OK. Now we better give our firewall a name, so let's call that firewall02, and then we're good to go. We've left everything as is. We've got a public IP address for our firewall. It's within our virtual network. Let's go ahead and click Review and Create. That's all validated successfully, so I'll click on Create. Now this can take some time to actually deploy, 15, 20 minutes or so. So let's do the magic TV trick, and here's one I prepared earlier. I'm going to click on Home, and I'm going to type in Firewall. Okay, so let's browse across to the Firewalls Services section, and you'll see I already have this firewall that I created earlier, pretty much with the same sort of settings that we just looked at, but within Virtual Network 1. So we're going to open Firewall Test 1, and this is where all the magic happens. So what I want to step through now is just a couple of important things. When you are going to create the rules within your firewall, there's really three main types of rules that you're going to work with. There are network rule collections, application rule collections, and NAT rules. Network rule collections are pretty much what you would come to expect from network security groups. So if I click on the Add Network Rule Collection, you'll see we're getting slightly different interface, but very similar types of properties and characteristics of our network security group. So we can select the protocols, TCP, UDP, ICMP, or any. We can have source IP addresses as well, and so on. So nothing really new here. Now, if you're wondering, what about augmented security rules? Well, we do still get access to service tags. So you can see down here, we can fill out the same sort of details and get access to all of those different Microsoft service tags like we spoke about a moment ago. So if that's already the standard functionality, you might be saying, well, why do we really care about Azure Firewall? Okay, so let's actually browse back a step. I'll discard these changes and let's take a look at application rules. If I click to add an application rule, you'll see things are slightly different. We've still got name, priority, and source, and so on. But what we're now talking about are fully qualified domain names. And this is something that's pretty cool and quite a lot different to network security groups. You'll see we have two different types. We have FQDN tags, which are these Microsoft built-in ones that you can see here. Windows updates, HD Inside, Azure Backup, and things like that. Now, these are managed by Microsoft. If you want to have your own fully qualified domain names in use, then you can use the target FQDN section instead. So let's say, for example, I wanted to create a firewall rule. And what I wanted to do was have it so that the virtual machine within VNet 1 could only access Google, for example. Now, I could go about creating network security group rules, but we know that that's only going to allow me to configure 80 and 443 for the ports and protocol. And then I'd have to try and add all of the public IP addresses for the Google website. That's going to be really, really hard. So this is an example of where you're going to want to use FQDNs. I could, for example, type in www.google.com, and I might even add in there just google.com as well. Okay, so I could say Google, and I could have the source type as IP address, I could have the source as any, and I could have the protocol as being HTTP and HTTPS. Now, when I create this rule, let's give it a name first and foremost. We'll say Google allow. We'll give it a priority of 110, and we'll leave it as is and go ahead and click on add. What we're doing now is we're saying, okay, we've created this new rule collection. Microsoft's going to automatically deploy it across any underlying Azure firewall infrastructure. And as long as we are using this firewall for our virtual network, then only that HTTP and HTTPS traffic is going to be allowed for www.google.com and for google.com. Okay, so we've got network rule collection, application rule collection, and then we've got NAT rule collection. Now, when we have a look at NAT rule collection, what we're talking about is inbound access. Let's say, for example, we had virtual machine 1 within this virtual network, and we wanted to allow RDP access. It's a Windows server. We could create an inbound rule, and we could allow 3389. Now, this is where you're going to see things start to differ, and you might actually already start to ask a couple of questions. 1, what public IP address are we going to use for our virtual machine? And 2, why have we not been specifying inbound or outbound so far? Okay, these are some important differences with the Azure Firewall Service. With NAT rule, we're talking about inbound, so we don't need to specify the direction. If we just close that rule collection right now, and then we browse into the application rule collection, let's take a look at that rule we just created. Now, do you see the direction there anywhere? No, there's no inbound, there's no outbound. With Azure Firewall, when we use application rule collections, we're talking about outbound traffic. With network rule collections, again, we are talking about outbound traffic. If you want to configure inbound traffic, this is where we use the NAT rule collection. And really the reason for this is that when you are forcing all of your traffic through the Azure Firewall from other subnets, you're only talking about outbound traffic. When you're talking about inbound traffic, you're actually talking about the address translation, because you have to allow traffic to hit your firewall and then be translated and pushed off to your virtual machine instead. So let's just take a look at how this works. If we browse to the public IP configuration for our firewall, you'll see we have a public IP address. Now you'll also see that we can add more public IP addresses as well. Okay, now I currently have all of my public IP addresses in use, but understand that your Azure Firewall can actually have multiple public IPs. So if we wanted to create an inbound rule that was going to allow inbound access to a virtual machine behind this firewall, then we're going to need to use that public IP. So I'm taking a copy of this public IP address. I'm going to browse back into the rules section. Let's go into the NAT rule collection. We'll add a new rule. And what we're going to do is create an inbound rule called inbound RDP for VM1. We're going to give this a priority of 110. And then what we want to do is say RDP inbound VM1. And we will put the protocol of TCP. We're going to say the source is going to be an IP address. The source can be any. We're going to allow any traffic inbound to RDP on VM1. But again, really best practice would be that we lock that down to public IP addresses that we know. For example, I could type in my public IP address of my home computer. Now for the destination address, you're going to use the public IP address of the Azure Firewall service. If you do copy paste, just make sure that you delete that space at the front, or the rule is not going to work. For the destination port, we want to have port 3389. Now for the translated address, this is where we point to the IP address of the VM that sits behind the firewall. So 10.1.1.4. I think that's correct, but we'll double check that shortly. And you'll see the last part we get is the translated port as well, which we're going to leave as 3389. So what we're doing here is we're saying that if someone points to our Azure Firewall public IP address of 20.46.106.83, then we're going to force that traffic to go across to our virtual machine that sits behind the firewall. This is essentially what NAT is. Network address translation is where we translate from one address across to another. So let's go ahead and click on Add. And now we've got all the rules that we really want within our Azure Firewall. This would currently allow a virtual machine behind the firewall to access Google and to have inbound access to RDP if it matches that IP of 10.1.1.4. The last thing, of course, that we need to do is browse back to home, browse to our virtual network, and make sure that we have user-defined routes configured appropriately. So to do so, let's have a look at our subnets. You'll see we've got subnet 1, and this is where we're going to have our virtual machine VM1. Then we have our firewall subnet, Azure Firewall subnet. Now what we would need to do is create a user-defined route and associate this with subnet 1 to push traffic across to our Azure Firewall. Now I've actually already gone ahead and associated this. You'll see I have a route table called via FW1. So let's just go ahead and check that out. I'm going to type in via FW1, and we're going to take a look at this route table right now. Now you'll see that what I have done with this route table is I have created a route. Let's take a look at that. It's called Internet via FW1. What we are saying here with 0.0.0/0 is that for any traffic that's destined for the internet, I want it to go via 10.1.254.4. So for the next hop, I choose virtual appliance, and then I've typed in the private IP address of the firewall itself. So what is this doing? Well, for any subnet that has this route table attached, it's saying if I'm going to the internet, I have to go via the Azure Firewall service. You do need this route table associated with any subnet that you want to use the firewall for. Okay, so we've got all those rules configured. Let's go ahead and check it out. I'm going to browse back to home, and we're going to open up our virtual machine within VNet 1. So we're going to browse into VNet 1. I'm going to take a look at connected devices, and you'll see we have VM01 connected here with 10.1.1.4. So I got the private IP address correct. it's currently got a public IP address associated with it. Now let's actually just navigate into IP configurations, because for our virtual machine, we don't need it to have a public IP address. It's now going to use the Azure Firewall service instead. So we're going to save the update to this virtual machine. What do we have now? Let's quickly summarize before we test everything out. We have a virtual machine within VNet 1, has a private IP address only. We have an Azure Firewall service within an Azure Firewall subnet, also within VNet 1. Subnet 1 is forcing all internet traffic to our Azure Firewall service using the IP address of the Azure Firewall. And we have the rules configured in our Azure Firewall to allow outbound access to Google and to allow inbound access via RDP. So what do we want to do now? What we want to do now is browse back to home, take a look at the firewall service. Let's browse into Firewall Test 1. We're going to navigate into Public IP Configuration. We're going to take a copy of the public IP address right here. And then what we're going to do is browse across to an RDP window. Let's type rdp:// and we'll paste in that public IP address. Okay, excellent. There you have it. We are connecting to that virtual machine via the public IP address of the Azure Firewall service. The last thing to check is to see whether or not we actually have outbound access to Google. So let's open up Internet Explorer, and we're going to browse to www.google.com and go ahead and press enter. Okay, so Google is working, RDP inbound is working. Let's just try the competition here, www.duckduckgo.com. And that is not working. And as you'll see, the firewall itself has actually responded back saying there is a deny. We have the default deny rule, there is no matching allow rule, and so the traffic is blocked. So there you have it, folks. Thanks for sticking with me for this two-part series on Azure Firewall. As you'll see, Microsoft have made leaps and bounds in terms of improving the network security features available, and specifically Azure Firewall helps us to get traditional on-premises type firewall capabilities through a as-a-service type offering from Microsoft. Hope you've enjoyed this lesson, folks. Thanks again. I'll catch you in the next one. Hi everybody, and welcome to this lesson on Azure Bastion, which is a really cool service we're going to learn about that helps us to provide secure management connectivity to our virtual machines. Within this lesson, we're going to have a chat about some important considerations for configuring the Azure Bastion service, and we'll jump into the Azure portal and check it out. So let's get started. When you're working with Windows and Linux virtual machines, you're really commonly going to have to connect to them to perform some management and configuration tasks, because more often than not, your virtual machine is not going to be ready for your purpose. You build it, you deploy it, but you need to hop onto the operating system and perform some tasks. To do so, we're really commonly going to use RDP for Windows or SSH for Linux. Now, when we use Azure Bastion, what we're doing is we are providing a secure and convenient way to use these management protocols for our virtual machines. So let's have a think about what we would normally have to do when we want to connect to our virtual machines. We know we would have to create a public IP address for our VMs. We might have to configure network security groups, or if we're using the Azure Firewall service, we're going to have to configure some NAT collection rules as well. Well, with Azure Bastion, if all you want to do is connect via RDP or SSH to a VM, you don't need to do any of that, okay? You can still use these protocols, RDP and SSH, but it's really simple to get access to them, all within the Azure portal. So what we're talking about is a service that provides RDP and SSH access over this really secure SSL tunnel, and it's really easy to configure, and it doesn't require the normal types of things we need, such as configuring public IP addresses and configuring network security groups. So what does this actually look like? If we want to get this secure SSL-driven RDP and SSH access through the Azure portal, how do we do so? Well, what we want to do is firstly, we need to create a virtual network. If you have this virtual network all ready to go, that's perfectly fine. You can use a pre-existing VNet, but what we do need to configure is this special Azure Bastion subnet. Similar to with the Azure Firewall, this is a purpose-driven subnet that can only be used for the Azure Bastion service. So if we have some virtual machines within our virtual network and we want to get access to them through RDP and SSH, then we deploy this Bastion service or the Bastion host itself to a subnet within that virtual network. What we want to do next is we actually just simply connect through the Azure portal to our virtual machines. Now, it's good to know that with the Azure Bastion service, it can be virtual machines that we connect to, or it can actually be instances within a VM scale set. And we'll see how this looks through the Azure portal shortly. So that's all there is to it. If you want that really secure encrypted tunnel to connect using SSH or RDP to your virtual machines, that's really all you have to do. It's such an easy service to use to help secure connectivity to your environment and to help improve the efficiency and simplicity of actually connecting to the service. Just understand that when you are using Azure Bastion, the browser that you use to connect to your virtual machines must support HTML5, and you do need outbound 443 connectivity. So the connection from the end user goes through the Azure browser. It uses a SSL tunnel over 443, and it provides that access through the browser for RDP or SSH. So pretty straightforward, right? Let's jump into the Azure portal and see how this looks. Okay, now I'm logged into the Azure portal, and what I'm going to do is I'm going to browse into Virtual Network 1, which we've been working with a little bit so far in previous lessons. So I'm popping into Virtual Network 1. If I have a look at connected devices, I can see we've got a firewall here, and we've got a virtual machine with an IP address of 10.1.1.4. If I take a look at subnets, you'll see that I've already created this special subnet that we need called Azure Bastion Subnet. This is how it has to be named. And similar to the Azure Firewall service, we have to have at least a /27 sized subnet. You can't do /28. You could do /24 if you want, but that's probably going to be a bit of wasted space within your subnet. So probably best to just stick with a /27 in most cases. Now understand that with this service, you can use network security groups, unlike the Azure Firewall service. However, you shouldn't be using a route table to push this traffic through an Azure Firewall service. You do not need to do that. Your virtual machines that you want to access, you could use the Azure Firewall service, but that really defeats the purpose of the Azure Bastion service. So if you're using both services, what are you going to do? Well, you're going to continue to have the firewall route table configured like we spoke about in the Azure Firewall service, but that's only going to be associated with the subnets that contain your virtual machines. It is not to be associated with the Azure Bastion subnet. Just make sure you don't have that attached right here. You can have NSGs, but you should not be using a user-defined route to push traffic through the Azure Firewall service, or through a network virtual appliance if that's what you have configured instead. Okay, so we've got this subnet ready to go. What do we do next? Let's browse back to the home. I'm going to navigate into the Bastion's service section, and I'm going to click on Create Bastion. Now I'm going to create a new resource group. Let's just call this Bastion1-RG. Click on OK. I'm going to give this a name of Bastion1, and for the region, I'm going to choose Australia Southeast. Now you'll see for the virtual network, I can choose the existing virtual networks. I could have actually created a brand new virtual network, but just understand that at least right now, your virtual machines that you access with the Azure Bastion service must be within the same virtual network. Unfortunately, right now, Azure Bastion does not support VNet peering, although this is something that the Microsoft team have noted they are going to support in future. So what we're going to do is we're going to choose VNet 1. That contains the Azure Bastion service we already configured, and it contains Virtual Machine 1 that we can test out this service with. Now for your Azure Bastion service, you do need a public IP address. You can use an existing or create a new one. I'm just going to create a new one here. We're going to call this Bastion1-pip, and then I'm going to go ahead and click on Review and Create. Validation has succeeded, so let's go ahead and click on Create. Now, as this can take a little bit of time, I'll speed things up until we're ready to go, and then we'll pop back and take a look at how we can connect using the Azure Bastion service. Okay, great, that Bastion has been deployed. If we navigate to the resource, what you're going to see is there's not really a lot we can see here about this. From a management perspective, we could jump into sessions and take a look and see who is currently connected and what VM they are connected to, and so on. And if you needed to, you could navigate to diagnostic settings or logs and configure some monitoring for this Bastion itself. However, the true magic for the Bastion service actually happens within the virtual machine pane. So if we navigate into Virtual Network 1, I'm going to go into the connected devices. I'm going to choose Virtual Machine 1 here. I've come a bit of a roundabout way, but just so you can see, this is the virtual machine we're talking about, which is connected to VNet 1, which we have the Azure Bastion service configured for. So this is our virtual machine, and you'll also see we have no public IP address associated with this VM itself. If I click on the connect option here, we have RDP, SSH, and we now have the Bastion option. It's this Bastion option that we have just really configured. And if I go ahead and type in my credentials, what we're talking about is providing this connectivity through the browser itself over SSL, so it's nice and secure. Using this HTML5 capability, we can go ahead, click on connect. And of course, that's not going to work for me because I have pop-up blocks enabled. Let's just quickly change those settings, click on done, and I'll click connect once again. And this is the Bastion service we are seeing. So really, it's all managed by Microsoft behind the scenes, and nice and easily, I'm connected onto a virtual machine. You'll see it's still got the same information we had from the Azure Firewall lesson. So that's it, folks. That's all there is to it. Really nice and easy to get management access to your virtual machines simply and securely with the Azure Bastion service. So that's a wrap for this lesson, folks. I hope you've enjoyed it. I hope this will be helpful in your own environments or when you're working with virtual machines yourself. Thanks again. I'll see you in the next lesson. Welcome back, everybody. Thanks for joining me for this lesson on Azure Load Balancer. In this lesson, we'll chat about the purpose of the load balancer. I'll briefly mention some differences with the application gateway. Then we're going to jump into the Azure portal and actually load balance a really basic static website. So let's get started. When we think about solutions that we want to deploy to be highly available, we should know that we need to do so with redundant resources. So let's have a think about a scenario. You're deploying a static website, and to do so, you've got 3 virtual machines that all serve that same static website. We do this because we want to allow traffic distribution from our users to these resources depending on which one of them is available. But let's have a think about how you might do this without a load balancer. Well, you can create some sort of DNS entry. It might be www.yoursolution.com, and when the user loads that up in their browser, they are navigating to a given resource. Your DNS entry can point to a single resource. Maybe that's the virtual machine with a public IP address. Well, what happens when that virtual machine goes offline? What are you going to do? Okay, are you going to tell your user to use a new address, maybe www.yoursolution.com, or are you going to update DNS yourself manually, or are you going to make some other change through some other form of application configuration? Well, if we don't want to do it this way, if we know that we're building a solution that's going to be backed by redundant resources, what we really want to have is some sort of central resource that our user can point to that is going to automatically be distributed amongst these back-end resources. This is what we're talking about with the Azure Load Balancer. Traffic distribution automatically from a central point to these back-end resources. A really key point to understand about the Azure Load Balancer is that what we are talking about is layer 4 traffic, so TCP and UDP protocols. Now I'm calling this out because when we talk about the application gateway, which we'll do shortly in a separate lesson, you'll see that the application gateway is far more aware of web applications and what they're doing and URLs and things like that. Whereas with the load balancer, we're just simply talking about layer 4. So you point your users to this load balancer, and then it sends that layer 4 traffic onwards, depending if the resource is healthy. Now, understand that, of course, we do need to have these redundant resources. There would be no point for us to put a web server here and maybe a database server there and some other application server here, because if one of them goes down, well, no one's going to be able to access your content. These really need to be redundant services within your solution. That's a really common part of architecting highly available solutions, is having redundancy within a specific tier: web, database, application, or so on. And when we use the load balancer, it's good to know that we get a range of specific load balancing features, such as session affinity. So we can say that once a user has connected, they should always connect to a same resource. And we get things like health probes. So don't use a virtual machine if it's gone offline. Now that's really just tipping our toes into the water with features, because there are a lot more when we're working with Azure Load Balancer. First things first, it's good to know that we can use the load balancer both publicly and privately. So you could deploy your load balancer in a public configuration, which means it gets a public IP address and it can be accessed externally by your external users. Or you could deploy it in a private configuration, so it's deployed to your virtual network and it's only accessible to resources within that virtual network. When we deploy our Azure Load Balancer, we get two main modes to do so. This is referred to as basic and standard, and we'll talk more about this shortly. Now, when we use the standard deployment SKU, we actually get improved high availability because we can leverage availability zones for zonal and zone redundant solutions. So that's just something to bear in mind. Now, of course, with our Azure Load Balancer, we do get a health probe because there's really no point in distributing load to resources in our backend if they are offline. So again, depending on the SKU we use, whether that's standard or basic, we can get access to TCP, HTTP, and HTTPS probes in order to determine whether or not the service in our backend is actually healthy. Now, if we just use the basic SKU, that is only going to give us access to TCP and HTTP. However, if we have the standard SKU, we also get the added HTTPS health probe as well. Next, when we're using our Azure Load Balancer, we can in fact actually configure port forwarding. So it's not just about distributing information from a front-end load balancer to back-end resources. What we can actually do is configure direct access to one or more of our resources that sit behind the load balancer. Because normally when you configure a load balancer, users are going to point to that load balancer and information will be distributed to any of those different resources in the back-end pool. But there are, of course, circumstances, maybe you want RDP or SSH access to your backend resources, where you might need to configure that port forwarding for direct access. Last but not least, it is good to know that with our load balancer, given these resources are sitting behind it, if they do still need outbound access, we can control that outbound connectivity by providing access from the backend resources through the load balancer to access external resources. So now that we understand the purpose of our load balancer and several of the key features, let's have a chat about how it's in fact configured before we jump into the Azure portal. The first thing we need to know is that our Azure Load Balancer has a front-end configuration. If we choose to deploy that as public, it'll be a public IP address. If it's private, it will be a private IP address within our virtual network. After we've configured that front-end IP, it's important to understand, of course, that we have the back-end resources. You might say that these are kind of the two key components of our load balancer service. The front end that users are going to be pointing to, and then the back end resources that will actually provide traffic to our users through the load balancer itself. Now, to actually connect these two things together, there's actually a couple more components we need to know about. Firstly, we have something called health probes, as I just briefly mentioned. What we're doing with a health probe is we're looking at TCP, HTTP, HTTPS across all of the resources in the backend pool to determine whether or not they are healthy. If they are unhealthy, then we don't want to use them within that backend pool. Okay. The other important component of our Azure Load Balancer in terms of configuration are the actual rules themselves. This is kind of where we pull all of the different pieces together. We configure the inbound, the outbound rules, we tie together the health probes with the backend pool, and we associate a front-end configuration with a backend pool. So what we've spoken about now is a summary of the purpose, the configuration, and the features. What we'll do next is we'll jump into the Azure portal and actually get started with the configuration of this solution using a couple of virtual machines that provide access to a static website. Now, as this can take a little bit of time, what I'll do is I'll split this video in two. Feel free to grab a break, a coffee, a snack, whatever tickles your fancy, and we'll pop back shortly for part 2 and take a look at the actual configuration. Hi folks, and welcome to part 2 of this lesson on the Azure Load Balancer. Now it's time for the rubber to hit the road. Let's get our hands dirty. Let's jump into the Azure portal and get started with the deployment of an Azure Load Balancer itself. Before we do so, let's just quickly take a look at a couple of resources I already have configured. So if we have a look at VNet 2, you'll see that within this virtual network, I actually have a couple of virtual machines. I know I'm showing you a bit of a roundabout way to see this, but it's really the network side that we are most concerned with. And these are within subnet 1. Now, just understand within this virtual network, we do have an Azure Firewall subnet, but it is not currently connected to subnet 1. So what we're going to do within this lesson is we're going to configure the Azure Load Balancer. We're going to get it to point to these two virtual machines because these virtual machines have a static website running. So if we actually quickly take a look at this resource, let's just take a copy of this public IP address. I'll paste it up here I'll get rid of that funny part at the end there. You'll see that this first virtual machine has a static website with the following content. And if we take a look at the second virtual machine, we're going to see something very similar. So I'll jump onto virtual machine 2, take a copy of that public IP, paste it in and get rid of that part there, and boom. Now, normally when you're configuring an Azure load balancer to a backend solution, they're not going to provide different content. They're going to provide exactly the same content. So I'm just doing it this way so we can actually test the service and we can see that traffic is going to different resources. Okay, so let's jump in. Let's get started. Let's point our load balancer to these two Windows Server virtual machines that are running IIS with some static content. So what we want to do first is we'll browse back to the home and we're going to click on the Create a Resource option. We'll go ahead and type in Load Balancer and I'll choose the first option right here and we'll create this Microsoft Azure Load Balancer. Now you'll see that Microsoft is calling out first and foremost that what we're talking about is layer 4. Remember again, this is not application aware. Even though I've got a static website running here, you don't actually have to be using the load balancer for web applications. It might be a database backend, it might be a fully redundant application server. When we're using the load balancer, we're just distributing that layer 4 traffic. So you can really actually choose what type of backend resources you have as long as they are network connected. So let's go ahead, we'll create a new load balancer resource group and call that LB01-RG. Click on OK. We're going to call this LB01, nice and creative again. And of course, no surprises here. You've guessed it. Let's go for Australia Southeast. Now what we're going to do is take a look at some of the important characteristics of our load balancer. First things first, is it internal or is it public? You'll see if we choose internal, we're deploying it straight to a virtual network and we're giving it a static or dynamic IP address that's going to be private. We could, of course, choose to use a public deployment, and that's what I'm going to do within this example. So public or private really depends on the solution you are configuring and whether you want it to be publicly accessible. It could be an internal intranet, for example, and maybe you only want to use this internally. Or like our scenario, maybe you've got a static website and it needs public accessibility, so you're going to choose the public type. The next and one of the most important configuration items for our load balancer is the SKU. You'll see we get basic or we get standard. Now, I'm not going to go through all of the differences for you. I'll include a link within the description below for this video to show you the important information. But really, when you're going to configure this solution, Microsoft these days is recommending that you use the standard load balancer. That's the preferred option. Now, when you use the standard load balancer, you're going to be forced to use a standard public IP address as well. And as we should know with standard public IP addresses, that means that we need to have a network security group to actually allow connections inbound. If you go with basic, it's going to use the basic public IP address SKU. These have to match. And so if you use basic, you don't need to have a network security group to explicitly allow your inbound traffic. We're going to go ahead and choose standard, but if you do choose standard, understand that there are a range of different features such as how many backend resources you can have in the pool, what types of endpoints you can have. So for example, with the basic, you only can have virtual machines in an availability set or a VM scale set. But with standard, you actually get more options. So you could have any virtual machines or VM scale sets in a single virtual network. It doesn't actually have to be within the same availability set. And as I mentioned before, for health probes, you actually do get the HTTPS option as well. The last and probably the most important component of choosing the standard SKU is that you get support for zone redundant or zonal pinned front ends for your actual Azure load balancer itself. So let's take a look at this. We're going to choose the standard option. We're going to go ahead and create a new public IP. We'll just call that LB01 pub. I'm going to go ahead, click on review and create. And if this all passes successfully, awesome, let's go ahead and click on the create button. Now, as always, this can take a little bit of time, so let's speed things up through the magic of video and I'll pop back shortly. Well, there you have it. I didn't actually even need to pause or change the video there. It's created nice and quickly. And that's probably due to the fact that it's really simple to create the Azure Load Balancer these days without actually having to go through the configuration at the outset, which sadly is a little bit different for the application gateway, which we're going to see shortly. So let's jump into that load balancer right now. And what we're going to do is take a look at the configuration of this solution so that it can map to these virtual machines that exist within our virtual network. So first things first, let's just have a quick look at the front-end IP configuration. You'll see we have the front-end IP and it's currently matched to that new public IP address that we created. Now we could actually add more front-end IP configurations if we wanted to. And this is really going to come down to your solution and whether you are using a single load balancer to access multiple different backend resources, or if you're just using a single load balancer for a single highly available solution. In our scenario, we're happy as is with the single public IP, so let's leave that one as is. Next, what I want to take a look at is the backend pool, because as I mentioned earlier, this is one of the other key components of our load balancer solution. This is where we go and say, what resources do we actually want to use for this solution? Let's just give this a name of BE Pool 01, and we're going to pick the virtual network that contains our resources. In our scenario, that's VNet2 for our 2 virtual machines, and you'll see here that we can actually choose to add virtual machines, or we can choose to add a VM scale set. It's really common to use a Azure Load Balancer service with virtual machine scale sets. Why is that? Have a think about the different types of resources that we have in our backend pool. What do they look like? Well, of course, we know for high availability, they are going to be redundant within a single given application tier. And a VM scale set helps us to really easily deploy redundant virtual machines that serve exactly the same purpose and that can shrink and expand in response to demand. So something really common to use with the Azure Load Balancer service. In our scenario, let's just go ahead and add 2 virtual machines so that we can see this in action. Now this brings me to one other really important consideration. When you are adding virtual machines to the backend pool for your load balancer, once again we are seeing that we have to match the SKU that is used. So for the virtual machines that I used earlier, we actually have public IP addresses using the basic SKU. I wanted to do this intentionally just to demonstrate that if I do so, I can't actually include them within the backend pool. So what I will do is I'll really quickly pause the video. I'm going to remove the public IPs from these virtual machines because we no longer need them. And that allows me to demonstrate another feature, which is the NAT inbound rules as well. So give me one moment and I'll pop back shortly and we'll get these VMs ready to go. Okay, awesome. That's ready to go. Let's go ahead and add these 2 virtual machines to this load balancer, and then we can take a look at some of the other rules as well. So that's all we need for our backend pool. What we've said is that we want these 2 resources to be in a pool called BE Pool 01, and then it's actually up to the rules where we go and associate this with the public IP or the front end of our load balancer. Now just understand that whilst you are doing this, it can actually take some time for the configuration to complete. What we are doing here is not so much saying that we just want these resources to exist in a backend pool, but we're actually changing the network configuration of these 2 virtual machines. So for WebVM1 and WebVM2, the networking itself is actually going to be updated to attach those VMs to this load balancer itself. If we took a look at the virtual machine configuration and we had a look at the network settings, we'd actually see that in the load balancer portion, these are now associated with this load balancer. Now next, what we want to do is have a health probe just to determine whether or not the resources in our backend pool are actually healthy and available to service traffic. So let's go ahead, click on add, and we're just going to make a basic probe. We'll call this probe 01, and you'll see there we can choose TCP, HTTP, or even HTTPS. Again, you're only going to get that HTTPS option if you're using the standard SKU, but let's just go ahead in our scenario and we'll use HTTP. You'll see what we're doing, and this is quite similar for the HTTPS option, is we're actually specifying the path, the URL that this probe should be checking to see whether the backend service is available. In other words, this probe is going to talk to WebVM1 and WebVM2, and it's going to check that it can respond on port 80 with just an empty path, but we could actually choose to put whatever we want in there. We could have images, for example, really depends on your scenario. This is different to the TCP option, which is just going to check that port 80 is actually responding. Okay, so we're happy with this probe. We're happy with checking the base URL. We're going to do that on an interval of every 5 seconds. And this is going to wait for 2 consecutive failures before it actually says that a resource within the backend pool shouldn't be used for load balancing. So let's go ahead and click on OK. And now what we want to do is tie it all together. So let's go into load balancing rules. We're going to click on add, and this is where we're going to tie all of the configuration together. Let's just give this a really meaningful name of rule 1. Apologies for my creativity. And what we're going to do next is choose the IP version, which in our scenario is IP4. You'll see this is where we select the actual front end that we want to associate this actual connection with. So we only have the one. We'll choose that now. And our scenario is going to be protocol of TCP, port 80. You can actually choose to change to translate the backend port if you so desire. So for example, if you wanted the users or the service that is accessing your solution to use port 80, but your backend resources actually hosted that on something like 8080, then you can go and translate that with this option as well. We're going to tie this together with BEpool01. We're going to use the health probe that we just created, and then you get to see here we can configure an important thing called session persistence, which I mentioned in part 1. With session persistence, what we are doing is we are saying, should we actually force that after a user or after a service connects to our solution, it's going to continue to use the same resource in the backend pool? Now, as an example, you might do this for a web application where the backend resources, WebVM1 or WebVM2, are actually going to maintain some information about users when they connect to the solution. If you do have this, if you do need to have what is sometimes referred to as sticky sessions, then we can choose to do so with the client IP, which means that when someone connects with the same client IP, they'll always go to the same virtual machine within our backend pool, or you can choose to do so with client IP and protocol, which means it's going to pick this combination to ensure that a session is sticky. Then session persistence is how you're going to do so. In our scenario, both of the resources in our backend pool are simple static resources. They don't maintain any information about the user or the service that is connecting to our solution, so we're going to leave session persistence as none. Okay, now we're going to leave the rest of the options as default. When you're talking about something like floating IP, it's a really specific scenario for things like SQL always-on availability groups, and that's really specific to given solutions that you are going to load balance. So we don't need to focus on that right now. So if we go ahead and click on OK, then we've really now got everything that we need to actually start load balancing inbound connections to our solution. So let's go ahead and check it out. If I click on the overview option now, I can take a copy of the public IP address. I can open up a new tab, paste that in, and I'll just quickly remove the text at the end. And what do we expect is going to happen? Let's go ahead and press enter. Awesome, there you go. We have connected to WebVM1 using the public IP address of our load balancer. Now what we can actually do, just to check and see that everything is working, is browse back to the home, choose WebVM1, and what I'm going to do is I'm going to go ahead and click on stop. Now what we expect to happen is our load balancer is going to use that health probe. It's going to determine that WebVM1 is no longer healthy, and it can then ensure that traffic is not directed to this resource when we're using the public IP of our load balancer. Now remember, we did have some wait time for that, so be sure your health probe has had sufficient time for that to take effect. And then what we can do is we can come back to our public IP, we can hit refresh, and awesome, there you have it. We're now connecting to WebVM2 because WebVM1 is offline. Just quickly, the last thing to take a look at, if we navigate back to the home, take a look at load balancer 01, you'll see that there's two other key things that we can do with our load balancer. We can have those inbound NAT rules where maybe, for example, I wanted to allow access via RDP to WebVM1 so that I can manage that server. I can do that with the inbound NAT rule. Remember, I removed the public IP addresses for our virtual machines, and that's really quite common for VMs or VM scale sets in a backend pool. So if you still needed to have inbound access, you can actually do so through your load balancer through an inbound NAT rule where you're going to allow inbound connectivity such as 3389 for Windows or 22 for SSH for Linux. If you're not familiar with this stuff, be sure to check out the Azure Firewall or Network Security Group lesson because we cover that type of inbound connectivity in more detail, and it's really much the same. Similarly, for outbound rules, what we're talking about here is outbound NATing, where we could allow our resources to go outbound via the load balancer itself. Once again, very similar to the Azure Firewall service, where we are choosing to NAT the outbound connections through our load balancer itself. Okay, everybody, so that brings us to the end of part 2 and the end of this lesson on the Azure Load Balancer service. A really cool service. The key takeaway here is that what we're talking about is layer 4 load balancing for highly available solutions. We're going to have resources in our backend pool that must be redundant for a given service tier. We have the front-end configuration, which is the public IP address that your users or your service is going to connect to. We have the back-end pool that holds our resources, and we use the health probe to check if those resources are available. We then use the load balancing rule to tie all of that together, along with features such as session persistence if we need to have sticky sessions. So that's a wrap for this one, folks. Thanks as always for your time. I'll see you in the next one. Well, g'day everybody, it's good to have you with me. In this lesson, we're going to chat about Azure Application Gateway. And if you haven't already checked out the Load Balancer lesson, I'd definitely encourage you to do so because the App Gateway kind of builds on some of those concepts. Within this lesson, we'll chat about what the Application Gateway does, why it's different to the Load Balancer, and I'll split this up into 2 parts once again so we can spend a bit of time within the Azure portal actually seeing this live with a demonstration environment. So as always, let's start with question number 1. What are we doing with this service? The Azure Application Gateway is really very similar to the load balancer, and you can in fact even combine it with load balancers within an overall solution. However, with the App Gateway, what we're talking about is layer 7 traffic. We are still talking about load balancing, but we are focusing on web applications because the Azure Application Gateway has awareness of web applications and web application features, as we're going to see. We refer to this as layer 7 because unlike layer 4, we're not just talking about data packets, TCP, UDP, we actually have some more awareness of the fact that this is going to be web, HTTP. We use things like SSL, there's awareness of cookies, and much, much more. So we've got those standard load balancing type features that we are already aware of. We can distribute load across resources that all serve the same purpose. They are redundant within a given specific tier. However, we get that additional functionality with things like URL-based routing. So a really common example of this is, let's say that you have a solution and maybe it's for online training materials. Well, perhaps for your training solution that you build, you have some web servers that are servicing your video content, maybe other web services that are servicing your image content, and maybe for all other traffic, you just have some default web services as well. Why would you go and do this? Why would you want to split up your backend pools like this? Well, when we think about the video content, we know that this backend pool might need to have additional capability for things like encoding and decoding and maybe streaming video content, which could be a lot different to just providing static data like a website, like image content, and so on. So maybe you want your solution to independently scale these different resources. Maybe your backend pool for the video content is actually going to be more expensive because you have virtual machines that maybe are a larger size and have more software licensing and so on. Really, the Application Gateway gives us this ability to split up traffic based on URL and so much more. We get things like SSL termination, cookie-based session persistence, and a lot more. What we're focusing on here is distributing traffic for web applications. So we get common features like we've already discussed. We can have public load balancing, and we can even, to a lesser extent, get private load balancing as well. But in terms of additional capability, well, we get that URL path-based routing that I just mentioned to you also. SSL termination is a really great feature of Azure Application Gateways because the App Gateway itself can handle what is sometimes a really costly computational process of encrypting and decrypting traffic. Instead of having your backend resources responsible for this, you can save on compute and you can leave this to the App Gateway instead. As I also mentioned, you get session persistence. So instead of with the load balancer where we only get session persistence based on client IP or client IP and protocol, With the application gateway, we can have session affinity that is cookie based. Okay, so again, we're talking about a web application type of feature. And given that we're dealing with web applications, it's important to know that we have specific web security capabilities, such as web application firewalls. And we'll talk more about this in an upcoming lesson. This is where we get to protect against common web vulnerabilities and exploits. And last but not least, the Azure Application Gateway is really good at its auto-scaling capabilities. We can have it auto-scale based on the demands of our users. So if this is all the additional functionality that we get with the App Gateway compared to the load balancer, what does configuration look like? Well, you're going to see that configuration is really quite similar. We have the front end, we have the back end once again. However, what you'll learn is that there's a few more modules, a few more components that we need to configure so that we can leverage the additional features we just spoke about. So for our front end, we have something very similar to the load balancer. We have our front end IP that can be public and or private, and that's what gets associated with our app gateway, and that's what our services or our users are going to point to be able to distribute load to the back end resources. Also with the front end component of our app gateway, we have something referred to as a listener. Now, the listener is where we say what ports and protocols are we actually listening to. Remember, it's not just TCP, UDP. We can have HTTP. We can have secure HTTP. And if we are going to have secure connectivity, if it's going to be encrypted, then we might also need to configure an SSL certificate as well. Remember, with what is often referred to as SSL offload being available through our app gateway, we are offloading that SSL computational task to the app gateway. So therefore, users are going to have connections with the application gateway that is going to be secure and encrypted. And then you can actually choose to either pass through unsecured connections to your backend or secured connections to your backend. All of this requires configuration of your SSL certificate. When we take a look at the backend, we're going to focus on a few common things that we're familiar with. So we have our backend pools, of course, and we have the rule, which is going to pull everything together. Once again, very similar to the load balancer. However, to support some of this additional type of capability, we have another thing referred to as the HTTP settings. HTTP settings are where we're going to configure some of the more web-specific type of functionality, such as path-based routing, which we spoke about, or that session cookie-based persistence as well. So we really kind of have these two halves. We have the front end, where we have our front-end IP, our listener that we're listening on. Then we kind of have the back end. The rule is going to pull this all together, our front-end listener with our back-end pools and with our custom HTTP settings. And you do get a default probe, but if you want to, you can also create a custom one as well. So that's what the application gateway does and what it looks like. Now, I know that that can seem like a lot to take in. So once again, let's split this up into two parts. Feel free to grab yourself a coffee, a chocolate, a break, a snack, whatever really suits you. And I'll see you again shortly for part 2, where we're going to jump into the Azure portal and check this all out. Hey everybody, welcome to part 2 in this lesson on the Azure Application Gateway, where we're going to walk through a demonstration of the configuration and deployment of an app gateway. Similar to the load balancing lesson, we're actually going to use a couple of virtual machines, WebVM1 and WebVM2. That's all going to exist within our virtual network VNet2, and what we're going to do is we're going to use our app gateway to provide public access to these resources. But different to what we did with the load balancer, we're going to use the path-based routing capability of the app gateway. So we're going to have two backend pools. WebVM1 will be in one and WebVM2 will be in the other. Now, normally, of course, you're going to have a lot more resources than this. Each pool would need to have redundant resources. But just to help demonstrate some of these different application gateway types of configuration, this is how we're going to do it in this demonstration. So let's get started. What I want to do first is create a new application gateway. Now we're going to create a new application gateway, and what you'll see is that you get to configure some of the different elements when you do deploy your application gateway at the start. I'm kind of going to skim through this because I think it's better to actually take a look at the configuration of an app gateway from the service portal itself. So let's get started. What we'll do is we'll create a new resource group. Let's just call this AG01-RG. I'm going to call our application gateway, you guessed it, AG01, and we'll deploy to Australia Southeast. Now, what you'll see straight away is that we get to choose tier, And this, similar to the load balancer, actually influences some of the different features that we get access to. Now, if we choose the drop down here, you'll see we've actually got a few options. But what we're talking about is, do you want a version 1 gateway or do you want a version 2 gateway? And when you do configure your gateway, do you want to have the web application firewall enabled for security as well? Now, we're not going to focus on the WAF right now because I'm going to have a separate lesson where we chat about how this actually works. So for now, let's just go ahead and choose standard V2. If you were going to choose the V1 SKU, you're going to miss out on some of the additional capability like auto scaling, zone redundancy, and even static virtual IP addresses. If you choose the standard option, then it is actually possible that the public IP address associated with the front end of your application gateway could in fact change. So standard V2 is commonly the recommended tier you should use. However, do check out the information on the differences between these tiers, and I'll include a link below, because if you're using this in the real world and you don't need all of the features, then maybe standard V1 is enough for you. We're going to choose standard V2, and then you'll see we get access to one of those features I mentioned that is only available to V2. That's auto scale, where we can actually say, what do we want for the minimum scale units for this app gateway, and what do we want for the max? So I'm just going to choose 1 and 2 because we're not going to be doing anything massive with this application gateway. Now, when we deploy our application gateway, we do need to choose a virtual network. I'm going to choose VNet 2, but what might be a little bit surprising is that you need to pick a subnet to deploy it to. Similar to the Azure Firewall lesson and some other Azure services, we use this dedicated subnet for the application gateway. At a bare minimum, you should have /27. You can't have /28 or /29. You could have it larger than that if you wanted to have /26 or /24 as well. You might ask, why am I going to have a large subnet for my application gateways? Well, it really is going to depend on how many you want to deploy for your virtual network. You can have more than one app gateway in your virtual network in your application gateway subnet. So depending on how many you are going to use, make sure your subnet has enough space. We're going to go ahead and choose app gateway subnet where we have a /27. Next, we want to have a look at the front-end configuration, and this is really where we're just saying, is it public, private, or both? Now you'll see when I choose the private option, I can't actually do so with the standard V2, so that is in fact something you need to be mindful of. While standard V2 has a lot of additional capability, it currently does not support private by itself. You can choose both, but this just means that you need to do so with a static IP address if you are going to use this option. For our demonstration, we only need public, so let's go ahead, choose public, and I'll create a new public IP address. We'll just call this AG01-pub. And you'll see here that this is giving us a static public IP address, which is a capability we can get because we're using version 2. So let's go ahead, choose OK, and next we get to pick our backend pools. Now what I'm going to do is I'm going to add a backend pool. Let's just give this a name of BE Pool 1. And I'll choose to add the pool without any targets right now because I want to show you the configuration from the actual configuration section. Next, we'll click on configuration and we're going to go into the routing rules. Now, once again, I'm just going to skim through this. Let's type rule 1. We're going to add listener 1 and we're going to choose the public IP address, and I'm going to leave all of this as the default. I'm going to choose the backend pool that we just created. I'm going to add a new HTTP settings, and I'm just going to really skip through this pretty quickly. HTTP settings, click on add, and then we're good to go. Now, the reason I did this is because I think it's kind of difficult to understand what's happening here when we do it all through this wizard rather than looking at it in the application gateway itself. So let's click on next for tags, review and create, and if this all validates successfully, we'll create the app gateway and take a look at that configuration in more detail. Now, app gateways, unlike the load balancer, certainly can take some time to deploy. So this time around, I'm going to pause the video and I'll pop back when we're ready to go. Okay, we're ready to go. Let's jump into the app gateway now and check out the configuration. So what you'll see here is a similar kind of experience that we're familiar with from the load balancer, but what we're now talking about are web application type of features. So if we navigate to the front end IP address, a very similar experience. Once again, we're talking about the connection point for our end users or for services that are going to access our solution. that's where things mostly change, okay? We have backend pools, which is once again familiar. However, the listeners, the rules, the rewrites, health probes, this is all now much more specific to working with web applications instead. So what I want to do with you is I want to walk through the configuration of this app gateway so that we can point the service to the two virtual machines. I don't want to use this backend pool that I've got here. I want to actually create two backend pools because in our scenario, we're going to pretend that we're using the application gateway to actually load balance traffic across two backend pools. One backend pool is going to be for default traffic, and the other backend pool is going to be only used when people are trying to access our video content, as if we were hosting a training solution ourselves. So let's go about first creating these two backend pools. I'm going to create one, and we're going to call this pool-default. And then we are actually going to add some backend targets this time. You'll see, unlike the load balancer, we get some additional type of capabilities. We can just point this to an IP address or fully qualified domain name. And we do still get the familiar VM or VM scale set options, but we also can point to Azure App Service as well. Because when we're talking about web applications, these additional options are going to be commonly in the mix. It might not just be VMs, might not just be VM scale sets. In our example, we're going to use a virtual machine as our target. So let's go ahead. We're going to choose our virtual machine, and we're going to say that Web VM1 is responsible for all default web traffic. Okay, so we're going to go ahead and click on Add and add this pool. Now remember that when we change this configuration, that is going to change the networking configuration for that virtual machine. So whilst that's continuing to deploy, I'm going to click on Add once again. We're going to create another pool. This time it's going to be pool-video. And yes, we are going to add a target. It's going to be a virtual machine, and this time it's going to be Web VM2. So we'll go ahead, click on Add, and now we have two backend pools that we can work with. So we've kind of got those core pieces once again. We've got the front end and we've got the back end. We need to fill in all those additional gaps. You might recall that for the front end, we had that additional really important piece of the puzzle, which was the listener. What is our application gateway listening for? Is it pure HTTP traffic or is it secure encrypted HTTP traffic? Let's take a look. If we go to add listener, we can give that a name of listen to. We can pick the front end IP that we're going to associate with, and then we can pick the port. Now you'll see there that from the wizard we already have one selected, but I wanted to show you some additional capabilities. If we choose HTTPS, you'll see we change naturally to the 443 secure HTTP port, and we get some additional settings for using a certificate. If you're going to use HTTP for your app gateway, you will need to upload the certificate you want to use to secure your website. Remember, if you're doing this yourself, the app gateway itself is going to be responsible for decrypting the traffic and encrypting the traffic for your users. For our example, we're going to use HTTP, but just remember this is where you configure the SSL side of things if you want your application gateway to handle SSL. Now, another important option is that of the listener type. If we choose basic, what we're really saying is that if the app gateway receives some traffic on port 80 on our given public IP address, then that's it. We just want to forward it through to a backend pool once we configure all of our rules and HTTP settings and so on. However, given this is a layer 7 service, it's important to know that we can use multi-site. So for example, I might say www.jazzlab1.com, okay? And I can create a listener where I'm listening for a specific URL. This is handy if you just want to use one public IP address and overload it with that one port as well. So you could have multiple listeners all listening on the same public IP, listening on the same port, but going to do something different depending on what that HTTP request actually looks like. Now in our scenario, we do want to create a new listener so that we can use it later on within our rule. So what I'm going to quickly do is I'm going to click on cancel, click on OK, come back into this original listener. Let's just change this to 8080. I know this might seem a bit odd, but since this listener is already attached, we have to change things a little so we can create a new one with similar settings. So I'll go ahead and click on Add Listener. We'll type in the name Listener 2. I'll use the front-end IP that we have configured, and we're going to use port 80, basic, and no error page URL. What we're doing now is we're creating the listener that we can use in an upcoming rule that we can use for our demonstration solution. So let's go ahead and click on Add. And then we can move on over to the HTTP settings. When we're talking about HTTP settings, what we're really talking about is the back-end connectivity. So we have this item we've configured here already, HTTP settings. What we're kind of saying is, how is the application gateway going to communicate with resources in our back-end pool? So you could even choose to have this configured as HTTPS. So that's going to ensure that even though the traffic is decrypted at your app gateway, that the traffic is then re-encrypted between the app gateway and the backend resources itself. Now, this can be used if you have some sort of solution that needs to comply with some regulations where the data must always be encrypted. In our example, we're going to leave this as HTTP. We're going to say that the backend port for our resources is still port 80, and then you'll see we get these additional type of options like session affinity, draining, and so on. So if we scroll down, the first option we have is cookie-based affinity. Again, we have a layer 7 solution here, so we can choose this option for our session persistence. So with your web application, if you do need session persistence, we can choose cookie-based affinity, which is a lot more powerful way of getting session persistence compared to if we were using the load balancer and just using client IP and client protocol. We're not going to use cookie-based affinity for our static website for demonstrating this solution. And we're going to leave all of these other options as default. Now, by default, when you work with the application gateway, a probe is already configured. If you did have a custom probe, and if we had actually configured one here, then this is where you're going to attach that probe as well. We're just going to use the default probe for our web application, click on save and leave that as is. And then this brings us to the really important part of the rules. Now, I don't actually want to use the rule we configured through the wizard, so let's go ahead and create a new one. Now for our scenario, remember we're going to make a multi-path rule. So let's call this multi-path rule. And what we're going to do here is we're going to use the listener that we created earlier, which is listening on port 80 on our public IP address. And for our backend targets, what we're actually going to do is choose multiple pools. So let's go ahead. We'll choose pool default, and we're going to use the default HTTP settings. What we're going to do now is add multiple targets so that we can have multiple different options. So we're now going to say we want a different option just for that video content. So let's choose video, and we'll also put a slash at the end and then an asterisk. Really what we're saying here is that we want all of the traffic that's going to match that URL. So if it has video at the end and anything afterwards, might be index.html, might be some contents page, whatever you really need. And then for our target name, we're going to have this as video target. And we'll use the default HTTP settings we configured. But for our backend target this time, we're going to use the video pool. Okay, so let's go ahead and click on add. And now what we're doing is we're saying that we've got this default backend pool for any connection that comes in through our load balancer. But if we have anyone that tries to access the site with /video at the end of the URL, then it's going to forward that traffic across to the backend pool called pool video. So let's go ahead and click on add for this one. And we really now have everything we need to pull this all together. So what we're going to do is we're going to browse across into the overview page for our application gateway. Let's take a copy of this public IP address. We'll paste it in. We'll get rid of that junk at the end. And let's see what happens. Excellent. So we're talking to WebVM1, which has that IAS page ready to go. Now we'd also expect that if we have anything after here with video / let's say index.html, excellent. There you have it. We're talking to WebVM2, which is the other backend pool we created to allow for this multi-path rule to work. So there you have it, folks. As you'll see, this solution is very similar to the Azure Load Balancer service. But what we're really talking about here are for web applications. And that's where we get the additional capabilities such as multi-path rules that we just looked at, session persistence using cookies, SSL offload, and much more. Hope you've enjoyed this lesson, folks. Thanks as always for your time, and I'll see you in the next one. Hey everybody, in this lesson we're going to chat about the Azure Traffic Manager. We'll start off by discussing the purpose the Traffic Manager serves, and then we'll take a look at the architecture of the service itself. What I want to do next is have a chat about some of the important routing methods we can use before we jump into the Azure portal and see the service in action. Now, so far we've been talking a lot about load balancing solutions, but primarily within a single region. Well, with the Azure Traffic Manager service, what we're talking about is actually helping to provide high availability across multiple regions. So we're talking about solutions that can remain online even if an individual region goes offline. Now, the way in which this is achieved is a little bit different from load balancers or application gateways, because what we're really talking about here is DNS. With the Azure Traffic Manager service, what we can do is respond to DNS differently depending on different scenarios. So first and foremost, if a region within our solution goes offline, then we can obviously have DNS respond in a way that excludes the region that has failed. But Azure Traffic Manager can actually provide more capability than just this, okay? So it's not just about responding to DNS based on services that are offline. We can also respond to DNS based on services that are closer to our users. So the Azure Traffic Manager service is primarily driven by DNS, but we've got a range of different ways that we can actually respond for DNS depending on what we want to achieve. First and foremost, it's about availability, but as we'll see in the coming slides, there's a lot more to it than this. To help understand this better, let's have a chat about the architecture of the Traffic Manager solution. The first thing we need to know is that what we're talking about are region redundant solutions. So in previous lessons, we've been speaking about ensuring that our service was redundant, and it was redundant in a number of different ways. We might have had multiple VMs within an availability set, a VM scale set, and so on. Well, with the Azure Traffic Manager service, we're talking about the same sort of thing. We're talking about services that are redundant, but they're redundant across regions. And unlike load balancers and application gateways, we get a few more options for what our actual end service is going to look like. So we can have a range of different Azure-based services, such as Azure App Service, or maybe even Azure Load Balancers as an endpoint. We can also have external services as well. So for example, you might use an endpoint outside of Azure. You might use a public IP or a fully qualified domain name to point to a service that you host somewhere other than Azure. And finally, we get a special type of option that's referred to as nested. Now, nested endpoints is more of an advanced type of option for when we want to support really large or complex deployments. So if we've got the solution that's redundant and it's hosted across multiple regions, what does it actually look like for the end user? Let's have a chat about the communication flow when we're using the Traffic Manager service. The first thing that's going to happen is your user is actually going to try and load your solution. That might be something like yoursolution.com, mysolution.com, yoursolution.net, whatever it is. The point is that we're talking about DNS here. So your user is going to navigate to this address, and what's going to happen is the Traffic Manager service is actually going to respond with an IP address based on your configuration of the Traffic Manager service. And there's a few different types of configuration we can have. We'll talk about that shortly. So Traffic Manager responds with the IP, and then your actual user or your service that's talking to your solution can go direct and talk to that solution. Really what we're talking about is DNS here. Now I've mentioned that there's a few different ways we can configure this, and primarily this is referred to as Traffic Manager profiles. What we're talking about here is how is the Traffic Manager service going to determine the appropriate IP address to respond with for your user. To determine this response, Traffic Manager is going to use something referred to as routing methods. So let's have a chat about those now. With the Traffic Manager service, you get a range of different options. You'll see we can have priority-based routing, which just means you're going to have prioritized primary and backup endpoints. You can have weighted, where maybe you want to distribute your load across multiple different regions, say 20% to one, 50% to another, and 30% to a final point. You might choose performance-based, which is a really cool option that allows your user to get an IP address that is based on how close they are to the actual service. So that's a really great option when you have a solution that is global in design, where you want your users to get access to the fastest service. You could also choose to create a geographic routing method, which is where you're going to explicitly define which geographies access which services. You can have multi-value, where multiple options are returned by DNS, and then it's up to the client to determine which option they'll use. Or you might even choose subnet, which is going to be based on the IP address of the client itself. Alrighty, so that's a fair bit of theory we've spoken about so far. Let's jump into the Azure portal and see how this actually works. You'll see here once again we're logged into the Azure portal, and we're also going to continue using the VMs that we've been using within this section of the course. That's WebVM1 and WebVM2. Now for each of these VMs, I have assigned a public IP address, and you'll see each are running IIS on Windows Server, and they just have a basic static web page. Now what we're going to do in this demonstration is create an Azure Traffic Manager profile, and we'll configure it to point to these different VMs using a specific routing method. So let's go ahead, click on Create a Resource. We'll type in Traffic Manager. I'll choose the Traffic Manager profile, and I'll go ahead and click on Create. Now straight away you're seeing that we're talking about DNS here. Okay, we need to provide a unique DNS name for our Traffic Manager service. So in this example, I'm just going to choose JazLab1 and we'll leave that, and hopefully that's not taken. Excellent, jazlab1.trafficmanager.net. Now you'll see we get to choose the different routing methods that I just spoke about a moment ago. I'm actually going to choose an option here for priority, and we'll have a look at that in the configuration shortly. For the resource group, I'm going to create a new resource group called TM01-RG, and we'll leave the location as Australia Southeast, and then go ahead and click on Create. Okay, now if we navigate into this resource, let's take a look at the Traffic Manager configuration. So we know that first things first, we configured a DNS entry with jazlab1.trafficmanager.net. This is kind of going to be the entry that you use to point to your actual solution. What do I mean by kind of? Well, if you so desire, you could in fact use this DNS entry. However, more often than not, you're going to create a DNS CNAME record that is going to be something like yoursolution.com points to jazlab1.trafficmanager.net. If you so desire, you can, of course, give your users this DNS entry and they can use the trafficmanager.net domain name. However, 9 times out of 10, you're probably going to create a DNS CNAME record. Now, that's the front end, if you like. We, of course, need to worry about the back end as well. So let's take a look at endpoints. What I want to do is I want to add these virtual machines as endpoints. So let's click on plus, and you'll see we get the different options available. Azure endpoints, external endpoints for fully qualified domain names or IPs, and nested endpoints, which are that more complex type of deployment. We're going to choose Azure endpoint, and I'm going to call this WebVM1, and then I get to choose a target resource type. Now I'm going to choose a public IP address. I could have actually gone through the other option and just typed it in manually, but I want to link to this resource because it exists within Azure, and I want the service to manage that link for me. So we choose public IP address, and then I'm going to go ahead and choose WebVM1, and we're going to leave the priority as 1 for this option. Now I'll go ahead and click on OK. And what I want to do is I want to add another endpoint for this profile. So let's call this WebVM2. We're going to choose the public IP address again, and we'll pick WebVM2. Now just understand that for the options here, I can only choose public IP addresses that have a DNS record associated with them. If you don't have that, just jump into the configuration of your public IP and add a DNS record to that resource. Okay, so we've got that ready to go, and what we're going to do is go ahead and click on OK. And really, that's all there is to it. What we're going to do now is we're going to browse back to the overview. I'm going to take a copy of this DNS record, and let's just open a new tab and paste that in. Okay, perfect. As you can see, we are loading up the same content we get from our actual virtual machine. Now, why are we getting WebVM1? We're getting WebVM1 because if we take a look at the configuration, we chose the priority routing method, and for our endpoint configuration, I have the priority listed here as 1 and 2. Now I could, for example, jump into the configuration, change the priority method to performance, hit save, and that's going to change the configuration of my endpoints as well. So you'll now see I no longer have to specify a priority after I change that routing method, because the Traffic Manager itself is actually going to take into consideration where the client is sending that request from and what the best performance option will be. Now in my scenario, these two virtual machines are in the same region, so that's not really going to do too much, because what we should properly have is endpoints that exist across multiple regions to really get the best out of this service. Okay folks, so there you have it. That's a wrap for Azure Traffic Manager. As you'll see, it's an important service when we're talking about distributing load across redundant endpoints. But what we're talking about here is geographic resiliency using DNS. So thanks again for your time, folks. I'll see you in the next lesson. Hey folks, thanks for joining me for this lesson on Azure Front Door. If you haven't already checked out the lessons on the Load Balancer, App Gateway, and Traffic Manager, I would encourage you to do so, because what you're going to come to learn throughout this lesson is that the Azure Front Door service is kind of like a combination of all of those services together. So within this lesson, we'll chat about what exactly this service does, some key components of the architecture, and as always, we're going to jump into the Azure portal and see this in action. When we're talking about the Azure Front Door service, what we're talking about are web applications that need high availability across the globe. You might already be asking, well, isn't that something that we can achieve through Traffic Manager? And you're correct, it is something that you can achieve. However, with Traffic Manager, we know that we're really dealing with DNS, okay? With Azure Front Door, we're actually really talking about a solution that's like the Azure Application Gateway working across the globe. So we get a lot of advanced layer 7 capabilities for ensuring that our web applications can be both accelerated and delivered at a global scale. So what you're going to see throughout this lesson is that we're talking about leveraging Microsoft's global edge network. This is how we can actually make our web applications run across the globe. And the Azure Front Door service is really something along the lines of a solution that Microsoft uses internally to deliver the services they sell to their own Microsoft customers. So Azure Front Door service has definitely been tried and tested, and we're talking about leveraging that massive Microsoft global edge network using all of those fast interconnects that Microsoft have already established to help to deliver your solutions instead of just theirs. Importantly, we need to bear in mind that what we're talking about here are web applications. So this is similar to the application gateway. It's something that's working at layer 7, and it's specifically designed for HTTP or HTTPS. Now, it likely comes as no surprise that the Azure Front Door service does integrate with Azure services as well. But what you'll also see is that if you have your own on-premises or third-party cloud solutions, you can actually point the Front Door service to those to provide web acceleration and features like caching and security as well. So before we jump into the implementation of the Front Door service, I wanted to briefly explain to you how this service actually works. Because so far, what I've talked to you about is really just a global network and features like load balancing and the application gateway and so on. I really like to paint out a scenario of you actually deploying a solution across the globe and having a think about how this works for our end users. So let's say you've got your solution, okay? You've deployed the Azure App Service, maybe a web app across some parts of the globe and other parts of the globe. And those two app services are probably integrated with the same single code repository, because remember, we're still talking about the solution and our backend actually being redundant. So these need to be the same thing. Now let's say we had a user that needed to access our service. Traditionally, what would happen is they would point to our web app, and if you want to use an analogy, we could have a car that's driving really slowly across the globe. It's going to access that data and return it to the user. When we use the Azure Front Door service, things actually change. We have something referred to as a point of presence. Now, this is what leverages the Microsoft Global Edge Network. This is where we say Microsoft has an edge network all across the globe that's really interconnected. It's very fast, it's low latency, it's high bandwidth. So if we can leverage this for our solutions, then we can improve performance for our solutions as well. So how would that look if we are leveraging the Azure Front Door service? If our user wants to connect to the service this time, when we're using the Azure Front Door service, what's going to happen is the user is going to be pointed to the local point of presence. The default Azure Front Door routing method is going to ensure that the lowest latency connection is used. Now, this is a little bit outside the scope of this course, but just very briefly, I wanted to mention that behind the scenes, what we're doing is we are using the Anycast protocol to actually split the TCP connection for our user to the actual backend resource, in our scenario, the web app. So how this actually looks this time around is the user is going to have the slow connection to their local point of presence, so nothing's really changed there. But then using this Anycast split TCP protocol, what's going to happen is that traffic is actually going to take a more fast route across Microsoft's backbone network to the actual end resource, the web app. So using this Anycast split TCP protocol, what we get is a much faster connection for our end users. And there are other features like caching as well, so that the global edge network point of presence can be used for caching things like files, images, and so on. So at a really high level, that's how the Azure Front Door service works. It's about taking your solutions across the globe and ensuring that wherever users are accessing your solution, they're going to use this Microsoft Global Edge network to actually get fast connectivity. So if that's how it all works, well, what does the implementation look like? When we're implementing the Azure Front Door service, you're going to see a lot of common features with things like the application gateway. So we start with our front end, which as we know is where we're going to point our users or our services to that actually need to connect to the back-end resources. Now, as we'll see in the portal shortly, this is actually going to be a front door domain, but we can use a custom domain if we require it. We then, of course, have our back-end resources, which no surprises, it could be something like Azure App Service, could be a range of other integrated Azure services, or even custom on-premises solutions as well. Then when we put it all together, we have this routing type of functionality, which is going to be responsible for actually getting the traffic from our user to the back-end resource using the Microsoft Global Edge Network. So using this fast Microsoft Global Network, we can provide faster connectivity to back-end resources. Again, these still need to be resources that you deploy, that you manage, and that are redundant. They should be duplicates of one another. All right, so that's what it all looks like. Time to jump into the Azure portal and check this out. Now here I am in the Azure portal, and what I want to do firstly is just quickly show you that I have two Azure App Service web apps running. So if we quickly navigate into web apps, let's take a look at the app services we have. You'll see that I have a web application deployed to Australia Southeast, and I have a web app deployed to Central US. Now, normally, once again, what you're going to do is have these web applications deployed using the same code repository because they should be a redundant service. In my scenario, I've just deployed a web application with no code, but we can still take a look at how this would function. So what we want to do next is go to the home, click on create a resource, and we're going to create the front door host that we need to use to make our solution globally available. So we've chosen front door. Let's go ahead, click on create and get started. What we want to do first is create a new resource group. I'm just going to call this front door 01-RG. And we'll click on OK. For our resource group location, let's actually just choose that to be Australia Southeast and go ahead and click on next. Now you're going to see something quite familiar. We have front ends, back ends, and routing rules. And really, actually, this is all you need to configure for the Azure Front Door service. Whether we do this through the wizard or through the configuration once it's deployed, pretty much always looks the same. So let's have a look at this in more detail. Firstly, we need to create the host name for our front end. Remember, this is going to be the central point that your users are going to be navigating to. So let's just, in this example, call this JazzLab FD01. This, of course, does need to be unique because it's going to be using the AzureFD.net DNS entry as well. Then you'll see some familiar options we have here. If we need to, we can enable session affinity. Now, I'm not going to go into great detail about this because it's the same type of thing we talked about in the Azure Application Gateway service. We're using cookie-based session affinity. I'm going to leave this as disabled, and we get another feature here called the Web Application Firewall, which once again is something that we get from the Azure Application Gateway. We won't talk about this because there's a dedicated lesson coming up for Web Application Firewalls. So that's all we need. Let's go ahead, click on Add, and then we need to configure our backend pool. Now let's just go ahead, give this a name of BEPool01, and then what we can do is choose the actual backend host. And you'll see this is where we get a few different options. We get the native Azure type of services that we would come to expect, app service, storage, app gateway, and even other options like custom hosts if you want to point to perhaps your own service that you have running somewhere else. I did just want to quickly call out here that you can point this to a public IP and you can point this to an application gateway. Because remember, what we are talking about here is creating a globally highly available solution. You might still choose to, and you might still need to, actually have an application gateway or a load balancer for your solution to actually provide that regional-based high availability. So you can combine these different services together. Or as in our scenario, we're just going to point directly to an app service, and we can choose the backend host name here of Australia Southeast. We'll leave all of these options as default for the port, and we'll talk about priority and wait shortly. So let's go ahead, click on Add. And what I want to do next is pick the other app service. So let's choose app service, and this time we will choose the Central US option and click on Add. Now there is some information here about load balancing, but we'll talk about this more shortly. So let's go ahead and click on Add, and then we want to configure our routing rules. Now, what I wanted to call out here is that you're going to see some, once again, surprise, surprise, familiar functionality when compared to Application Gateway. So let's just type Route 1. And what you can see you can do is you can even have path-based routing, again, if you wanted to do something like videos or images or have your default options. We're just going to leave that as default because we know what that is. And you'll also see we have this final option here referred to as caching. So if you did want to leverage that global edge network more like a content delivery network, this is where we're going to enable caching. What that's going to do is it's going to help us to cache things like images and large files across that edge network so that the end user might not even have to come all the way back to the app service. It can just rely on a cache of the data at a local point of presence and retrieve that nice and quickly. We're going to go ahead, leave that as disabled and click on Add. So that's all we need for our front door service. Let's go ahead and click on Review and Create. And if the validation succeeds, we'll click on Create. Now, as always, this can take a little bit of time, so I'll speed things up until we're ready to go. Okay, awesome. That's actually pretty nice and quick. So let's go ahead and click on Go to Resource and check this out. Now, unlike the Application Gateway, there's really not a lot different between the wizard view for creating this resource and what you see within the settings. So if we navigate into Front Door Design, we're going to see exactly the same thing. The important thing to understand about the front door service is that what we actually do is we take a range of the different items we have configured, and it's all brought together in order to determine how traffic is routed for our end users. So for example, in the backend pool, we specified priority and wait. And if we scroll down, we also have this section here for load balancing, which has a really important characteristic referred to as latency sensitivity. Now, I'm not going to go through all the different combinations and permutations of how this works together, but just understand that what's happening behind the scenes is the front door service is using this information to determine what is the closest backend for our end users. So if you have backend resources that have the same priority and you've got latency set to 0, then Microsoft is going to go about doing its thing to determine which is actually closest for the end user. So what I'll do is I'll include that link to an article, and it talks about lowest latency based traffic routing. So if you need to deploy a configuration that was more complex than this, then this is the type of settings that you're going to change. So that's all we actually need to do to get this solution running. If we go back and click on the overview, what we can do is we can take this front-end host, we can paste that into a browser, and there you have it. You'll see that we're actually connected to our back-end Azure web app that I've already deployed across a region. Now for me, this should be pointing me to the Australia Southeast web app because that's closest to me. Now, if I were to shut down that web app, it would point me across to the other web app because it won't send me to an unhealthy resource. So we do still get that same type of capability that we would expect with the Azure App Gateway, load balancing, and things like that. Okay, folks, so there you have it. As you'll see, it's a pretty similar service to those that we've already discussed, but the really key takeaway for the Azure Front Door service is that what we're talking about are solutions deployed at global scale. When we want that global high availability, when we want our web applications to be accelerated, and when we want features like global caching, this is where we're going to use the Azure Front Door service. So, as always, folks, I hope you've enjoyed this lesson. Thanks for your time, and I'll see you in the next one. Hey everybody, in this lesson we're going to chat about web application firewalls in Azure. And I'm just going to call this WAF for short. So what we'll talk about is how we can use the WAF for the application gateway or for the Azure Front Door service. We're going to chat about some of the differences of running the WAF in these two services, and we'll also jump into the Azure portal and check out a WAF policy. When we're talking about web application firewalls, what we're saying is we want to protect web applications from common threats and exploits. So we know that the Azure Application Gateway and the Front Door service are about delivering highly available web applications. This is why both of these services have a web application firewall. So common exploits might be things like SQL injection or cross-site scripting, and this is what we want to protect against with these two services. Now, to protect against this, we can use both Microsoft managed rules, or we can create our own custom rules as well, and we'll take a look at this soon. And as I've mentioned, this is supported by both the App Gateway and the Front Door service, but what you're going to see is there are some differences, but Microsoft are also starting to pull out the web application firewall kind of as its own service. It's not quite its own service yet. It's more that we can configure the policies in a centralized way. But just understand that Microsoft is working on simplifying the process of centrally managing your web application firewalls across all of your app gateways and front door service. Whilst there's a lot of things we're trying to do in common, there are some differences when we run the WAF on either the app gateway or the front door. Firstly, what we're talking about is protecting the solution either at the network edge or within the region. So remember that the application gateway itself is really deployed to a region and it's focused on region high availability, whereas the front door service is focused on global availability. And this is why when we use the WAF, for the app gateway, we're getting protection kind of at or in the virtual network, whereas at the front door, we're actually protecting before the traffic even enters our virtual network. So that can be an important distinction to understand about configuring these two services. As I mentioned, when you use this on both of the services, you get support for Azure managed rules and your own custom managed rules as well. There are some differences between the Azure managed rules. For the application gateway, it's going to be based on something called OWASP core rule set, and we get support for versions 2.2.9, 3.0, and 3.1. Whereas for the front door service, we're only going to get protection against really the top 10 or the sort of common OWASP vulnerabilities. Now, OWASP stands for Open Web Application Security Project, and it's really kind of like an open source approach to security. So whether you're using something like Azure services or whether you're using Cisco or maybe F5, a lot of these different network security options provide support for the Open Web Application Security Project, right? It's this non-profit foundation that looks at securing against common threats and vulnerabilities. But just understand there are some differences in how this is implemented with the application gateway versus the front door service. There are some other differences as well. So when we use the application gateway, we can use geo-filtering rules, but we can't configure rate limiting. And these are common types of things you want to implement for web application security. The front door, you do get geo-filtering and you do get rate limiting. So let's jump into the Azure portal and see a bit more about how these are implemented. Here I am in the Azure portal and I've got my application gateway and we have the front door service that we configured earlier. So let's firstly take a quick look at the application gateway. If we scroll into the web application firewall settings on the left here, you'll see that I need to have the WAF tier enabled. As long as my application gateway is on the WAF tier, and this can be configured if you don't have it currently enabled, then you can go ahead and enable your firewall and configure it for either detection or prevention mode. When we have this in detection mode, what we're talking about is logging and reporting different types of security concerns. When we're talking about prevention, we're actually going to go about saying we want to block things that we feel is malicious. So that's how we enable the functionality on the application gateway. If we browse back to home, and I'll just discard these changes, and then we open up the front door service that we created earlier, you'll see we have web application firewall on the left-hand side as well. Now, how we enable this for the front door service is actually a little bit different. And this is what I was talking about, how Microsoft are trying to centralize and kind of make a modular approach to web application firewalls. Let's click on Home. What I want to do next is click on Create a Resource, and then I'm going to type WAF. Now you'll see we get this option here, Web Application Firewall. If I choose this, what we're talking about doing is creating a Web Application Firewall policy that we might use. So this really helps if you have multiple application gateways or multiple front door services, and you want to centrally manage the web application security for these. It also actually helps us to provide more granular control over security, and you'll see what I mean by that shortly. So the first thing we need to do when we create a WAF policy is choose what this policy is for. You'll see we can get it in the front door service, global WAF, application gateway, regional WAF, and even in preview currently the Azure Content Delivery Network. So let's go ahead and choose the application gateway just as an example. I'm going to choose an existing resource group I've already created called WAF policies, and we're going to call this AG-WAF1. We're going to choose the location of Australia Southeast, and we'll say that the policy is enabled. Now, when we go to configure the policy settings, the first thing that we can do is configure that mode that I just mentioned a moment ago. Do we want to prevent things from actually happening, or do we just want to detect and report on them? Next, are there any portions of your web application that you want to exclude from this firewall? After we've configured the mode and the exclusions, we can move on over to the managed rules. Now we're talking about here a policy for an application gateway. So you'll see, as I mentioned, we get support for 3.1, 3.0 and 2.2.9 OWASP rules. We also get a bot manager rule set that Microsoft have configured as well. So this is the open source project that I was talking about a moment ago. So let's choose the latest version for that. We'll move on to custom rules. We won't add any custom rules, and then it's on to the association. You'll see when we associate a WAF policy, we can do so for the entire application gateway. That can be one or more app gateways. Or, which is really quite neat in terms of granular control, we can do so at the listener level. So remember, your application gateway could be configured with multiple listeners. So you might actually choose to have different policies for different listeners. I'm just going to go ahead and click on Review and Create because I've already been through this process and I've already created a WAF policy. Let's go back to the start of the creation of this WAF policy. Now, if I click on Create once again, I just want to highlight here that you can also choose that Global WAF front door option. If we choose the existing resource group, we'll see that this is going to look a little bit different. So let's call this FD WAF. We'll leave the policy state as enabled. We get the familiar mode options, but then when we move into the managed rules, you'll see what we're talking about is really a Microsoft managed rule. It's not specifically the OWASP option. Microsoft's saying they have a pre-configured rule that's available, and that's for the top 10 OWASP categories. So just understand that if you are deploying the service and for whatever reason you need complete compliance with the OWASP versions, then it's going to be a bit different when you're using the WAF policy for the front door service. Otherwise, we've got the same type of functionality with custom rules and association. So if I navigate back into Home, what we can do is we can browse into resource groups, take a look at our WAF policies, and see that we have these WAF policies here ready to go. So if I click on the front door WAF, what we can actually then choose to do is browse into the associated front-end hosts. And this is where we're going to associate this WAF policy with an actual front door service. So I'm going to choose to add a front-end host. I'm going to pick the front end that we created earlier, jazzlabfd01.azurefd.net. Go ahead, click on Add, and then click on Save. So for the front door service, that's how you associate the policy. If you are actually wanting to configure this for the application gateway service, then understand that you can either do so manually through the service itself or centrally with these policies. So I think it's actually best practice to use the central policies, and then you can ensure that whatever central policy you have, whatever you require for your organization, you are managing centrally and you're applying that to all of your different app gateways and to all of your different front door services. So folks, that's really all there is to it to application gateway and front door service web application firewall. The really cool thing, in my opinion, is this central ability to manage your WAF policies. That's a bit of an improvement that Microsoft have made over the years, and I definitely encourage you to check it out. As always, thanks for your time. I hope you've enjoyed this lesson, and I'll see you again soon. Hey folks, in this lesson, we're going to check out Azure Update Management. We'll talk about the architecture and the workflow of the service itself, as well as jumping into the Azure portal and seeing it in action. The Azure Update Management Service, as the name suggests, is responsible for managing updates centrally for your machines. Now, if you're familiar with the Windows Server Update Service, which is used within Windows-based enterprises, we're talking about the same type of capabilities. What is that? Well, we're centrally getting a view of all the updates across our machines, as well as being able to schedule updates to those same machines. So it's about assessing and reporting on the update status, as well as controlling what updates you want to deploy. Now, with the Azure Update Management Service, the cool thing is we're talking about both Windows and Linux. And this service supports not only Azure, but also things like on-premises or other cloud providers as well. So how does this service work? Well, we're actually using a number of different services behind the scenes. First and foremost, we need to use an Azure Automation account. Now, if you're not familiar with the Azure Automation service, be sure to check that out in the previous AZ-303 course. Within our Azure Automation account, we have something referred to as a hybrid runbook worker. Now, it's this hybrid runbook worker that's actually going to reach out to our other machines and help to perform assessments and help to schedule updates. The next piece of the puzzle is the Azure Log Analytics workspace, and in conjunction with that, we use the Log Analytics agent. So these two services, Azure Automation and Log Analytics, help us to go out and talk to machines in our environment, assess the status of updates, and schedule those updates to occur. How does that actually work behind the scenes? Well, let's have a chat about that now. When you go through the Azure Update Management workflow, it looks something like this. Firstly, you have the Log Analytics agent deployed to the machines that you need to update. That agent is going to report the status of updates on the given operating system, and it's going to report that information back to the automation account. Now, we can then jump into the Azure Automation Service and take a look at all of the machines that we have assessed updates for, and we can schedule updates based on the updates that we want to deploy. So once we've created that schedule, what's going to happen is the hybrid runbook worker is going to talk to the automation account, and it's going to check to see if any updates need to be scheduled. If it does find that updates do need to in fact run, then what it's going to do is it's going to trigger updates on the operating systems that we manage. And that's going to look something like this. First things first, we need to know that for our operating systems, if we're using Windows, the hybrid runbook worker is going to trigger the Windows Update agent to help perform some update tasks. If you're talking about Linux, that's going to use yum, apt, or zipper. Now within Azure Update Management, we do get the ability to configure pre-steps and post-steps. So if you want custom scripts to run before updates and after updates, then you can do that. Otherwise, at the very least, what we are going to do is engage the Windows Update agent or yum or apt or zipper, and we're going to perform updates depending on the schedule and depending on the updates that we want released to our machines. So once that update has been performed, we're going to get the report back to the automation account so that we get that full picture of updates that have occurred and the update status on our machines. Now, before we continue into the Azure portal, just quickly bear in mind that this hybrid runbook worker needs to have the ability to communicate to the machines that you are managing updates for. As you'll see, if we're managing Azure, it's all nice and pretty simple to do, and it's managed for us behind the scenes. But if you are managing updates in AWS or Google or on-premises, then you are going to have to deploy the hybrid runbook worker to a machine in your environment that has connectivity to the machines you want to manage. So let's jump into the Azure portal and check out how this works for Azure. Okay, here I am in the Azure portal, and what I want to do now is I want to browse into automation accounts. Again, if you're not familiar with this, be sure to jump back to AZ-303 course 1 and check out where we create and configure an Azure automation account. So I've already got that automation account up and running. Now what I want to do is I want to browse into the Update Management section. If this is the first time that you're using Azure Update Management, then what you are going to have to do is enable the Update Management service. And when you do so, it's actually going to link the Update Management service to a Log Analytics workspace. Remember, the automation account is where we are sort of controlling updates and pushing out updates, but it's the Log Analytics workspace that's going to help us to get Log Analytics agents onto machines we want to manage and have that repository for data that we actually use for this. It's actually pretty cool how it works behind the scenes in terms of Log Analytics queries and management solutions, but when we just use this update management feature, that's all sort of hidden away for us behind the scenes. So once you've enabled the Update Management service and you've linked that to your Log Analytics workspace, what you're going to go and do is add machines. They might be Azure virtual machines or they might be non-Azure machines as well. So if we click on Add Azure Virtual Machines, you'll see that I've already got 3 virtual machines within the environment, and I've gone ahead and clicked this and I've enabled that. Now what that's doing is that's actually deploying the Log Analytics agent to the virtual machine. So if we go back one step, if you wanted to configure this for non-Azure virtual machines, you click on this option instead, and it's going to take you to a link about the Log Analytics agent. So again, a key takeaway for the Azure Update Management service is that what we are really leveraging behind the scenes is the Log Analytics workspace. I do provide more information on how those agents work and how you can manage machines within a workspace in the AZ-303 course 1. So that's all happening, that's working behind the scenes. We've got the Log Analytics agent deployed to machines that we want to manage. That can be on-premises, it can be within Azure. And what we want to now do is we want to go ahead and schedule an updated deployment. So we can click on this schedule option right here. And what we want to do is we want to configure a schedule for deploying updates to our machines. They can be Windows or they can be Linux. So I'm going to go ahead and choose Windows, and let's say daily update -Windows. And what we need to do next is actually say what groups do we want to add to this schedule. Now again, behind the scenes, this is actually going to use log analytics queries. So you'll see here, I can choose all of my subscription. I can maybe refine that down to multiple different resource groups depending on what I want, or I might say select all, and I can have different filters here like location and tag. Because if we go ahead and click on add, what's actually happening is this is creating a query with the log analytics query engine. And it's going to be able to go through and dynamically create a group of machines that we want to manage. So this is a pretty cool part of how this all works. In my scenario, I've got 2 virtual machines that are Windows and 1 that is Linux. Now, only one of them is showing up because when you first configure the update management solution, it can take some time before the agent's installed, and then the agent reports back to the log analytics workspace. So if you are following along at home with your own environment, just be sure you give it a half an hour or more for each of your agents to actually check in. So I'm going to go ahead and click on OK, and that's going to be a dynamic group of computers that will update depending on what I have selected here. So I'll choose OK, and then I'm going to go ahead and look at the update classification. Now you'll see I get to specify what types of updates I want to deploy. I might, for example, actually choose to only have within this option perhaps security updates and critical updates, or you might select the lot. Then you also get the option to exclude updates. So maybe you have some concerns about specific updates that don't work within your environment, well, you can exclude those, or you can manually specify those that need to be included as well. Then we get to choose the schedule for our updates, and maybe you're going to do this on a daily basis. Let's say you're going to do this at 9:00 p.m. and you might do that every night. So we can choose once off, or we can choose recurring. I might say every day and go ahead and click on OK. And as I mentioned, you do have the option to have pre and post scripts, and this is actually going to leverage Azure Automation runbooks if you want to do so. In my example, I'm just going to leave that as is, and I'm going to say that if reboots are required, that I will push a reboot automatically. So let's go ahead and click on Create. You might be wondering, what are the steps to use the hybrid runbook worker? Well, if you're managing virtual machines within Azure, that's actually all going to be managed for you. When you deploy the log analytics agent as part of enabling update management for your virtual machine, or if you've already done so to connect a virtual machine to a log analytics workspace, then through that process, the hybrid runbook worker is actually going to be deployed to virtual machines that you already have. So if we take a look at the View Update Agent Readiness status for VM01, you're going to see that the hybrid runbook worker that is assessing our virtual machine is in fact VM01 itself. As the log analytics agent is deployed to more virtual machines, they can have the hybrid runbook worker functionality installed automatically so that there's always virtual machines to talk to other virtual machines to help perform those updates. If you are doing this on premises, then what you're going to want to do is navigate into the hybrid worker groups section and click on configure. This is going to take you to a Microsoft link that talks about how to use a PowerShell script to install the hybrid runbook worker on machines that you manage in other environments. Okay, folks, so that's all there is to it for this lesson on Azure Update Management. As you'll see, it's a pretty cool tool to help us to manage updates centrally for both Azure, on-premises, and other cloud machines as well. Thanks for your time. I'll see you in the next lesson. Welcome to this lesson on Azure Backups, where we're going to chat about what the Azure Backup Service does, the different types of scenarios it supports, and we'll jump into the Azure portal and check it out for backing up Azure virtual machines. Azure Backup can really be thought of as backup as a service. It's really where Microsoft manages a lot of the back-end type of infrastructure for you. So have a think about how you would normally have to manage backups for your on-premises enterprises. You're going to have to build up backup servers, have backup software, licensing for that software, and you are definitely going to need storage. The storage is probably the more tricky part of this equation. Well, with Azure Backup, what you're really talking about is this all being managed for you in the cloud. We're talking about the typical types of backup that you would come to expect. So backing up and recovering your critical workloads and data. But it's not just data, okay? It can be files and folders, but it can also be things like machine system state or even application-aware backup. So maybe you've got a Microsoft SQL server and you need to back that up as well. When we deploy the Azure Backup Service, we actually get to use different agents. So the agent we use is going to depend on whether we need to support on-premises or other cloud environments or just have backups for Azure virtual machines. And we'll talk more about this shortly because also, depending on the agent you use, That's going to determine what type of support you get for file level backups, application aware backups, and so on. The implementation of the Azure Backup Service actually doesn't require many different components, especially when compared against something like the Azure Update Management Service. So first things first, we have the Recovery Services Vault. This is both the storage and kind of the centralized management pane for your backup service. So the Recovery Services Vault is where we go and configure what type of storage we need. Do we need it to be locally redundant or geographically redundant? And that's where we're going to manage the different schedules and policies that we want to enforce for backing up our workloads. The workload is an important consideration when we're backing up data, because do we want to back up Windows machines, Linux machines? Are you going to back up SQL, for example, or some other type of application that needs to have a special awareness of the backup? When you're talking about Azure backups, you do need to be mindful of application consistency. So the really common example, SQL. If you have SQL running on a virtual machine and you go and perform a backup at, let's say, 9 o'clock, when you run that backup, you need to be sure that SQL itself has written all of the data it needs to write to storage, because certain applications like SQL can actually have data and other things stored in memory. And so when you perform the backup, you really need to go and say, hey, SQL, I want to back up this database, but I need you to make sure that you have committed all that information to storage. So depending on what we're trying to actually back up, we're going to need to pick an appropriate backup agent. That's what's going to be deployed to our servers, and that's what's actually going to back up the data, maybe perform some application-aware backups, and send it off to the Recovery Services Vault. Now, I hate to bore you with too much information, but I've got a nice big table here that includes some important details. This is some important information from a range of different Microsoft articles. I'll try and include the important links below, but just understand that what you see here does matter when you're architecting a backup solution. Whatever you're going to do, when you want to use Azure Backup, you're going to deploy your Recovery Services Vault, but then you need to pick the different type of approach you want to take. So for example, we can use the Microsoft Azure Recovery Services agent, and that can only be installed on Windows, and it provides file level backups. But the important considerations here are that it can back up 3 times a day, but it can't actually perform application-aware backups. Whereas for one of the other examples, Microsoft Azure Backup Server, we get full support for more traditional types of backups. We can have Windows, we can have Linux, we can have application-aware backups, system state, file folder volume, and so on. And you can get far more customization over the backup frequency and how that's actually performed. Now, if you didn't need to back up machines that were on premises or in other third-party clouds, you might go ahead and use the Azure Virtual Machine Backup extension. It's very easy to use, very simple to set up, but it can only back up once per day. So we do get support for application consistency, file level backups, file level restores, and things like that, but we can only use it in Azure and we can only back up once per day. The final option to be mindful of is something referred to as Microsoft Data Protection Manager. Now, if you've been using the Microsoft DPM service on premises, what we're talking about is a traditional Microsoft backup solution. Why are you going to deploy your own Microsoft DPM solution? Well, hey, maybe you've already got that on premises and you can integrate with Azure Backup for online cloud-based backups as well, but maybe you still need support for tape, and that's why you might use that. So the key thing to understand here is that Microsoft have provided a range of different options, and when you architect a solution that is going to use Azure Backup, you need to be mindful of the appropriate agent for your given scenario. I've only listed a few of the different considerations here, so just be sure to check out how often you can back up, what type of backup you're going to get, and what type of workloads you support. To see this in action, why don't we jump across to the Azure portal and we'll check out how we can back up an Azure virtual machine. Okay, here we are in the Azure portal. What we want to do next is go to Recovery Services Vaults and go ahead and click on Add. We need to create a resource group, so let's call this Vault 2-RG. I'm going to go ahead and click on OK. For the vault name, we're going to call this Vault 2. Now that doesn't have to be unique like storage accounts and things like that. It's just for our use. So let's go Australia Southeast, click on Review and Create. That's actually all there is to it for getting started. You'll see there is an important note here about the storage replication type, and we'll take a look at that shortly. So let's click on Create, and then go ahead and click on Go to Resource. Okay, so we've got our recovery services vault. This is where our data is going to be stored, and this is where we're going to get the reporting and assessment type of capabilities to see what workloads we're actually backing up. So you will notice as well that we've got an option here for site recovery, and we're going to talk about that in an upcoming lesson. Firstly, what I did just want to mention is that if we navigate into the properties section, you'll see we have some options here down the bottom. If we click on Update beneath Backup Configuration, you'll see that we get to choose what type of storage replication we actually have. Do we want this to just be LRS or do we want it to be GRS? If you're not familiar with these options, be sure to check out Storage Account Replication in the AZ-303 number 1 course. So GRS is selected by default, so we don't need to change anything there. Let's go ahead and click on X. Okay, so we've got our storage ready to go. Let's navigate across to the backup section. And now Microsoft is going to actually help us to pick the appropriate agent for our workload. So you'll see here if I choose on-premises, for example, I might say that I want to back up Hyper-V virtual machines. Depending on what option I pick there, that's then going to recommend for me a specific agent to use. So when we're saying on-premises virtual machines, Microsoft's going to recommend the Azure Backup Server. Now in our scenario, we just want to back up an Azure virtual machine. So let's choose the Azure option here, and we're going to pick virtual machine. When we click on the backup option here, it's just going to go about navigating to a backup policy for us that we can use for our virtual machine. So you'll see that by default, we get a default policy, has daily backups running at 11:30 a.m. UTC, and it talks about restore and so on. Let's just go ahead and click on create new policy and take a look at this right now. Let's just say we want daily VM backup, and for the frequency, we'll leave that as daily, but we do have the option for weekly as well. So I'm going to say that I want this backup to run every day, and I want it to run at nighttime, let's say at 7 p.m. I'm going to choose the time zone. For me, that's going to be UTC plus 10, somewhere here. There we go. And then we get to pick the instant restore option as well. Instant Restore just talks about how much of the data Microsoft is going to retain for you and for how long, depending on how quickly you want to be able to recover from backup. We're going to leave this as is at 2 days, and then we need to go ahead and choose the retention range. Now you can see here that we actually get some pretty granular control over how long we want to retain the data for when we create Azure Backup policies. I might say that I want to retain the daily backup point for 180 days, but maybe I need something more than that. So you might say every Sunday, every weekend backup, I want to retain that backup for maybe 52 weeks, okay? So what you get control over is really this traditional type of backup retention policy where you can say, how long do I want to retain the different types of backups for? Maybe in our example, we were happy with 7 days worth of the immediate backups, but we did need weekly backups for up to a year. Maybe we want monthly backups for the first Sunday, and we want 60 months worth of those. You can even go all the way up to yearly backup points as well. In our example, I don't need to retain this data for long, so let's turn those options off and just go ahead and click on OK to create the new backup policy. Now what I want to do next is actually add a virtual machine. So let's go ahead and click on the Add option here, and I'm going to choose VM01 and click on OK. Now what's actually happening behind the scenes here when we click Enable Backup is that's going to deploy a virtual machine extension to our Azure Virtual Machine VM01. That VM extension is going to be responsible for helping us to transfer the data to the actual backup vault. Now, once we have that backup data, depending on how we are getting it, whether it's through the VM extension, the Mars agent, the Microsoft Azure Backup Server, or so on, we can then navigate across to backup items and we can get more information. So we see here that we have the Azure Virtual Machine installed. Currently, it's actually being deployed, but we can hop into this section here. We can enforce a backup to occur when we want it to. We can manually restore a virtual machine if there's been any issue, and we can recover files as well. How you do this is of course going to depend on the agent you use, but as you'll see, it's pretty simple for us to get up and running with Azure Backup. So folks, that's all there is to it for this lesson. Thanks for being with me, and I'll catch you in the next one. Hey everybody, welcome to this lesson on Azure Site Recovery, or ASR for short. Within this lesson, we're going to focus on how we can use ASR to establish disaster recovery, because understand that ASR can actually be used for migrations as well. But this isn't something that Microsoft is pushing, given they now have the Azure Migrate service. So let's get started having a chat about how we can use ASR for disaster recovery. You might actually consider that ASR is disaster recovery as a service. What we're focused on is business continuity. What that really means is that we want to ensure that if there's a major outage at a site level, that we can protect against that. We can recover from that type of outage. So business continuity means, how do we go about getting our business operations back online if there's been a major outage at one of our sites? This is what Azure Site Recovery is focused on, where we establish that we have a primary site and we have a secondary site, and we want to have some type of capability to automate the recovery process. So at any given point in time, we should have our servers from our primary site being replicated across to a secondary site. And when we're working with ASR, we're really commonly talking about taking something from on-premises and replicating it into Azure. That means that if a disaster struck our on-premises site, we could fail over to the Azure site. We could have all of our servers that were on-premises now running within Azure. Now, the ASR service actually supports a range of different workloads in these type of scenarios. So on-premises might be Hyper-V for Microsoft, VMware, or even just plain physical servers. And you can actually even use Azure Site Recovery to replicate from a primary Azure site to a secondary Azure site as well. And really, no disaster recovery solution is going to be complete if it only focuses on Windows. So it's good to know that ASR supports both Windows and Linux. Now, before we jump into a demonstration environment to take a look at how we can perform this replication and configure failover, let's have a chat at a high level about the different components of Azure Site Recovery. So first things first, we have something referred to as replicated items. This is where we're talking about the workloads from our source environment that we actually want to replicate to a secondary location. This is our primary solution that we want to configure disaster recovery for. Now, for our replicated items, Azure Site Recovery actually provides some functionality to group these items in case they have some meaningful grouping that we need to use. So you might have a solution, for example, that's made up of app servers, SQL servers, web servers, and it may be important that all of those virtual machines are replicated in a specific way. Maybe your solution is not going to work unless they all get backed up, they all get replicated to the secondary site at the same sort of time. That's where we can use something referred to as multi-VM consistency. So when we've established our replicated items, that can be on-premises, Hyper-V, VMware, physical servers, and so on, we then need to configure replication policies. That's where we go and say, how often do we want our servers to replicate from the primary site to the failover site? With Azure Site Recovery compared to something like Azure Backup, what we are focusing on is having really granular recovery point objectives. So somewhere in the vicinity of 0 to 72 hours. What that means is at most, we only ever want to lose maybe 1 hour's worth of data, 2 hours worth of data, up to 72 hours. We're not really talking about long-term backups here. That's where we're going to use the Azure Backup service. What we're talking about is disaster recovery for an entire site. So using our replication policy, we're going to go and configure the recovery point objectives and retention. And what's going to happen then is our data is actually going to replicate to cache storage. If we need to initiate a failover, that cache storage can be used to actually go and create our environment within Azure. Now, whilst I am continually saying our destination environment is Azure, it is worth highlighting that ASR can be used to actually have a secondary site, a disaster recovery site that is also on premises or maybe even in another cloud. But throughout this lesson, we're just going to work on the basis that our recovery site is within Azure. So what we've established so far with replicated items and replication policies is that we have a primary site and we have a failover site, and we want to replicate from the primary to the failover in a regular basis. But what actually happens if disaster strikes? This is where ASR's recovery plans come to the rescue. Recovery plans are really focused on getting us back online quickly in an automated fashion. So within the recovery plan, we might, for example, say we want to fail over the SQL group of servers, then the application servers, and finally the web servers. And within our recovery plans, we get the ability to have pre and post tasks, and they can actually be both manual and automated. Because when you're having a major disaster strike your primary site, you may actually have some manual tasks that need to be undertaken by humans. So as part of this recovery plan, you can have both automated tasks and manual tasks. And this is all focused on reducing your recovery time objectives. In other words, how fast can you get back online after disaster strikes? So now that we've covered the important components at a high level, let's jump into a demonstration environment I have within both Azure and a Hyper-V environment, and we're going to take a look at ASR in action. Okay, so here we are within the Azure portal, and what we need to do first is take a look at Recovery Services Vaults. Now, you may recall from the backup lesson that this is something that we need for Azure backups as well. Recovery Services Vaults are used for Azure Site Recovery and Azure Backup. So let's browse into Vault 2 that we have here configured, ready to go. And what I'm going to do is I'm going to click on the Site Recovery option. Now, depending on what type of workloads you are protecting, you're going to have to use different types of tools. Fortunately, through the ASR wizard, the Getting Started section here under Site Recovery, Microsoft provide you with guided steps to go and get up and running. So let's go ahead, we're going to click on Prepare Infrastructure, and we're going to get ready to protect a Hyper-V environment that I have up and running, ready to go. So we're going to say that our machines are located on premises, but again, you could actually protect workloads within Azure if you wanted to as well. What we want to do next is we want to say that we want to replicate to Azure. We want Azure to be our recovery site. Again, this could be on premises if you needed it to, but we're going to use Azure in this example, and we're going to say we are not performing a migration, and instead we are going to set up disaster recovery. Now, this is the important last step here. What type of virtualization are you using? Is it Hyper-V on premises? Is it VMware? Or is it maybe just not actually virtualized at some other solution or its physical servers? Depending on the option you pick, that's going to determine what type of architecture you need. Now, even though there are three options here, really the architecture that you use to migrate to Azure is going to look one of two different ways. If you're using Hyper-V, let's actually just load up a quick Microsoft article and take a look at what that architecture looks like. And I'll be sure to include the links for this in the description below. So for Hyper-V, we don't actually require a lot of different infrastructure. If we use Hyper-V, what we're really going to see is that we have something referred to as the Azure Site Recovery Provider, and we have the Site Recovery Services Agent, and this is what we're going to look at shortly. Now, if you are working with VMware, on the other hand, let's take a look at the architecture there. And what you're going to see is that this is the same image and the same architecture that you use for VMware or for physical servers. So if you want to understand the architecture, you really only need to understand these two architectures that we're looking at now. So if you learn about the Hyper-V architecture and you learn about the VMware architecture, then you've really learned all you need to know about the services, the infrastructure, the installation that we need to configure. For VMware and physical servers, there is of course a little bit more that we need to do, but really we have this one server here that can be combined, and it's the process and configuration server used for managing the replication of information from on-premises to Azure. You also have this important component here called the mobility service. Now, the mobility service is going to be deployed across each of the actual virtual machines or physical servers in your environment. That's what helps to capture all of the information from your servers so that it can be replicated across to Azure. The last piece of the puzzle is something referred to as a master target. Now, master target helps in the scenario that we have had a disaster strike, we've failed over to Azure, and then we need to fail back. Now, as this is quite a long lesson, if you'd like to grab yourself a coffee or a snack, feel free to grab a break right now. I'll split this lesson into two, and we'll resume the configuration of Hyper-V within part 2. Hi folks, and welcome back to part 2. Let's go ahead and get started with the configuration of Hyper-V. So we have on-premises to Azure. It's not going to be a migration. We're using Hyper-V virtual machines, but we're not using System Center Virtual Machine Manager. So let's go ahead and click on OK. And you'll see that what we need to do now is we actually need to get started setting up the infrastructure that we just spoke about. Now you'll see the first step Microsoft recommends is something referred to as the Deployment and Planning tool. The deployment and planning tool helps us to take a look at your infrastructure on premises and say what types of things you're going to need in terms of storage and network throughput to actually perform replication from on premises to Azure. We're going to go ahead and skip this and say, yes, I have done it, and click on OK. And these steps are pretty much going to look the same whether you're doing Hyper-V, physical, or VMware. What we want to do first is prepare this source infrastructure. So in my scenario, I have a Hyper-V site. I need to go ahead and click on plus Hyper-V site. I'm going to say we have on-prem Hyper-V and go ahead and click on OK. Okay, so just quickly refreshing that with the Hyper-V site now ready to go, you'll see that the next component we have is the Hyper-V server. Now this is where we actually need to install that Azure Site Recovery provider I mentioned on our actual Hyper-V host. So what we're going to do is we're going to browse across to a remote desktop session where I have the Hyper-V host open, ready to go. Okay, so here I am on my Hyper-V host. You'll see here that we have Hyper-V up and running, and I've got 2 virtual machines. And this is what we're going to configure disaster recovery for using Azure Site Recovery. Now I'm logged into the Azure portal on this host in the same location so that I can go about easily getting access to 2 important things. 1, the download for the Microsoft Azure Site Recovery provider, and 2, the Vault registration key. Now, whichever approach you really take, you're always going to be needing to download some sort of software, whether that's Hyper-V, VMware, or physical servers. And for that software to actually work, you're going to need this Vault registration key. So let's go ahead and click on Azure Site Recovery, and we'll get started with the installation on this Hyper-V host. Let's go ahead and click on Run. We're going to click on Yes for automatic updates and choose Next. We'll leave the default installation directory as is and go ahead and click on Install. Once the installation is complete, we need to register this server. So you'll see we need to use this all-important registration key. So let's click on Browse. We're going to go to Downloads, and I'm going to select the Vault credentials that we just downloaded a moment ago. So we have that there. That's what's going to allow us to securely connect to our Recovery Services Vault. Let's go ahead and click on Next. We don't have a proxy in this environment, so I'm going to choose Next. And you'll see the registration is underway. This is what's actually going to register this Hyper-V host within our site recovery infrastructure so that we can use it, so that we can control it, and so that we can set up the recovery policies and failover policies that we spoke about a moment ago. Okay, the site recovery registration is complete, so let's go ahead and click on Finish. Now, if we scroll back to the Azure portal, let's take a look at the next steps. Okay, awesome. So now you'll see we have both the site and the server ready to go. If you are actually performing these steps in your own environment, just be sure that you go back a couple of steps so that the page can refresh and get the new values. So I'm selecting the host for our site. I'm going to go ahead and click on OK. And then what we need to do is we need to prepare the target. This is our secondary site, if you like, where we're going to perform failover for. So what we want to do is select our subscription, choose the deployment method. We're going to stick with ARM because we shouldn't really be using Classic anymore. And you'll see that the wizard needs to have that storage account for the cache. So we've got that ready to go. We have some networks also. So let's go ahead and click on OK and configure our replication settings. Okay, now we're going through the wizard, so we don't yet have any replication policy. So let's go ahead, create and associate one right now. We're just going to call this replication. You'll see that it's talking about Hyper-V to Azure, and we get to establish a few of those important characteristics with respect to the recovery point objectives. So we can say how often is the automatic copy frequency going to happen. When we configure this replication policy, our source environment is going to be constantly replicating to our destination environment. So let's go ahead and leave that as the 5-minute copy frequency, and then we get to select something called the recovery point retention. This is where we say, when we're replicating this data, how many recovery points do we want to have in case we need to fail back? So for example, we might actually even set this as 24. And what's going to happen when this replication policy is associated is we're going to have that constant replication occurring every 5 minutes, but we will be able to go back and get previous recovery points in case maybe there was a disaster that struck that corrupted our data, and we don't want to use the latest recovery point that we have. So you can actually choose to have more recovery points retained up to 24 hours. Now, for many solutions, it's really important that you consider application consistency. We spoke a little bit about this in the backup lesson. What we're talking about here are things like SQL Server, SharePoint, and other applications where you need to have application consistency. Remember, that's flushing the data from maybe memory on a server to the actual long-term storage. So we're just going to leave this option as 1. We're actually going to set the recovery point retention to 1, and we're going to go ahead and select initial replication to start immediately. So let's go ahead and click on OK. That's going to create our replication policy. Now remember, when we're talking about replication, what we're talking about is replicating to cache storage. So we still actually need to go about saying what's the virtual network we're going to use in case of a failover, and what are those resources and resource groups actually going to look like when we fail over to Azure. Okay, so we've got that infrastructure ready to go. Let's go ahead, click on OK, and click on OK once again. So now that we've configured the site recovery infrastructure, what we now need to do is actually go and say, what items do we want to replicate? So let's just browse into the replicated items section here. And we're going to go ahead and click on the plus replicate option. And we're going to leave the source as default. That's got our settings that we already need. On premises, not performing a migration, using the on-prem Hyper-V site that we just set up. Let's go ahead, click on OK. And this is where we kind of configure, if you like, the mapping from our on-premises environment to Azure. So here's where we're going to say, where do we actually want the virtual machines to end up when we replicate and in the event of a disaster? So we're going to use our existing subscription. I've created a resource group called Recovery RG. We'll use the Azure Resource Manager model. I'm just going to pick a storage account which we use for the replicated caching, so the VM disks. We need to have a network that we're going to use. So we'll choose a recovery virtual network that I've already created. And we of course need a subnet for our virtual machines to actually reside within. So you can see here that what we're doing is we're saying we've got the on-premises servers, we want to replicate the disks to a storage account, and when we fail over, we want to use a recovery virtual network. So this should be a dedicated virtual network that you've configured that actually matches your source environment. So I'm going to go ahead and click on OK, and then we can select the virtual machines. And you'll see the two virtual machines from our Hyper-V host that we looked at a moment ago. So let's go ahead and click on OK. And I'm going to go ahead and say that we have two Windows virtual machines. We're going to stick with an operating system disk. We're going to replicate all of the disks, but you can see you get some additional type of granular configuration if you need that. So if you don't want all disks to replicate, if you had data disks from on-premises, maybe some temporary disks that you didn't need, then you can choose to exclude those as well. For our replication settings, we're going to use the replication policy that we just configured a moment ago. You can see how this modular approach kind of helps us to have different policies for different replication items and yet pull it all together nice and simply. So we're sticking with the copy frequency, recovery retention, and app consistency that we just configured earlier. Let's click on OK. And then go ahead and enable replication. Now, whilst that's loading, the last thing to really be mindful of with Azure Site Recovery are site recovery plans. So let's take a quick look at that. If I click on the plus recovery plan option, what we're actually talking about here is how can we really quickly automate the recovery in the event of a disaster. So let's say recovery plan. We're going to use the on-prem Hyper-V to Microsoft Azure, and we're going to stick with Azure Resource Manager. You'll see then I get to pick the actual items I want to have included within this recovery plan. So let's go ahead and select the VMs that we just replicated and go ahead and click on OK. Now let's take a look at this recovery plan and see exactly what we're talking about. You'll see that for the recovery plan, we can actually go ahead and test the failover, so we could force a failover to occur right now. We could also customize it and add some additional things. So the recovery plan allows us to have additional steps if we require them. We can also group virtual machines if they need to be started in a specific way. So maybe what we wanted to do is we wanted to add a group, and within this group we needed to add some post-action tasks. You can see here, and we can do the same sort of thing with pre-tasks. What we're talking about is maybe kicking off an automatic script or even having some manual tasks that are required before other steps are going to take place. So folks, that's what you have for Azure Site Recovery, a collection, kind of a modular approach to planning massive disaster recovery for your primary site to a secondary site. This is a really powerful solution because really what we're talking about is a major event. If your organization has a primary on-premises location, maybe you need to have all your virtual machines there at the current time, but you want to get started with Azure by having Azure Site Recovery, and you can use that for recovering to Azure from your on-premises environment. That might be Hyper-V, VMware, or even physical servers. And we know that Microsoft provide us a range of different tools for the different requirements. But really what we're talking about is having replicated items, replicate on a regular basis with replication policies, and then in the event of a disaster, we can fail over, and we can do that failover with a recovery plan. So folks, thanks for sticking with me for this long lesson on Azure Site Recovery. I hope you've learned a lot. Thanks for your time, and I'll see you in the next one. Hello folks, in this lesson we're just going to do a quick walkthrough of the Azure Migrate service. Primarily I just want to introduce you to a few concepts and what the service does before we actually get started performing a server and database migration in the upcoming lessons. So Azure Migrate, what is it? Well, really what you're going to come to learn is that it's more about being a centralized management interface then it is a specific thing. It's kind of this location we can go to migrate a range of different resources to different Azure services. But we're not just talking about Microsoft specific tools. We can be talking about Microsoft tools to migrate servers. We might be talking about third-party tools to migrate and assess servers, or we could be doing database migrations with the Microsoft Database Migration Service, even application and data migrations as well. What we're talking about is this central management interface for a range of different tools that help us to assess and perform migrations of different types of things to Azure. So what are those different things that we're going to migrate? Well, really what we're talking about are server migrations. And as you'll see in the portal shortly, we can use Microsoft tools or third-party tools. We're talking about database migrations, data migrations using something called Azure Data Box, and even web application migrations. If you're looking to migrate maybe your on-premises .NET or even PHP applications across to the Azure App Service. So really what we're talking about is this central interface with a range of different tools for migrating things into Azure. Now I haven't actually listed one newer feature which has been added, which is referred to as VDI migrations or virtual desktop infrastructure migrations. That's a really specific use case and we're not going to talk about that within this course, but just understand that feature is also available for Azure Migrate. So if we want to use the Azure Migrate service, well, what does it look like? Let's jump into the portal and check it out. To get started using the Azure Migrate service, you can navigate into Azure Migrate, or you can go ahead and click on Create a New Resource. Now I'm going to create a new resource and let's just call this Migrate. I'm going to create a new Azure Migrate service. I'm going to go ahead and click on Create. What we are doing through this process of creating an Azure Migrate service is creating what's referred to as a project. So you'll see here if I navigate into the different tools on the left-hand side, I actually have this option up here called Migrate Project. Now I've already created a project and that's called Migrate 1. This project is what's going to keep all the different bits of information about the tools that I'm using, the findings from those tools, maybe status of migrations and so on. So this Azure Migrate project is what houses the important metadata about the different migration tasks you're undertaking. So understand that this is a central interface for tracking all things related to migrations, assessment and migrations. If you've already got a project but you wanted to create a new one for maybe other migration tasks you have underway, you can click on Change and then go ahead and click here to create a new Migrate project. If you don't actually have a migration project, then if you followed the steps a moment ago where we clicked on Create a New Resource, this is exactly what you're going to see. We can start off by saying, what's our project name? Let's call this Migrate 2. And then when we click on Next, we can start to take a look at the various different tools that we can use. So if we were performing server migrations, maybe the first step we want to undertake is actually assessing the different workloads we have and understanding costs and so on before we perform that migration. So you'll see we have assessment tools, not just for Microsoft, but even from other third parties as well. So I might choose the Azure Migrate Server Assessment and go ahead and click on Next. Then I can actually use a different migration tool. So you'll see that maybe I want to use Carbonite perhaps for my migrations, even though I'm using the Azure Migrate Assessment tool for the assessment. Let's just go ahead, click on Azure Migrate Server Migration, go ahead, click on Next, and then click on Add Tools. So what this is doing is this is creating that migration project, Migrate 2, that's going to house information about the tools that we're using and data that the tools will actually find. You can quite easily just click on the Change option once again and switch between projects depending on what project you're actually working on. Also, if you didn't add any assessment tools earlier, you can navigate into the migration goals on the left-hand side, and you can check out the other assessment tools as well. If you want to add one of those, simply click it, click on Add Tool, and that will be added to your migration project. Now, depending on the tool that you're actually using and the migration that you're performing, you're going to have different tasks that you're going to need to undertake. We're going to take a look at server migrations and database migrations in a dedicated lesson coming up shortly. But similarly, if you needed to perform VDI migrations, you're going to add a tool, add the tool for the assessment, and for VDI we have to use a third-party option, but for the migration we can choose the Azure Server Migration tool to actually perform that migration as well. So I might just go ahead and cancel out of that. And you'll see we have web apps in case you need to migrate a application across to Microsoft Azure App Service. Just understand that the supported workloads currently are only Windows applications, .NET apps, and PHP apps. When you perform the migration, what we're talking about is migrating to the Azure App Service. And last but not least, we have the ability to migrate data. So if we have a look at DataBox, we're talking about a very specific service here called Azure DataBox. This is where you might have lots of data on premises. Maybe you don't have a fast connection. Maybe you're talking about remote sites with lots of data that you need to import into Azure. This is where we can use Azure DataBox. For Azure DataBox, Microsoft is actually going to ship you some physical hardware. You can then upload your data to that hardware, ship the hardware back to Microsoft, and they'll connect it to a data center for you. Well, folks, that's all there is to it to this quick introduction to the Azure Migrate service. In some upcoming lessons, we're actually going to look at server and database migrations in more detail. Thanks for your time. I'll catch you there. Alrighty, let's get started. In this lesson, what we're going to do is actually perform a migration using Azure Migrate for servers. To do so, we know that the first thing we need to have is a Azure Migrate project, and that's going to help us assess our on-premises environment for migration to Azure. That's going to house the important data about assessments, migration activities, and so on. Now, when we work with the Microsoft tools for assessing and performing our migration, one of the first things that we need to do is use a discovery appliance. And we'll take a look at this in the portal shortly. This is where we actually deploy an appliance to our on-premises environment. That's going to help to assess the on-premises servers in terms of any compatibility concerns, maybe the costs, that sort of thing. And then once we've got that assessment complete, we can jump ahead to the migration. Now, what you're going to see with the migration is we don't actually have to perform discovery and assessment if you don't want to. You don't have to have that first assessment tool. You can just use the Microsoft migration tool, and that's going to use some software to actually take a look at what you've got and then perform planning. So let's jump into the Azure portal and check this out. Alrighty, here I am in the Azure portal. Let's go on and hop into Azure Migrate, and we're going to take a look at the server migration goal. Now you'll see we're in the Migrate 1 project, which I had already created, and I've added the Microsoft Assessment and Microsoft Migration tool. If this doesn't look familiar, then be sure to jump back to the previous lesson and check out the Azure Migrate overview. So what we want to do first is we're going to start with the assessment tool, and we're going to perform discovery. Now, to perform discovery, we need to do so using an appliance or actually import some data using CSV. We're going to go ahead and do so using the appliance, and you'll see similar to Azure Site Recovery and other Microsoft services, we get different options depending on the workloads we are working with. Now for the discovery component, we have support for VMware with vSphere, we have Hyper-V support, and you are now getting preview support for not virtualized or physical servers. This previously wasn't the case, so this is quite a new feature. In our scenario, we're going to use Hyper-V, and what we want to do is assess an on-premises Hyper-V host, which has a couple of different virtual machines running. Now to do so, what we need to do is download and install the Azure Migrate appliance. So let's hop on over to our Hyper-V host, and we're going to check this out now. Okay, you'll see I'm logged into my Hyper-V host. If I take a look at the Hyper-V manager, I have a few different virtual machines running. 2 of these virtual machines are those that we want to migrate across to Azure, but one of them is the actual appliance. So if I navigate into the Azure portal, you'll see I've come along to the same steps that we were just taking a look at. I've downloaded the Azure Migrate appliance, and I've already deployed that to my environment. Now it's going to be quite a similar experience if you're using VMware as well. The point here is that we use a Azure Migrate appliance that's on our host infrastructure that can help us with the discovery of machines we want to migrate. So I've already deployed this, and if you are following along at home, just make sure you've gone through the additional steps of actually completing the configuration of that appliance. It's really simple. It's just a case of starting up the appliance manager, which more often than not will start when you connect to the machine, and allowing it to go through the steps and perform any updates if they are available. What you're going to need to do next after you've completed the initial prerequisite steps is just register this appliance with Azure Migrate. So make sure you go ahead and log in. And then what we can do is we can select our subscription, we can select our Migrate project, and we can give this appliance a name. So I'm just going to call this Migrate Appliance 1 and go ahead and click on register. Well, it looks like we're just going to call that Migrate Appliance because CE1 is too many characters. Okay, so that's registered successfully. Then what we can go and do is click on continue. And I'm just going to maximize this window since it's all over the place. And what we need to do importantly is actually provide some credentials for this appliance to talk to the host so I can go and scan and retrieve information about the virtual machines that are running. Now, if you were performing this in the real world, you wouldn't really want to give it an administrator account. You can actually go and create a service account, and that's probably more better practice. But in my example, I'm just going to go ahead and use my local administrator account, and we'll call that admin. We can save the details, and then we're going to go and scroll down and click on add. So let's go ahead and type in the IP address of the Hyper-V host. I'm going to use 192.168.0.1. Go ahead and click on validate. And let's just see if that has worked successfully. Excellent. Now, if you are following along within a demonstration environment, understand that this step here does require DNS. So if your environment does not have a DNS entry for your Hyper-V host, you will need to add a host record here locally, which you can do so by just going into the hosts file and adding that record manually. Okay, so we've got that record, we have added the host. Let's go ahead and click on Save and Start Discovery, and let's see how everything goes. Now understand that this process is going to assess our host environment, and it's going to feed that information back to our Azure Migrate project. So that can actually take some time. You'll see right here the discovery is initiating, and what I'm going to do is I'm actually going to pause the video right now, and I'll pop back once we're ready to go once the assessment has complete. Okay, so we can see that the discovery has complete. Let's browse back to the Azure portal, and I've already gone ahead and clicked on the refresh button, but if you are following in your own lab, just make sure you click refresh because these assessment tools, remember, are writing to the project, and so you might need to hit refresh to just get an update. So let's go ahead and click on assess. Now you'll see there that we can find the virtual machines on the Hyper-V appliance. But what we want to do as this next step is the actual assessment. So what we've completed so far is discovery. We now want to perform an assessment. Let's say assess-on-prem. And what we're also going to do is we're going to create a group. We're just going to call this app1. So let's say, for example, we had an application and within that application, there were 2 virtual machines. We can create groups just for better visibility, better control, and so on. So let's go ahead, click on Create Assessment, and we'll take a look and see more information about what the cost is going to be to run these virtual machines, whether there's any issues, that sort of thing. Once again, let's go ahead and click on refresh, and if everything is completed, we should see a new option here now as well. Okay, so let's navigate into the assessment that we've just completed, and let's have a look at what we get. You'll see that we've got this assessment here, and we've got a group which contains the virtual machines that we just added. If we actually now have a look at the assessment in detail, you'll see we get more information about a few important things. 1, what is the readiness? Do we have any issues, any concerns with compliance, that sort of thing? And what's this going to cost us to actually run within Azure, both from a compute and from a storage perspective? So you'll see here that what we've focused on so far is the assessment, the discovery, the assessment, the planning, if you like, before we actually perform the migration. So now that we've got this information, what we want to do is we want to browse back to the project, and we're going to go ahead and get started with the actual migration. To do so, let's click on Discover using the migration tool that we've already added. For the virtual machines, we're going to go ahead once again and say yes with Hyper-V. The target region is going to be Australia Southeast. This is where we're saying we want to actually migrate our virtual machines to. So I'm saying, yes, I do want to migrate to Australia Southeast. Let's go ahead and click on Create Resources. Okay, so you'll see in terms of actually migrating machines from our on-premises Hyper-V environment into Azure, similar to Azure Site Recovery, we're going to need the Hyper-V replication provider, Azure Site Recovery provider. So let's browse across to our Hyper-V host and register it with the Azure Migrate registration credentials. Okay, so here I am on my Hyper-V host. I'm already in the same step we've just looked at before. I've downloaded the Azure Site Recovery provider. And yes, I know we're talking about Azure Migrate, but it does use a lot of the underlying same software as the Azure Site Recovery service. So let's go ahead and install this right now. We'll click on Install. And then what we want to do is we want to actually register this with our Azure Migrate project. So I'm going to click on Register. I'm going to click on Browse for the registration credentials. I'll go to Downloads, and you'll see if we sort by date that we have the Migrate credentials right here. So again, yep, a very similar process to Azure Site Recovery. Let's click on Open and go ahead and click on Next, Next, and allow that registration to complete. Okay, so we have our Hyper-V host registered. Let's go ahead, click on Finish, and we'll browse back across to the Azure portal. And what we're going to do is just close this option here, and you've guessed it, we're going to click on Refresh. All right, awesome. Now, if we have a look at the migration tools this time around, you'll see we've got more discovered servers. So let's actually just click on Discover first and foremost and take a look at what we can do. We can say yes with Hyper-V. We can now click on the Finalize Registration option, and that's actually going to finalize the registration of that Hyper-V host for discovery. All right, and that finalization has completed. So what we want to do now is click on Refresh. I'm just going to X this option here on the right-hand side. And then what we want to do is we want to actually get started with the replication of virtual machines. So we're going to go ahead and click on Replicate. Now for our source environment, that's going to be Hyper-V. We'll click on Next. Now this is a really cool part of the actual replication step. You'll see here we can actually import migration settings from Azure Migrate. So since we performed that assessment earlier, it's actually gone ahead, established what VMs we want to use, and given us some recommendations about the configuration. We can configure this manually if we so desire, or we can use the information from our assessment that we completed earlier. So you'll see here, I'm going to use the assessment that we completed earlier, and I'm going to select all of the virtual machines for migration and go ahead and click on Next. Now I need to choose a target environment for this migration, so similar to site recovery, let's just go ahead, use the recovery resource group. We need a replication storage account, and we need a destination virtual network and subnet as well. You can also configure licensing, so if you're using software assurance on premises with your Microsoft licensing, you might want to enable that as well. That's not what we have, so let's go ahead, click on Next for Compute, and you'll see here that we've got some recommendations all ready to go for our virtual machines. I'm going to select the operating system type there just to be sure. I won't deploy these to an availability set, so let's go ahead, click on Next for disks. We'll select all disks to be replicated, and we're going to go ahead and start the replication. Now this, of course, can take a little bit of time, so I'm going to pause the video and we'll pop back once that replication has complete. Alrighty, so it's been a little bit of time now and the initial replication has completed. So if we take a look at replicating servers right now, we'll see both app VM1, SQL VM1 show the status of protected. What this means is that from either here or from the previous option, we can go ahead now and click on the migrate option instead. When you go to migrate your virtual machines from on-premises to Azure, you get the option to either shut them down automatically or not. Now, I really would encourage that you do shut them down as part of this migration, because if you don't, it means that you can't be certain you're going to get the most current version. So let's actually go ahead and give this a try right now. I'm going to click on App VM1. I'm going to say, yes, I want to shut it down, and I'm going to click on Migrate. Okay, and if we navigate across to our Hyper-V host, we can see here that App VM1 has been turned off, and you can see that it's initiating the failover. So the failover is underway. It's being reported back to our Hyper-V host. If we browse back to the Azure portal, we can see the migration still underway. So what I'm going to do is I'm going to pause this video until the migration is complete, and we can take a look and see what has happened. Okay, so that migration is now complete. Let's refresh the page here for our Azure Migrate status. We can get more information from the Azure Migrate perspective, and we can also hop onto the resource group and take a look at what we have. So if we take a look at the overview, you'll see we get more information about what has happened. We have the migration of one server. We've got the replication status with one virtual machine now currently replicating. Let's actually browse across to the home, and what we're going to do is take a look at the recovery resource group. Now, what you see is we've got app VM1. So this is the virtual machine that we have migrated from on-premises using Azure Migrate. So folks, as you'll see, it's really quite simple to migrate machines from on-premises. We can perform that assessment, we can get a view of how much it's going to cost, and then we can replicate those machines and engage the migration. So thanks for your time on this one, folks. I'll catch you in the next lesson. Hello everybody. Once again, we're going to perform some hands-on work with the Azure Migrate service, but this time we're going to work with databases. So let's jump in. First things first, when we are migrating databases from on-premises or from some other location into Azure, what we want to do is start with our Azure Migrate project. We know that's where our important metadata is going to reside and where we're going to see more information about assessment and migration activities. However, things are a little bit different with migrating databases than what we've seen for servers so far. What we want to do first when we want to use the Azure Migrate service for databases is we need to use the Database Migration Assessment. This is a tool that's going to perform an assessment on our databases, and it'll check for compatibility issues and things like that. What we then need to use is something called the Database Migration Service. Now, this is kind of where Microsoft are going to manage some compute resources for you that's going to be responsible for actually migrating the databases from the source to the target destination. Now, that migration that you're going to perform can either be online or offline, depending on which pricing SKU you use for the database migration service. So let's jump into the Azure portal and check this out. Okay, so here I am in the Azure portal, and no surprises, I'm going to jump straight into the Azure Migrate service, and then I'm going to navigate into databases. Now what we're going to do for this demonstration is use the two Microsoft tools, the assessment tool and the migration tool. And you'll see as the first step what we have to do to perform that assessment is download the Data Migration Assessment tool onto our source environment. So let's jump across to a virtual machine that I have running that has our source databases. Okay, so here we are logged into the virtual machine that has our database already installed. And you'll see that I've got the Data Migration Assistant already installed, ready to go as well. What we want to do to get started is click on the plus new option and perform an assessment. Now let's just call this Assess 1. And then we're going to go and choose what type of assessment we want to perform. So you'll see here we can have a source server type of SQL Server, which is what we're going to do, or even AWS RDS, which is AWS's relational database service, in case you want to migrate from there across to Azure. For our target server type, you'll see we get the options of Azure SQL Database or the other type of Azure SQL options, such as managed instances and VMs, or you might even just perform an assessment to migrate to SQL Server. In our example, we're going to choose Azure SQL Database, and then I'm going to go ahead and click on Create. Now, in terms of the assessment we perform, we're really looking at compatibility and if we're going to lose out on any options when we migrate from this on-premises solution across to Microsoft's Azure SQL service. Because Azure SQL itself doesn't actually provide 100% feature parity with Microsoft SQL Server running on a server. For that, you would need to use something like an Azure SQL VM, or if you wanted an approximation of that, you could use managed instances. But Azure SQL, as with all platform as a service offerings, provides a range of different benefits. So if our on-premises database is compatible with Azure SQL, then it might be a great alternative for us. So let's go ahead, click on Next. Okay, then you're going to have to type in the SQL information for your server. This is going to depend on your environment. For me, I've already got this pre-configured ready to go. That's going to be 10.1.1.5. I'm going to look at the SQL Express instance I have, and specifically on port 1433. Similarly, for authentication, that's going to depend on your environment. I'm going to use SQL Server Authentication. So let's go ahead and type in that password. I'll encrypt the connection, and I will trust the server certificate. So then what we want to do is go ahead and click on Connect and choose the actual database source that you want to perform the assessment for. So I'm going to click on the All option here, but I'm just using the Microsoft Sample Database Worldwide Importers. So let's go ahead and click on Add. Now let's actually just maximize this for better visibility, and you'll see what we are doing is we're looking at our local SQL Express instance. We're specifically focused on the Worldwide Importers database, and now I want to go ahead and choose to perform the assessment. Now this assessment is what's saying how ready are we really to move to Microsoft Azure SQL, and if we do, are we going to encounter any issues or any differences or unsupported features. So we can see here that Microsoft has told us a little bit more information about the database, the features we're using, and any types of issues we might actually encounter. This is what we're focused on with the Data Migration Assistant. Now, if we take a look at the compatibility issues, we can get more information specific for that database, and perfect, and there you'll have it, we're ready to go. This database is completely compatible with Azure SQL Service. Now, if we did have a database that had some issues, Microsoft might actually say that they are small changes or they are all the way through to blockers of our actual migration. So with the migration complete, what we're going to do is go ahead and click on Upload to Azure Migrate. So I'm going to choose the Azure option here. Let's click on Connect, and I'll connect into my Azure subscription. Now, once we've authenticated with Azure, we can choose the subscription and we can go ahead and choose the migration project. And I'm going to select Migrate 1 and then go ahead and click on Upload. Awesome, that assessment has been uploaded to Microsoft Azure. So let's browse back to the Azure portal and take a look at the next steps. Now, no surprises here. What we're going to do is go ahead and click on the refresh option just to make sure that the assessment tool has the latest data as per the information that we just uploaded. Fantastic. And now if you have a look at the assessment tool, you'll see that we have assessed database instances, databases, and those that are ready to go for a migration to Azure. Now you'll see importantly here that when we look at the next steps, we're talking about the database migration service. So to actually go and migrate into Azure, this is what we need to use. And this is what I was mentioning in the slides a little earlier on. So let's actually jump back to the home section, and I'm going to go ahead and click on Create a Resource, and we're going to type in database, if I could spell, database migration assistant. Okay, let's actually take that back out. Azure Database Migration Service. This is what we need to use and what we need to create for performing the actual migration. So let's go ahead and click on Create. And what we're talking about now is creating the compute resources, if you like, that Microsoft's going to manage for us to help with the migration of our database. So let's create a new resource. We're going to call this DB migrate -RG and click on OK. Then we're going to give this service a name of DB Migrate 1. And we need to pick a location, so let's choose Australia Southeast. When we create the migration service, you'll see that we get two different options. We can have standard and we can have premium. And if we choose standard, it's actually a free service. Microsoft want to help us to use their services. However, if we choose premium, it starts off as a free service, but will actually cost you money after you've used it for more than 6 months. Now, when we use the premium feature, not only do we get more cores to help us with the migration of our databases, but we get the ability to perform online migrations as well. So if you choose the standard option, you can only perform your database migration offline. If you choose the premium option, you can perform a migration online to help minimize any disruption to your end users. So let's leave this as premium, and we're going to go ahead and click on Apply. What we want to do next is navigate into the networking settings, because understand that behind the scenes, these compute resources that are managing the migration of your data do need to have connectivity to your source environment. Now, for me, I've actually got a virtual machine running in VNet 1 within Subnet 1, so that's where I'm going to position my migration service. However, it is a very real possibility that you will have databases on premises or maybe in AWS that you want to migrate. So just be mindful that you do have the appropriate connectivity to your source environment. So for me, this does the trick. Let's go ahead and click on Review and Create, and then get started by clicking Create. Now, whilst this migration service is deploying, let's jump back to the home, because we do need to consider one other thing. Where are we going to migrate this database to? So if we have a look at Azure SQL, let's take a look and see if I've already deployed something ready to go. Okay, Azure SQL Service, and I already have a SQL service deployed right here. So this is important because we want to go into the SQL Server itself, and we need to ensure that the database migration service can in fact access this database server itself. So what we're going to do is we're going to browse into the Firewalls and Virtual Network section, and we're going to click on Add Existing Virtual Network. We're just going to leave this as the default names, and what we're going to say is that we want to allow VNet 1 and Subnet 1 to have accessibility to this SQL server. If we don't do this, then the database migration service won't actually be able to connect on the network layer to the database server to actually migrate it to Azure SQL itself. Okay, so we have a service endpoint enabled for this subnet. We're going to add this rule. Let's go ahead and click on OK. And what this is going to do is add the rule to the SQL server within Azure SQL. This is going to allow connectivity from the migrate service to actually migrate the database. Alrighty, so what we want to do now is browse back to the home. And once the migration service has been configured and is ready to go, I'll resume the video and we can take a look at actually migrating our database. Fantastic, that migrate service is ready to go. So what we want to do next is click on the plus new migration project. We're going to give this a name of DB migration. We're going to choose the source server as SQL Server, but what you'll see here is that when we actually are now focusing on the migration of a database to Azure, we get a few more options. When we were looking at the assessment before, we were really only looking at SQL Server and AWS RDS. However, when we're actually performing the migration, you'll see there's plenty more options. So the database migration service actually includes support for a range of different scenarios. What I'll do within the description below is include a link to this article right here where we can get more information on the different scenarios. So you'll see currently we have offline migration support for things like migrating to Azure SQL, Cosmos DB, or even Azure DB for different source servers. And if we're talking about online migrations, then we get a similar experience, but somewhat slightly different as well. So just understand that when you're using the database migration service, we are not just talking about Azure SQL. We are talking about the other Azure database services as well. So I'll close this article and I'll include that in the link below. What we want to do in our scenario is choose SQL Server for the source. We're going to choose Azure SQL Database for our destination. And what I'm going to do is for our first step, we're actually going to perform a migration of the schema only. So let's click on schema only migration. I'm going to go ahead and click on OK. And then we're going to go ahead and create and run the activity. Now for our source SQL Server, we're going to use what we did before, which is 10.1.1.5 /SQL Express :1433. For the authentication type, I was using SQL authentication. So I'm going to type in the username SA and I'll enter in my password here as well. I want to trust the server certificate and I'll leave the connection as encrypted. Then let's go ahead and click on Save. Now the next option we need is the target server. This is going to be the Azure SQL database that we want to send our database to. So I'm actually just going to quickly open up a new Azure portal page and we're going to grab that information as well. So we'll open up Azure SQL. We'll take a look at the SQL server that I've already configured. And I'm going to take a copy of that information right there. Let's browse back to the migration service. We're going to paste that in. And for the username, I created an account earlier when I created this database, but you'll need to make sure you enter in the correct details as well. So I'll go ahead, click on Save, and we're nearly there. Okay, so now we can see that we do have connectivity. So everything has been working so far because we are seeing that wide world importers database ready there to go. I'm going to say that I want to send this across to a JLab SQL 01. I'm going to generate the schema from source and go ahead and click on Save. So this is going to be my first step to migrating across to Azure SQL. We'll call this schema migration and go ahead and click on Run Migration. Now, as always, this can take a little bit of time, so I'll speed things up through video until we're ready to go. Awesome, that migration has completed. If we want to get more information, we can open that up and we can see there's a few errors there about the different types of configuration we have available. So let's actually just browse back to DB Migrate. And what we want to do next is actually migrate the database. So let's click on plus new migration project. We're going to call this Migrate DB. We're going to leave it as SQL Server and Azure SQL Database. I'm going to click on Create and Run Activity. We're going to use an offline database migration type. For the source, once again, we're going to go with 10.1.1.5 /SQL Express :1433. I'll enter in my SQL authentication details. We'll once again trust the certificate and click on Save. For the source, I'll paste in those details once again. I'll enter in my administrator account. And then I'm going to go ahead and click on Save. Okay, so we're going to take that database. It's 3.1 gigabytes. We're going to migrate across to JLab SQL 01. So let's click on Save and then go ahead and get started with the migration of this actual database. So you'll see that Microsoft provide that flexibility if you want to perform the schema migration first and so on. So let's go ahead, click on Save. We're going to go and create this migration and click on Run Migration. But that's not going to work until I give this a name. So let's say DB Migrate, and we'll go ahead and click on Run Migration. All right, so there you have it. If I click on refresh, we can get an up-to-date status of the migration. And folks, that's really all there is to it for Azure Migrate with databases. As you've seen once again, Azure Migrate is really about providing that centralized management interface. But unlike when we were migrating servers, when we're working with databases, we really need to use that database migration service to help us out. It's much more than just Azure SQL. As you've seen, there's support for Cosmos DB and a range of different source databases as well. So folks, I hope you've enjoyed this lesson. Thanks for your time, and I'll catch you in the next one. Hey everybody, congratulations, you've made it to the end of the course, and that is definitely a case for celebration. Now throughout this course, you've actually learnt over around 30 different features, so if you've completed this course along with the first AZ-303 course, then you've actually completed a combined total of over around 60 different Azure services. Now, I hope as part of your learning, you've also been using the hands-on labs because that's really a great way to get confidence and skill working with Azure services. And if you're going on to take the AZ-303 exam, well, Microsoft have committed to including simulated exam questions in all Microsoft exams, so it really makes sense that you do get that hands-on experience. Along with the hands-on labs, I've also included some flashcards, so if you would like to test your knowledge, then be sure to check those out. And if you do have any questions or comments or concerns, or if you'd like to reach out and chat to myself, other students or other training architects, then be sure to jump into the community where we can have a chat. Now, the natural question for you is, what am I going to do next? Well, definitely I think you should be celebrating, so give yourself a weekend off, maybe a week off, have some downtime, relax, recharge, and definitely give yourself a big pat on the back for what you've achieved so far. Now after that, you might actually be interested in taking one of the other courses within the AZ-303 learning path. Whether or not you're going on to take the AZ-303 exam, or if you're just interested in other courses, then there is a collection of courses here for you at your disposal. So I'll include a link to all of these courses within the description below. And if you are going on to take the AZ-303 exam, then I would encourage you to either complete all of these courses, or at least be confident that you can work with all of the services we covered across all of the courses. The first course in the AZ-303 learning path is Implement and Monitor Azure Infrastructure. It's quite a large course, followed by this one that we just completed, which is Implementing Management and Security Solutions. Now, the remaining two courses are relatively smaller compared to the first two, but they are still important, and that's where we're going to cover off solutions for applications and data platforms within Azure. So folks, once again, thanks so much for being with me. I've really enjoyed this journey with you, and I'm looking forward to many more courses to come. Thanks again. I'll see you in the next course. Hey everybody, and welcome to this lesson on Azure AD Application Security. Now I know this topic can actually mean a lot of different things to different people when you're working in different scenarios and architecting different solutions. Within this lesson, what we're going to focus on is not so much about things like granting access to applications for our users. Instead, we're going to focus on how we register our application within Azure AD, so we can use that application to interact with other resources that authenticate with Azure AD. So specifically what we're going to do is we are going to focus on how we register an application in Azure Active Directory and what that looks like. We'll also take a look at the permissions we can assign to applications. So for example, you might have an application that needs to access blob storage. Well, how are you going to do that? And finally, I actually want to run through a demonstration of this because it can be a little bit of a hard concept to understand unless we actually walk through a demonstration together. So by the end of this lesson, you're going to understand how we can register an application, grant permissions to something like Azure Blob Storage, and we'll actually run some code to see this in action. First things first, we need to understand what this looks like. When we actually go to register an application within Azure Active Directory, we do so by creating what's referred to as an application object. So for example, let's say we're creating an application that needs to create messages and read messages and delete messages all within the Azure Queue service. Well, what we need to do first is register this application in Azure Active Directory so it even knows that it exists. If we want to grant permissions to this thing to access Queue storage, Azure AD needs to know about it. Remember, Azure Active Directory is where we centralize the management of identity for users, security groups, and applications. Now, when we do register that application within Azure Active Directory, we're going to create something referred to as a service principal. This service principal is specific to the actual Azure Active Directory tenant you're going to use. Now, Microsoft have split out these two items, the application object and the service principal, because you might register your application and then you might actually go and grant access to that application to other people who use Azure Active Directory as well. So when you register your app within Azure AD, it creates an object and it immediately creates a service principal. If you go and create an instance of your application in someone else's Azure Active Directory tenant, it doesn't need to create the app object again. Instead, it'll just create a service principal in their Azure AD tenant and point back to your application object as well. This is primarily for scenarios where you're working with multi-tenant deployments. So you create an application and you might need it to run across other people's tenants as well. If you're not going to do that, well, don't worry too much about this. Just understand the service principal is primarily what we're going to be working with. The last thing we need for our application is something referred to as application secrets. Now, this can be a little bit hard to understand why we have secrets. We've registered our app, we've got a service principal, we assign that service principal permissions to things like blobs and queues and tables and app service and whatever you really want it to have access to. So why do we have application secrets? Well, if you've got this logical representation of your application within Azure AD, when you actually create code, when you create your code to go and do something, how does it prove that it is this logical application? To understand this better, let's have a think about a normal staff member. When you have a staff member, you create their user account within Azure Active Directory. It might be Morty Smith. Now, Morty Smith has a logical user account created in Azure AD, but when Morty wants to log in and prove that he is in fact Morty, well, he needs to go and provide some information. He needs to provide credentials, a username and a password. This is why we use application secrets as well. Your actual application code can say that it is my app 123 or Bob's app 123 or whatever it is. It needs to prove that it is in fact who it says it is. So that's where we have the application code that talks about the service principal. It provides the secret information, it authenticates against Azure Active Directory, and then for example, it might go off and access blob storage. To understand this better, what I want to do is jump into the Azure portal. We're going to register a fictitious application, and then we're going to take a look at some sample code that's actually going to access queue storage, and we're going to see how this works. So here I am in the Azure portal, and what I want to do is navigate into my Azure Active Directory tenant, because this is where I first need to go about registering my application to create an object and a service principal. So let's click on App Registrations. We're going to go ahead and click on New Registration. Now let's just say we have a simple app. We're going to call it My Application, and that's all we actually need to do at this stage. We're going to say this application is only for my tenant. We don't need to worry about a redirect URI right now, and we're going to go ahead and click on Register. Okay, boom, nice and easy. We've got our application. Simple, right? And as I mentioned, the next thing we need to do is actually create certificates and secrets. This is kind of like the user credentials, the password, that sort of thing. So what I want to do is I'm going to create a new client secret. And let's just go ahead and call this secret 1. And I'll say that it expires in 1 year. Now this secret has been created, and this is going to be the only time I can see this value. So make sure if you're following along at home, if you're performing this type of setup, take a copy of that secret and don't lose it. Otherwise, you're going to have to delete the secret and create a new one. What we want to do next is we want to say that my application has access to a storage account so that it can go and manipulate the queue storage. It can send messages and delete messages and that sort of thing. Now, I've already created a storage account for this example. So you'll see I have JLab Store 01, and if I take a look in the Storage Explorer, you'll see that I've already configured a queue. So I'm going to expand the queue option here, and I've configured a queue called Processing Queue. Within this queue, I've created 3 sample messages, just some basic text, my message, hello, that's it. And what I want to do is I want our application, the My App application, to talk to this queue and to read those messages. So the first thing we need to do is actually go about granting that application with access to read this queue. To do so, we're going to navigate into the IAM section, and we're going to click on Add and choose Add Role Assignment. Now, just as if we were working with users, we know that we need to follow the principle of least privilege. So for the role, I'm going to choose a built-in role, and I'm going to type in queue, and we'll choose the storage queue data contributor. That's going to ensure that the app that we register for this type of security only has access to the queue. It can't manipulate tables, files, blobs, things like that. So again, just like a user, we need to select what this service principal is. So we can type in my app, and I can choose my application that we just created. I'm going to go ahead and click on Save, and that's all we have to do. What we've now done is we've logically created an application within Azure AD. We've granted that application access to the queue storage. What we want to do next is see this in action. So let's actually browse across to some sample Python code that I have available to see if we can access this queue storage. Okay, so here we have some really basic Python code where we're going to say we want to connect to the storage queue service. We're going to do so using the storage account that we just created, jlabstore01. But how do we go and actually prove we are who we say we are? That's where we need to use the client secret, client ID, and tenant ID. Okay, once we provide that information, we can go off and read the queue. So to get this information, we need to go back to Azure Active Directory. But what I'm going to do first is just paste in the client secret that we copied earlier, just so I don't overwrite that value and have to create a new secret. So let's browse back to the Azure portal. We're going to go to Home, navigate into Azure Active Directory, and we're going to take a look at those registered applications once again. We'll browse into my application that we just created, and you'll see that all of the information we need is provided here for us nice and easily. So first things first, I'm going to take a copy of the tenant ID, which just represents the Azure AD tenant that I have that I'm using. So latagl.onmicrosoft.com. I've got a copy of that. I'll browse across to the code and I'm going to paste that in. Next, what I need is the client ID, which is the ID for the application that we have created. So I'll take a copy of the application client ID, browse back to the code, and we'll paste that in. So what we're doing here is we're saying we want to connect to the storage account that we just created. We're going to access a queue within that storage account called processing queue, and we're going to confirm that we are my application, the application that we registered. Now using this code, we can then connect to the queue service, and we're going to take a look at the messages within that queue, and then we're going to print them to screen. So let's go ahead. We're going to type in Python, and I'm just going to run this script that I have right here. And if everything goes successfully, this should work. Let's actually just expand the visibility here a bit better so we can actually see the results and if it is working. I'm going to go ahead and press enter. So there you have it, folks. That's how we go about registering an application within Azure Active Directory. The important parts here are that we create that object within Azure AD. We get a service principal. That service principal can be assigned permissions just like any other service principal, for example, a user. And so long as it has those permissions to access a service, we can then create code that uses the client secret information, prove it is who it says it is, and access that Azure-based service. So thanks for your time on this one, folks. I hope you've enjoyed it, and I'll catch you in the next lesson. Hey there, welcome to this lesson on managed identities, where we're going to take a look at a way how we can actually provide identities to our Azure services far more easily than the app registration approach we looked at in the previous lesson. Now, if you haven't already checked that out, I definitely encourage you to complete the previous lesson because we're going to build on some of the concepts that we discussed within that lesson. And really, seeing that lesson helps us to see exactly why managed identities is a great way to secure our identities for our solutions. When we're using managed identities, what we're talking about doing is essentially providing an actual identity for our Azure resources through the Azure platform itself. So think about in the past lesson how we went and we registered an application and we had to get the secret information, we typed that into our code, and that was how we really established that identity for our applications. Well, with managed identities, you don't need to store that secret information within code. Okay, instead of that, you let Microsoft manage the underlying security and credential information for Azure resources. Now there's support for various different Azure resources, so let's have a think about some examples. Maybe you're using a virtual machine and you've got some scripts that are running there using Azure CLI or maybe using PowerShell, and it's going to interact with Azure management to maybe go off and stop virtual machines, start virtual machines, create virtual machines, and create other resources. If you want to do something like that, you're going to have to somehow give your script on that virtual machine credentials to do so. And then you have to worry about how you are going to securely store that information. Or let's think about the Azure App Service. Maybe you've got some code that wants to interact with queue storage like we saw in the previous lesson. And as we saw in the previous lesson, we know that we have to manage the client secret, the client ID, and the tenant ID. Well, with managed identities, we don't need to do that. For various supported Azure resources, Microsoft can actually manage all of that for you. So what does this really look like? Well, let's have a chat about some key components. Firstly, for our resources, for those that support managed identities, we need to enable a system managed identity or a user managed identity. So that might be for Azure Kubernetes Service, maybe even for Blueprints, App Service, or virtual machines. Now, what we're doing in that step is we're essentially getting a service principal for any resource that we give a managed identity. So unlike the previous lesson, we're not having to go and register a new application or create users or things like that. For a virtual machine, we turn on a managed identity. For an app service, we turn on a managed identity. For any of these things that support managed identities, we simply turn it on, and then we have a service principal within Azure Active Directory that we can use in the same sort of way that we're familiar with. We can assign it permissions to different resources and so on. Now, behind the scenes, this is actually going to leverage something referred to as the Instance Metadata Service, or IMDS. So if you're using virtual machines and you have code or scripts running there, what can happen is that code or that script can actually go about talking to the IMDS. It can retrieve a token to actually go and use to provide some access to other services. Now, when you look through documentation and you first learn about managed identities, you're going to see IMDS mentioned with virtual machines. But really, it's probably more correct to just refer to this as a token endpoint. The point here is that whether you're using a virtual machine, an app service, or one of the other supported services, is that it can then go off to this token endpoint to retrieve an access token. Okay, so it can talk to the token endpoint. The token endpoint is managed by the Microsoft platform, and so it's able to say, hey, yeah, okay, you're a virtual machine with a managed identity. I can see that because I am the platform. So I'm going to give you a token, and you can use that to go and access other services. So with that token, the resource can go and take the token, the identity, and it can talk to supporting services. Just understand that these services that you're going to use this token for must actually support Azure AD authentication. So what I'll do is I'll include a link to a Microsoft article that's going to list out the services that support managed identities and the services that then support Azure Active Directory-based authentication. So in a nutshell, that's what we do. Now, these steps might seem a little bit complex, but really, behind the scenes, this is all very simple. If you had a script running on your virtual machine, for example, let's say it was Azure CLI, well, that script can just say as login -- identity, and it's going to use the managed identity. If you've got code that's running, well, you can very simply use the software development kits available for Python, .NET, whatever it's going to be. You're going to use the Microsoft Identity libraries, and you're going to be able to very easily just retrieve a token to access that service. It is actually a REST endpoint behind the scenes, this token endpoint, but you don't have to interact with it with REST. Like I say, you can use things like the SDK or the various CLI tools to actually very simply get this identity and interact with other services. To understand this more, let's actually jump into the Azure portal, and we're going to walk through some demonstration code and see this in action. Okay, so here I am within the Azure portal, and we have two important services that we're going to interact with. Firstly, we have JLab Store 01. Now, within the Storage Explorer view, we're going to see in the queues service that I already have a processing queue. And you should have already completed the previous lesson and probably have a good idea of what we're going to do. We're going to do exactly what we did within the previous lesson, but we're going to take a look at how much more simple the code looks and how secure it is when we use managed identities instead to actually access this information from code. So the other piece of the puzzle here is that we have an Azure web app that's running, and this is where our code is going to run, that's going to talk to that queue service and take a look at those messages within the queue. So how do we do this? Well, let's just really quickly jump across to some code. When we completed this within the previous lesson, we had three main elements. For the secure connection to the queue storage service, we had to provide the tenant ID, the client ID, and the client secret. And this was all for an application that we registered within Azure Active Directory. Now, what we're going to do this time around is browse back to the Azure portal, and we're going to assign a managed identity to this application. So let's hop on over to Identity, and then all you need to do is click the On option here. Now, I've already gone ahead and done this. So this is the important part of the managed identity settings. When we simply turn on the system assigned managed identity, Azure is going to manage the identity for us. We don't need to register an application within Azure AD. But then, of course, we do need to still do the other component, which is to hop into the storage account and apply the appropriate roles and permissions. Now, if I hop into Role Assignments, you'll see if we scroll down that I have the application we registered in the previous lesson, and I've also gone here and done a similar thing. But instead of having to use a registered application, I've actually got a managed identity that I can really simply use. You can see here we have an app service identity. I've assigned it the same types of permissions we spoke about in the previous lesson, and that's all we need to do. We don't need to register that app. We don't need to manage client secrets. It's really nicely and easily managed by the Microsoft platform for us. So if we take a look at the code that we're actually using this time around, what we can do is we can take a look at how this differs. Previously, we had all of this secret information within the code, which is a security risk. Now, in the new application that I've built, that's really just doing the same thing. We're talking to queue storage, we're displaying the messages, but we've got a web application this time around. All we need to do this time is right here in one single line. Credentials equal default Azure credential. We're just using the managed identity of the Azure App Service web app that we have running. Now, depending on what SDK you're using, what language you're programming in, this will look a little bit different. But the key point here is that we're not storing the secret information within the code. So let's browse back to the Azure portal. And what we're going to do is we're going to jump back to the home. We're going to take a look at this managed identity web app that we're running. And I'm just going to very quickly click on browse and let's see what happens. Awesome. There you have it. We're displaying those messages from the storage service, and we haven't had to store that secret information in code, and we haven't had to register an app with an Azure AD. So as you can see, managed identities are a really powerful and really secure way to provide identity to your applications, to your scripts, to things like that, where you would otherwise have to normally manage an application manually within Azure Active Directory. The key takeaway here is that we no longer have to store secret information within code. It's all managed by the platform for us. Hope you've enjoyed this lesson, folks. Thanks for your time. I'll see you in the next one. Hey folks, thanks for joining me. In this lesson, we're going to learn about the Azure Key Vault service, the purpose it serves, and once again, we're going to jump into the Azure portal and actually test this out using a sample web application. Now for this lesson, it really does help that you've completed the previous lessons within this section of the course because we are extending upon some knowledge that we've built there. The key purpose of the Azure Key Vault service is really to protect secret information for your applications. Now you might immediately be asking the question, well, why do we need to protect secret information? We know that we can use managed identities, and using a managed identity, we don't need to store secret information such as client secrets and so on. Well, it's very possible within your application you have lots of other secret information that you need to store. That might be passwords for third-party APIs, it might be some sort of connection strings, certificates, and other secret information. With the Azure Key Vault service, we're talking about protecting this type of information. Passwords, certificates, keys, that sort of thing. And really importantly, when you use the Azure Key Vault service, it's going to be protected using hardware security modules. And specifically, Microsoft is actually storing this information in compliance with the Federal Information Processing Standards, or FIPS 140-2. So you know that when you're storing this information, it really is going to be stored very securely. Now, Microsoft have built the Key Vault service to provide some additional capability as well, such as certificate and key management. So instead of running your own certificate and key management solutions, you can actually leverage some advanced capabilities from Azure Key Vault. And what we're really talking about here is providing secure programmatic access to secret information for your application. So the Azure Key Vault service itself is actually accessible using REST. So within your application, if you need to store secret information and you don't want to put that in code, this is where we might use something like the Azure Key Vault service. And it's important to know that even Microsoft use this service for things like virtual machine disk encryption. It really is built to store information very securely. So what does it look like when we go and actually build this? Well, there's a number of important components that we need to understand. First, no surprises here, is the Key Vault service itself. When you create a Key Vault, you're going to create a URI for your Key Vault that it can be uniquely accessible from. And understand when you deploy the Key Vault, that's what's actually creating that hardware security module to store your information securely. Next thing, we actually need to, of course, store some secret information. So secrets, keys, certificates, and as I mentioned, you do get some additional types of capabilities to manage keys and certificates as well. Now, if you have your Key Vault set up ready to go and you want to store or retrieve some secret information, you need to understand that we need to use something referred to as access policies. Remember from our lessons on role-based access control, a lot of the time what we were talking about was management layer access to manage Azure resources. Well, don't forget there's the data layer as well. When we're talking about Key Vault, the data layer is secured using access policies. So you might have administrators who create the Azure Key Vault resource, but they don't need to have access to the actual secrets within that Key Vault. This is where we use access policies. Access policies are where we define what level of access we are granting to the data within the Key Vault itself. So as always, I think it helps to understand this by jumping into the Azure portal and seeing more of a real-world demonstration of how this actually works. So let's jump across to the Azure portal now, and we'll check this out. Okay, here I am within the Azure portal, and what I want to do now is create the Key Vault. So let's go ahead and click on Create a Resource, and we're just going to type in Key Vault. We'll choose the first option there and click on Create. We're going to create a new resource group. We'll call this Key Vault 2, as I already have a Key Vault here, -RG, and click on OK. Now for the name, understand that this is going to be used to create you a unique URI that you use to access your Key Vault. So it must be unique. It's like storage accounts. It can't be something that's already in use. So let's call this Jazz Lab KV2, and we'll place this in the region of Australia Southeast. Now for the Key Vault service, there are different pricing tiers. Understand that if you do need support for those HSM-backed keys, hardware security modules, you need to use the premium option here. Otherwise, let's go ahead and use standard for our scenario. That's going to be sufficient. And you do get to configure an option called soft delete. So if you would like to have your keys being protected from accidental deletion, or just have that option to just restore your secret information after it has been deleted, you can configure this thing that's kind of like a recycle bin. I'm not going to use that, so I'm going to go ahead and click on Disable, and we're going to go to Next and choose the Access Policy. Now this access policy is where we go about saying who has access on that data layer. So if I actually go ahead and delete the entry here that has been automatically created for me, I'm not going to have access to create data within the Key Vault or to retrieve data from that Key Vault. So even though I create this service and I might be the owner of the Key Vault itself, that doesn't necessarily mean I have access to the data within it. This is where we use access policies. So let's leave this as default. And you'll see a few other options here at the top as well, because we can use our Key Vault service for things like Azure Disk Encryption or Resource Manager templates and so on. Now, if you'd like to learn more about this, be sure to check out the lessons within the previous course where we cover off things like Azure Disk Encryption. For us, that's all we need. Let's go ahead, click on Next for networking. We're going to leave this as a publicly accessible Key Vault service, but you could actually choose to lock this down if you so desired to use things like virtual network firewalls and private endpoints. Once again, this is something we've covered in the previous course, so if you'd like to learn more about that, then be sure to check that out. For us, let's just leave this as public endpoint, which is the default, and go ahead and click on Review and Create. Okay, validation has completed, so let's click on Create. And once this Key Vault's ready to go, we're going to go ahead and create a secret bit of information within the Key Vault. And then what I want to do is access that from an application. So let's go ahead and check it out. I'm going to click on Go to Resource, and what you'll see on the left-hand side is where we're going to store that secret information. So we could have keys, we could have secrets, or we could have certificates. Let's go about actually just creating a secret bit of information and see how this actually works. So I'm going to click on Generate/Import. I'm going to manually create my own key. And let's say that we had a web application hosted within Azure App Service. And for this web application, we had a third-party API service, and some secret information was required by that API to actually access it. Let's say we wanted to create a secret called API credentials. Now we might need to have a password to actually access this API, so let's just go ahead and I'll type in a pretend value here of password 123. Now that might be all we need in this scenario, so let's go ahead and create our new secret. And what I want to do next is kind of walk through a demonstration of how we might access this information in a secure fashion. So we've stored the secret information that we want to use with our application. How are we going to go and do so? Well, we know that first things first, we need to configure access policies to provide access at the data layer. But let's just go back one step. Let's say that we have an application. It's an Azure App Service web application. And let's take a look at some sample code that we might have. Here you'll see a familiar application. It's quite similar to what we used in previous lessons. Instead of talking to the Azure Queue service, this time I want to demonstrate how we can talk to the Azure Key Vault. So normally you're not going to be displaying your secret information on a page, but in this scenario, let's actually do exactly that. What we have here within this code is a simple Python web application using Flask. And what we're going to do is a couple of different things. Once again, I want to use the default identity. So for our web app in this example, we're going to use a managed identity. Using that managed identity, we're then going to go and talk to the key vault that we just created. And specifically, we're going to take a look at the secret that we called API credentials and see if we can get access to that. Once we've got access to that data, we'll actually display it on a web page so that we can see that this is in fact working. So if we browse back to the Azure portal, you're going to see that what we need to do first is configure the access policies. So I've actually created a web application on the Azure App Service, and I've provided a managed identity for the code that you just looked at. This is something we should be familiar with because it's as per the lessons that we just completed. If you haven't completed those, make sure you do so. So what I'm going to do now is I'm going to click on the Add Access Policy option, and then we're going to go about selecting the principal for our application. So I'm going to type in KV Demo 1, which is the name of the Azure App Service web app that has that Python code running. So I'll click on this option and I'll choose Select. Really what we're talking about when we want to provide access to our key vault is that we must be using an Azure Active Directory identity. So really commonly you are going to see the key vault access actually combined with something like managed identities. Now, if you needed to, like the app registration lesson, you could create an application that has a client secret, and that's how it's going to go and register with an Azure Active Directory identity, and then you could provide that identity with access to this key vault. But understand that that almost does defeat the purpose because you are going to have a client secret in your code for that to actually work. It's much better to combine this with something like managed identities, which, as we know, removes the need for that client secret to be stored in code. So when we configure the permissions, you'll see that we get to configure permissions across the key, the secret, and the certificate, because it's not necessarily the case that you need to provide access to all. In our example, we might just choose to provide access to the secret information, and maybe we only need to get information, and that would actually do the trick in our scenario. However, you might actually have an application that's creating data, that's deleting data, backing up, and so on. So what I'm going to do is I'm just going to provide this application with full access to the entire key vault at the data layer. I'm doing so using the key, secret, and certificate management template, which, as you'll see, has filled out full for all of the different options with certificate, with secret, and with key. So that's all we actually need to do. We've provided the permissions and we've associated that with the service principal that matches our Key Vault web app. So let's go ahead and click on Add. Once I've added those permissions, I then need to click the Save button for that to take effect. Okay, so what we want to do now is we want to browse back to the home and we're going to navigate into the Key Vault demo that I have created called KV Demo 1, which is running the code that we just looked at. What we want to do next is click on Browse and let's see if this works. Awesome. And there you have it. Everything is working as expected. So folks, that's everything we need to know for this lesson on the Azure Key Vault service. The key takeaways are that we use the Key Vault service when we want to have a really secure repository for secret information. That can be keys, secrets, certificates, and we can even get some advanced type of capabilities such as key and certificate management as well. To provide access to the service, we need to use an access policy that's going to grant permissions to an Azure Active Directory identity in order to interact with and retrieve the data. So thanks for your time on this one, folks. I hope you've enjoyed it, and I'll see you soon. Hey everybody, thanks for joining me for this lesson on certification pathways. This is just going to be a quick lesson where we're going to have a chat about how the AZ-303 course is actually structured. So you might have noticed that there's more than one part to the AZ-303 course. We've got parts 1 through 4, and there's even a part 5, which we're going to talk about shortly. Now, the way in which the AZ-303 certification pathway is structured is that we have one part for each of the core modules within the AZ-303 exam. So we have implementing and monitoring Azure infrastructure, management and security, solutions for apps, and data platforms. And each of these parts corresponds to the concepts and the services and how to implement these things that you need to know for the AZ-303 exam. So this directly matches the AZ-303 outline that you can find on the Microsoft website, which I'll include a link to for this lesson as well. So if you are going on to take the AZ-303 exam, I'd definitely encourage you to check out each of these parts because it covers everything you need to know for the exam. So you might be wondering, well, if this covers everything we need to know for the exam, why have we split it up into a certification pathway? There's actually a couple of different reasons for that. Firstly, maybe you don't actually want to take the AZ-303 exam. Perhaps you want to learn more about solutions for apps within Azure. If that's the case, then you can simply focus on Part 3. Another reason is that you might be going on to take the AZ-303 exam, but perhaps you already feel you're a guru in one of these specific areas. For example, maybe you've already taken the DP200 series of courses and exams, and you feel like you know everything there is to know about data platforms. If that's the case, then maybe you want to skip Part 4 of the course. However, generally speaking, for anyone who's going on to take the AZ-303 exam, I definitely would encourage you to check out parts 1 through 4 and make sure you've covered all the services and all the concepts that are included within these courses. Now, definitely, if you are going on to take the AZ-303 exam, it's important to know that we have a Part 5 of the certification pathway as well. What we're going to do within Part 5 of the certification pathway is firstly have a chat about all the key information that we've already discussed across Parts 1 through 4. So this is not about introducing new concepts and new services. It's just about having a look at what we've discussed, walking through some example scenarios, and just walking through some preparation tips for the exam. Certainly, one of the really key important things you need to know about Part 5 is that we include the all-important practice exam. So if you are going on to take AZ-303, definitely ensure you take this practice exam. It's going to focus on the different types of questions and scenarios that you might be asked within the AZ-303 exam by Microsoft. So folks, that's all there is to it for the certification pathway. I just wanted to let you know how this is structured and why. So thanks very much for joining me. I hope you enjoy these courses. Hi everybody, thanks for joining me in this lesson where we're going to have a really brief chat about AZ-303 Part 1. Now, if you're going on to take the AZ-303 series of courses, then it's important just to understand what the different courses include, so what's covered, what topics we discuss, as well as how they actually relate to the other courses. So within this lesson, we're going to really briefly have a chat about AZ-303 Part 1, what's covered, and how it relates to the other courses. So first things first, with AZ-303 Part 1, we're focusing on the Implement and Monitor section of the AZ-303 exam. So the topics we're going to discuss are actually completely taken from the AZ-303 exam skills outline. So this is going to include a range of different things such as monitoring Azure infrastructure, looking at log analytics, Azure Monitor, and other related services, as well as infrastructure such as storage accounts, how we build them, and important properties. Virtual machines and virtual networking is also very important within AZ-303 Part 1, so we'll have a chat about that, as well as automated deployments, and finally Azure Active Directory Identity Services, which is a really key part of AZ-303 Part 1. We'll look at Azure Active Directory and other related Azure Active Directory services. So why does this all matter? Well, if you are taking all of the different AZ-303 courses, which is something I'd encourage you to do if you're going on to take the AZ-303 exam, then you need to know how AZ-303 Part 1 actually relates. I would expect that you're going to take AZ-303 Part 1 as well as all of the other parts. It's really expected that if you're going to go on to take the AZ-303 exam, that you have actually participated in, taken all the lessons and performed all the labs from parts 1 through 4. But really specifically, just understand that what I do expect is that if you do take the other remaining parts, you have all of this knowledge that is discussed within part 1. So those different services and those different concepts from networking, compute, identity, and monitoring are actually all quite heavily used across parts 2, 3, and 4 to differing degrees. Certainly in part 2, there's a really big reliance on concepts and services we discussed within part 1, but also within parts 3 and 4, there is a reliance reliance on things such as monitoring and identity, and even networking and compute in certain circumstances. So if you're going on to take the AZ-303 exam, I definitely encourage you to take all of the different parts and understand that part 1 provides a lot of foundational knowledge that's going to help you in the remaining parts. So folks, that's all there is to it for this really quick lesson on the AZ-303 Part 1 course and how it relates to the other parts. I hope you enjoy these courses. Hello again, and thanks for joining me in this lesson where we're going to quickly have a chat about AZ-303 Part 2. What I'd like to do is just talk to you about what's actually covered within this course and give you an understanding of how it relates to the other parts within the AZ-303 series of courses. So first things first, what is AZ-303 Part 2? Well, this is a course where we're focusing on implementing management and security solutions. This is directly taken from the AZ-303 exam, and it's one of the larger modules on the exam. So parts 1 and part 2 are the two biggest modules on the AZ-303 exam. Now, just like parts 1 through 4 within the AZ-303 series of courses, we're going to focus on topics from the given module of the exam. So for implementing management and security solutions, we're going to focus on a range of different topics. That's going to include migrations to Azure, so using the Azure migration and migration related services, as well as backups and site recovery using Azure Backup and Azure Site Recovery respectively. And we're going to look at some network load balancing, network and application security, and then we're also going to have a chat about governance and policies with services like Azure Policy, for example. So all of these different services and topics that we discuss are directly taken from the AZ-303 exam, specifically from the Implementing Management and Security Solutions section of the exam. Now, how does this all relate to the other parts within the course? Well, as you know, if you've already watched the previous lesson, we firstly have AZ-303 Part 1, which is going to provide a foundation to a lot of the different knowledge that we have within the AZ-303 series of courses. What's important to understand about Part 2 is that yes, it does build on top of that foundation, but it really provides a supporting role in terms of parts 3 and part 4. So parts 3 and 4, once again, I definitely do encourage you to take part 1 because there's a lot of foundational knowledge. Part 2, you are going to need that if you are going on to take the AZ-303 exam, but if you're just interested in how these relate, or maybe you only want to take one of these parts just for your own learning without actually going off and taking the exam and getting certified, then just understand that part 2 provides a bit of knowledge for parts 3 and 4. For example, in part 2, we have a chat about Azure Policy. Now, if you're going on to take parts 3 and 4, we're not going to directly talk about how to use Azure Policy to control apps or Azure Policy to control data platforms, because all of that knowledge is provided through part 2. So just understand that part 2 provides a supporting role. It provides supporting knowledge for things like management and administration. So folks, that's all there is to it for this quick lesson on the supporting course, AZ-303 Part 2. As always, I hope you've enjoyed it, and I'll see you in the rest of the courses. G'day Cloud Gurus, and welcome to this lesson on AZ-303 Part 3, which is one of the supporting courses in the AZ-303 series of courses. So within this lesson, I just really wanted to briefly have a chat to you about what AZ-303 includes and how it relates to the other parts within the AZ-303 series of courses. So first things first, AZ-303 Part 3. Probably no surprises at this stage. You'd understand that what we are doing is we're having a chat about the Implement Solutions for Apps section of the AZ-303 exam. So the topics we are going to discuss are going to come directly from this exam module from the AZ-303 skills outline. Now that's going to include a range of different information for things such as application hosting, Azure Compute, Azure App Service, and so on, and serverless applications like Azure Functions, for example, as well as containerized applications with services such as Azure Container Instances, Azure Container Registry, and even Azure Kubernetes Service. So really this is entirely focused on the different services we can use to host applications within Azure. Now, how is this going to relate to the other parts within the AZ-303 series of courses? Well, realistically, it's actually going to be fairly standalone. Okay, we know from the previous two lessons that have covered part 1 and part 2 that part 1 is for foundational knowledge, part 2 provides some supporting knowledge, But really, when we're looking at part 3, it's fairly standalone, okay? There is some information there on how to operate applications with an Azure Active Directory identity, for example, that might actually help you when you think about part 4, data platforms. But other than that, really, part 3 is very standalone. You definitely should take part 1 to get some foundational knowledge around networking, Azure Active Directory, and so on, because I'm going to expect that you have that knowledge when you take part 3, but otherwise, part 3 is standalone. Now, when I'm talking about all of these courses in terms of supporting, foundational, standalone, and so on, just remember that, of course, to go on and take the AZ-303 exam, I do still expect that you've taken parts 1 through 4, because you'll definitely need to do so, or you'll definitely need to have that knowledge to actually go off and pass the exam. Okay, folks, so thanks for your time in this one. I hope you've enjoyed it, and I'll see you in the next one. Hello once again, thanks for joining me in this lesson where we're going to have a brief chat about AZ-303 Part 4. I'll provide you with an understanding of what concepts are covered, as well as having a chat about how AZ-303 Part 4 relates to the other AZ-303 courses. Okay, so what is AZ-303 Part 4? Well, this is focused on the Implement Data Platform section of the AZ-303 exam. So the topics and services we discuss come straight from the AZ-303 exam skills outline. So we're going to talk about SQL data platforms, NoSQL data platforms, and high availability and replication. That's really going to be lessons and labs that are focused on Azure SQL products, as well as Cosmos DB and Azure Tables. Now, data platforms is one of the smaller sections of the AZ-303 exam, so there's not going to be a lot of time spent within this section compared to, say, Part 1, which is a really large section of the AZ-303 exam. But how else does this content relate to the other parts of the AZ-303 courses? Well, first things first, we know Part 1s and Part 2 are important. Part 1 is going to provide us with some foundational knowledge, networking, compute, and so on. And Part 2 provides us with a bit of supporting content for things such as backups and high availability. So Part 4 otherwise is really a standalone course. Just like Part 3, it expects that you have some knowledge from Parts 1 and Part 2, but otherwise it's pretty standalone. Now, again, with that being said, of course, if you are taking the AZ-303 exam, I do expect that you've done Parts 1 through Part 4 to ensure that you have all the knowledge that is covered across the entire exam. Okay, folks, so that's all there is to it for this quick lesson on AZ-303 Part 4. Thanks again for your time, folks. I hope you've enjoyed it. I'll see you in the next one. G'day everybody, thanks again for joining me in this lesson. We're going to have a chat about AZ-303 Part 5. So what is it, what are we going to talk about, and really how does this relate to the other content? So far, you've probably watched my videos on parts 1 through 4 and thought this all makes a lot of sense. It's directly related to the AZ-303 exam. I can see that each of these different parts, 1, 2, 3, 4, matches an AZ-303 exam outline. So what's part 5 all to do with? Well, part 5 is really about preparing for the exam. So there's not going to be any new content that is being discussed. What you're really going to see is that within the AZ-303 Part 5 course is you've got a lot of preparation material. So first things first, there's going to be a practice exam. The AZ-303 practice exam included within the Part 5 course is going to help you prepare for the AZ-303 exam. It's going to have lots of questions that are built in similar ways to the actual Microsoft AZ-303 exam. So definitely that's a resource I would highly encourage you to use if you're going on to take the AZ-303 exam. But what else are we also going to talk about? Well, what I want to do with an AZ-303 Part 5 is provide you with a bit more of an understanding about the questions you're going to get. So we're going to have a chat about some example questions. We'll actually take a look at the different parts of the AZ-303 exam skills outline and look at how we might build questions for those exam skills that we need to know. And then once we have that understanding of how questions can be built and the different types of ways that our knowledge is going to be tested, we're also going to take a look at some example scenarios. The scenarios are going to provide a bit more information that's hidden away before we come to the actual question. This is going to be similar to use cases that you will see A, in the real world, and B, on the AZ-303 exam. So really with AZ-303 Part 5, it's all about preparation. It's not about talking about new content. It's really about saying, hey, how can we get ready for the AZ-303 exam? What types of questions might we see? What are some example scenarios? And of course, I can't really go through every single possible type of question that you might see on the exam or in the real world. So just understand that what we're doing here is taking a look at the approach that we can use to prepare for the exam. Now, one thing I did want to mention is that this is entirely optional, okay? You don't have to take this content because we're not talking about any brand new content. But realistically, if you're going on to take the AZ-303 exam, I would highly encourage you to take the content within Part 5. At the very least, make sure you perform the practice exam multiple times, but just understand there's nothing new that is going to be covered within this course. So how does this relate to the other parts within the course? Well, really parts 1, 2, 3, and 4, you're going to need to take the lessons, perform the labs, and gain all of that knowledge, because within Part 5, we're just walking through different tips and scenarios to prepare you for the exam, and you're also going to have access to that practice exam to make sure you can test and be ready to go for the AZ-303 exam. No new content, just tips and tricks and tools that are going to prepare you for the AZ-303 exam. Okay folks, as always, thanks for your time. I hope you've found value in these videos to get a bit more understanding of the different parts within the AZ-303 series of courses. Good luck on your learning journey. I look forward to joining you, and I'll see you again soon.